Hello everyone, welcome to this Python programming session. Designed by Guido van Rossum, Python is a high-level general-purpose programming language. Its design philosophy emphasizes code reusability with the use of significant indentation. Python is dynamically typed and garbage collected. It supports multiple programming paradigms including structured, object-oriented, and functional programming. Named after a famous BBC comedy series called Monty Python, Python has slowly made its presence felt in the developer community. Python has various use cases in different domains like data science, data analytics, machine learning, AI, and software development, amongst many more. Stay with us until the end of the session as we discuss some very important Python concepts and discuss plenty of useful hands-on so you are able to build strong foundational knowledge in Python programming. Now, let's move on to the agenda for the session. So we are going to start the session with introduction to Python and slowly move on to Python variables and token. Moving further, we are going to cover Python data types, conditional statements and looping statements. After that, we will cover functions in Python, file handling in Python and Python arrays. And we are going to top the session with interview questions for your interview preparation as well. Make sure you hit the subscribe button and press the bell icon for more such updates on Intellipaat.
So what is Python? Well, ladies and gentlemen, you need to understand that Python is, a very nice programming language to work with at the basic level. And if you're thinking, okay, so what is it used for? Well, what is Python exactly? And all of these questions flooding your mind right now, well, let me answer that. Python is basically an object-oriented language where, all the data is considered to be individual objects and worked with it. So that is what object-oriented basically means. And it's a high-level programming language where, we don't use very complex syntax to work with. It is easily understandable and provides, very high readability as well. So by high readability, what do we mean? Well, high readability makes sure that even a non-programmer or a beginner can basically understand a lot of code when looking through a Python code. Well, it's as simple as that. And Python is primarily used for web development, application development, and much more. We know how much you guys are excited for web development. We know how much you guys are excited for understanding data science, understanding artificial intelligence, deep learning, machine learning, everything. And you guys might already know that Python is used for all of these applications, right? And that there's a reason for that. Basically, Python is known to be the world's #1 programming language. In fact, Java actually had this bragging right of being called the world's #1 programming language, and then Python came in, and pretty much from then on it has remained on the top spot since then. So the next question you might have is Python a new language? Is it an old language? Because if we do have very experienced developers among us who've been working with Java all their life, C++, C# or anything, you might wonder, is Python a new language? Well, not exactly, because Python has been in existence since the 1980s. That's pretty much close to 40 years now. Python is almost a 40-year-old language, ladies and gentlemen. And the most important thing you need to understand is that it gained a lot of momentum. It gained huge popularity in the beginning of the 21st century, and basically since then, as I just mentioned in the previous slide, it has been rising and rising. And here's the person who created Python. His name is Guido van Rossum, and he's an amazing developer. You can check out more about him after the session, of course. And then coming to some quick Python facts that you might know or not know. Well, guys, do let me know if you know any of these. Let's consider Firefox. Firefox has over 230,000 lines of code, which basically calls to the working of Firefox, and it's all written in Python. How amazing is that? 230,000 lines of code of Python for Firefox, ladies and gentlemen. And then coming to Microsoft, of course, they have their own IDE. They call it as the Visual Studio Code, and this is basically used to promote worldwide Python development as well. And you can get pretty much free versions of this, and Python is open source, if you've been wondering. So Python has been used by the community, developed by the community, and implemented very well by the community as well. And then coming to Netflix, did you know that Netflix actually makes a lot of use of Python, especially in the field of data science? Well, everything from automatic image recognition, it might be a recommendation for all the TV shows and the movies we can watch on Netflix, and much more. But do understand that Netflix uses a lot of Python. And then coming to Uber, I'm pretty sure everyone knows about it, and they actually make use of Jupyter notebooks, and they make use of IPython to basically share and store all of the data with respect to the driver client interaction and all the ratings and all of that, and much more. As you can see on your screen, some beautiful usage of Python right here. Well, on that note, let's come to the topic of why one should learn Python. Well, the first point that I would actually tell you guys of why you should consider learning Python is how simple it is and how beautiful the readability is. So what do I mean? Well, here's a simple Java code which basically prints the statement hello world. You know, we've all been in our first stages of programming where the first piece of code we might have printed very well might be the hello world program, right? So here is how you would do it in Java. Okay, so how do we do it in Python? Well, look at how elegant, how beautiful and how simple it looks, ladies and gentlemen. And I'm pretty sure if you had to write code and if you had to start out with, if you're a beginner, you would prefer Python for this. You know, there are no semicolons, it is very much readable, and even if you do not know a programming language, you can understand that print hello world pretty much, you know, probably equivalent to putting out an output which gives out hello world. You know, you can at least take a guess and understand. But then as soon as you look at the Java code, you might be taken aback. You might be like, whoa, what's happening, right? And this is one of the most beautiful reasons why I personally prefer Python and why we have thousands and thousands of developers who actually prefer Python as well. Coming to the next point, I believe it's convenience. Because again, of course, this point applies to multiple programming language out there, but the specialty of Python is that, you know, since it's basically platform independent, you can run it on Windows, you can run it on a Mac OS platform, you know, basically Apple's operating system, and you can use any of your favorite operating systems. You know, in fact, if you want to run Python on a PlayStation, well, you can do that as well, ladies and gentlemen. Yes, on your PlayStation, Windows, Mac OS, PlayStation, and many other operating systems for that note as well. So this, you know, makes it very convenient for the developers, for the people who prefer Windows, and of course for the population who prefer Mac OS to everything else. So understanding this point is very vital at this stage. And next is pretty much cross-language operations. Well, what do I mean by cross-language operations? Coming to cross-language dynamics, you need to understand that Python can talk and work well with all of the languages that already exist. See, for example, there are languages, from C, Java, C++, we have JavaScript, we have languages such as Rust, we have .NET, and we have all of these languages, platforms, firmware, libraries, whatever you want to call it. And basically, Python brings all of this together. And if you are an expert in JavaScript and, you know, you're trying to implement JavaScript using Python, yes, you can do that. Can you run some Java code using Python? Of course. And can you go on to use .NET alongside Python? Of course. Well, as you can see where this trend is heading, well, it is the #1 language of choice for a reason, and I believe this is one of those reasons. So what do you guys think? Head to the comment section and let me know.
So on that note, let us quickly walk you through the procedure of how you can install Python on Windows, guys. It's a very simple and a straightforward process. I've broken it down to a couple of steps and let's go with it together, right? So step 1 is go to python.org and head to the downloads page, and let's do that side by side, guys. So let me head to the Python website. So it's python.org for the people who are wondering. I'll just go to download here. You can directly click on the link there as well. Since we're looking for Windows, Python pretty much detects that it's for Windows. So we already are at the page where we hit the download. So this pretty much forms our second step as well. So let me quickly save it in the desktop. It's about 25 MB if I think. Yeah, it's about 25.2 megabytes. This will take a couple of seconds to download, and in the meantime, let's quickly check out what are the next steps in our PowerPoint slide, guys. So step 2 is again click on the download, which we just did. And guys, as of this video being made, Python 3.8.0 is the latest stable version out there. So that brings us to step 3, guys. Step 3 will pretty much be opening the installer, and we should be presented with this screen. So let's quickly wait for the download to complete, and then we're going to open up the installation box. Hey guys, that took about a minute to install, and we're presented with this screen, which is the installation screen. Just before you hit install now, you can pretty much choose to customize the installation and install it at a place of your desire. Make sure you just click this button which says add Python 3.8 to path. Well, what it basically does is it sets your environment variables and it sets the path variable to Python. So as soon as you hit Python in your command line, you can just start using Python directly, guys. So that's what it does, and it would be recommended that you do this. Even if you would not do this, there would be no problem. There are other ways to launch Python and to use it. But if you are a beginner, if you just want to hit Python and then start out with coding, you can pretty much hit Python to path, guys. And you just hit install now. And this will ask me for my admin password, because we have to install it as an administrator. So let me quickly type in my administrator password and we can work with it, guys. and I just entered my password. So pretty much it should take about I say around 2 or 3 minutes to get the entire setup process done. So in the meantime, let's check out what's step 4. Again, step 4 is check the last option to add it to the path and install, and step 5 is the important step, guys. So we need to verify that our installation has been successful. So for that to occur, we need to make sure our setup completes. So let's just wait a minute and then we can go ahead with the setup, guys. So guys, now the setup is successful. Let me quickly open up command prompt to verify that it has been installed correctly, guys. So if I go ahead and type in Python there, then pretty much Python console is ready for us. So let's type in a sample code, hello world. And as soon as I go ahead and run this, we have the output, guys. So pretty much, well, as of this moment, Python 3.8.0 is the official stable release of Python, and that's what we've been using, guys. So we can check out another code snippet as well, guys. So let me do a equal to 1, b equal to 2, c equal to 3, and so much more, right? So let us create a new variable d and then probably add a and b to it. So let me just quickly do this. We can print d. Well, d is 3. Let's multiply, you know what, let's create another variable, call it e, multiply d and c. Let us print e. Guys, I'm just doing this to just show you that everything is working fine. So 3 multiplied with 3 is 3, and so much more. To just get out of the console, you will have to type quit followed by parentheses, and you're out of there, guys. So this is as simple as installing Python on your Windows, guys. And we just verified it using a simple piece of code as well, guys. But Python has another thing called as idle, guys. So idle is this pretty much interactive Python console that you can go about using. And the shell is actually ready. So we can go about typing again, hello learners, and done. So the Python 3.8.0 works perfectly on the idle shell as well. So this is another way to just verify the installation, guys. So coming back to the presentation, step 7 is again an optional step, but you will get there very soon in case even if you're a beginner or an advanced learner, guys. So install the libraries that you pretty much want. There are many libraries that Python supports, and the most popular ones are TensorFlow, NumPy, SciPy, Scikit-learn, Pandas, Matplotlib, Keras, PyTorch, LightGBM, and so much more. Well, these are machine learning, deep learning oriented libraries that are present on your screen. But then the next step of installing Python is to pretty much install all of the packages and libraries that you want to go work with further on, guys.
Now we have Python variables. So this is the first thing that we're going to learn about when it comes to Python. So what are variables? Let's take a look at them. A variable is simply a container. It contains some value in memory. A variable points to a memory location where the value that you want to store is stored. So in Python, the data types will be identified according to the data we provide. And I'll show you what that means in a moment. A variable should start with a letter or an underscore and cannot start with numbers. So there are two ways of assigning a variable. You can assign a single value and you can assign a multiple value. So before we begin, let me just show you what you can do and how you can execute some Python. Now, since I'm showing you some really common tasks, I'll be doing it in the shell. Now, shell is not the way to write code when you're writing code for large applications, but when you're trying out small things and you're trying to understand how these things work, what will be the output of one command or the other command, shell is a great environment to work in. So I'll show you how I do it. So I go to the start button, I type Python, and it opens Python 3.7. So I open this and it's here. So now let me just show you what I mean. So the first bit of code that I would like you to write is you should, let me just make a change to this so that you could see it properly. So the font size, I'm going to increase it to 28 so that you could see it properly, and click OK. Hopefully it's visible. So what I'm going to do now is, now I can type any code that I want to write. So I will type print, print. Print is a function that will take in something that I want to print on the console. A function always gets called with these parentheses, opening and closing, and two quotes. Inside it, we're going to write hello world. Hopefully you're writing it with me, and once you're done with this, press enter, and as you can see, it got printed on the screen. Now, why did we have to put quotations here? Why did we have to put the the parentheses there. We'll discuss all of that in a future video. But note that you've written your first line of Python code, and it was really easy. You only needed to write one line of code, and it did something. So many languages require you to line like 15 or 16 lines of code for it to just print something on the console. But here we were able to do it with just one line. This is one of the major advantages of using Python. Now we come to data types. So as we have already discussed in Python variables, the data type will be identified according to the data that we provide. So what exactly is a data type? Well, data type is basically something that allows us to understand what kind of data are we storing in a variable. Let's say that I want to create a variable named name, and I want to store some name. Let's say the name is John. Now I want to check what data type it is. I press type name. So it's a class of type string. So it's a string. A string is nothing but just some characters strung along. So it could be a sentence, paragraph, basically any text that you need to store, you store it in a string. If you want to store it in one continuous long line of text, you do it using string. Now that is done, there are many other kinds of data types as well. Let's say that you want to store a whole number, a number which has no fractional point. You use integer for that. To give an example, let's say num is equals to 1. As you can see, 1 has no fractional part to it, it's a whole number. And I press enter, and if I look at the type of num, I get integer. So integers store numbers with no fractional part. On the other hand, if I want to store some fractional part, let's say 1.5, and I check the type of num now, it will be changed from integer to float. Float is something that stores fractional part. So if you wanted to store the value of pi, you would store it in the type float. Now you don't have to define what kind of type you will be using, because Python takes care of it for you. This is what is known as duck typing. Duck typing basically means that Python takes a look at the class and performs the functions accordingly. So it will take a look at the value that you are pointing to, and it will take a look at it and understand that okay, it's a number which is floating point, so we can just use it. So we can just assign a float class to it. Now the main question is, why do we need to use different kinds of data types? Well, there are many reasons. The first and the most important reason would be that types are important for us to distinguish between different kinds of data. So we can, for instance, add two numbers. So 1 plus 1 will give us 2. If the computer does not know what kind of data it is and it tries to add it, it will have no idea how to perform it. So let's say that I gave it, instead of 1 plus 1, I gave it B plus C. So what do you think will happen in this scenario? So if you want to take a guess, pause the video for a moment, think what's going to happen, and then resume it. So what's going to happen is it's going to concatenate this string. As you can see, it just took B and added the next string to it. I could even make it a little bigger. B, let me just do it this way. BSDA and CSS, and as you can see that it added it to the it added those two strings together. Now if this was not string, and if I were to use a number, again, what do you think will happen? We get an error. So this is where we use it, because adding a string and a number, let's say that you were giving an exam and they say add a plus 15, that would make no sense, and the computer will have no idea how to process it. It won't have any understanding of whether it should add two numbers, whether it should convert it to string, whether it should do something else. So for computer to be able to comprehend the kind of data that you're giving it, data types are used. And there are many other reasons behind it as well. Another reason being determining the size of the variable. So if you have a string, the size of the string is determined by the number of characters it holds. If I have a string called ABCD, it will have 4 bytes. It will be occupying 4 bytes. On the other hand, if I have a number, it will be occupying 2 bytes or 4 bytes, depending on the kind of interpreter you have in the language and the environment you have. So this also allows for computer to understand how much memory to allocate for a specific variable. This is why we use variables like this. So hopefully it's clear to you. So let's move on. So now we'll take a look at how to assign values to a variable. I've already given you a little taste of how that happens, but let's take a look at this. So we can assign a single value, or we could assign multiple values. So let's take a look at how that works. Let's say that I want to assign, as I've already showed you how I do that. But let's just do it again. Let's say that I want the age. I want to store someone's age. Let's say they are of age 25. I press enter. This is assigning a single value to a variable. So I'm assigning 25 to age. If I were to type name, comma, age n equals 25, this is going to show me an error because it does not know how to unpack this value. This is just one value and I'm expecting two values. Now if I were to move ahead, instead of doing this, as we've already seen, the naming conventions are also there, so you can't name a variable with that begins with a number. So if I wanted to name something underscore name, that would work just fine. As you can see, this is fine. But if I were to start it with anything other than underscore, let's say dollar name, or even if I were to start it with an integer number, this is also going to cause an error. So anything other than a character, which is anything from A to Z, whether it's small or big, and anything that is not underscore is going to cause an error. So always make sure that you're assigning the variable names correctly. Another thing that you can do is naming a variable. The variable cannot start with a number, but it can end with a number. So if I were to say name 1, this will work just fine. And if I were to say name dollar, this is going to cause an error because dollar already holds a value in Python language. So it's a token, which we'll discuss in a later video. So make sure that you are naming it correctly. And always make sure that you're naming your variables in a way that helps you understand what exactly is it that you're trying to write. You can start it with 2 underscores as well. That will work as fine. No matter how many underscores you are passing it, it's going to work just fine. So these are the variables that we have declared so far. And we have assigned a single value to it. Now let's take a look at how to assign multiple values. So assigning multiple values is also quite simple. As you can see here, if you want to assign one value to a multiple variables, we can do what being done in the first line, which is a equals to b equals to c equals to 10. That means set all the variables on the left hand side, which is a, b and c to 10. On the other hand, if you want to do it, you could do it other ways as well. So we could assign multiple values using the comma operator. So I'll show you how that works in a moment. Let's just see how that works. If I were to go a equals b equals c equals 15, and if I were to print a, it's 15, b is 15, c is 15. Now if I were to change it, I want to assign 10, 15 and 20 to all of them. Instead of doing the equal sign, what I do is I use commas and I tell it okay, a comma b comma c. Now I want 10 assigned to a, comma 15 assigned to b and 20 assigned to c. I press enter. A, b, c. So I have to make sure that I'm using the correct ordering. Order matters here. If I were to use a, b and c, if I were to use b, c and a, then b will be assigned 10, c will be assigned 15 and a will be assigned 20. So make sure that the order matches with the values that you're providing it. Now let's take a look at Python tokens. Alright, so now let's take a look at operators. So operators are just special symbols that are used to carry out arithmetic and logical operations. In Python there are several kinds of operators. So we have all of them listed down here. So the first kind is arithmetic, then there's assignment operator, there's comparison operator, logical operator, bitwise operator, identity operators and membership operators. And we'll take a look at them one by one. So let's move on and see what are arithmetic operators. Well, as the name suggests, we use arithmetic operators to perform arithmetic operations or mathematical operations. Things like addition, subtraction, multiplication, division, modulus and exponentiation. So addition basically adds two numbers. So we can add 6 plus 5, in which plus is the operator and 6 and 5 are the operands. Similarly, we can subtract, we can multiply two numbers, we can divide two numbers. Modulus operators is used to give us the remainder. So if I were to go 7 modulo 2, it will give me 1 because when we divide 7 by 2, we get a remainder of 1. And similarly, exponentiation is used to raise a number to a specific power. So for instance, if I were to type 7, then 2 times the multiplication symbol, which is the asterisk, and then I type 2, that means that we are multiplying 7 by itself 2 times. So that's what these operators are for. These are very easy to understand. These are just basic mathematical operators, and they are very commonly used in Python. Then comes assignment operators. So assignment operators, as the name suggests, assigns a value to variable. So let's say I have a variable x and I want to assign the value 10 to it. I want it to hold the value 10. So I could just type x is equals to 10, which is what is shown here. Now there are some extensions to the simple assignment operator, which is the equals operator. You can add a plus right in front of it, and what it will do is it will add more. It will add the number that is on the left hand side of the operator to the right hand side of the operator. To give you an example, as you can see, we have plus equals is the operator, and we type x equals to x plus 2. Let's suppose that before we execute this was already executed. The x is equals to 10 statement was executed, and x contained the value 10. After I run this code, what will happen is will take a look at the number that x holds, which is 10, and it will add 2 to it, so it will become 12. Now following the same logic, we have minus equals. So the minus equals operator is going to do the same thing, but instead of adding 2, it's going to remove the number that's on the right hand side. So x equals x minus 29 will subtract 29 from the already existing number in x and assign that new value to x. Similarly, there's multiply equals, there's divide equals, and there's or equals. So this is basically a binary operator or and bitwise operator, and we'll take a look at that in a moment. And then there's comparison operators. So comparison operators, as the name suggests, are used to compare two values. Let's say that I have two values that have been entered by the user, and I want to compare the values in them. So this is where this comes into play. Now let's say that you have a login form and the user enters the registration name, the registration number, then they enter their password, and just to make sure that they have entered the correct password, you have a confirm password field as well. So when you're validating the form, you need to check whether or not password in the password field and the confirm password field are equal to each other. So this is where the double equals come into play. Now the reason why we have two equals and not one is because one equals is used as assignment operator. The operand on the left hand side gets assigned the value on the right hand side. Here we are comparing the two values, so operands on both the sides will be compared to each other. Then just the opposite of it would be the not equal operator. The not equal operator is used to check whether or not an operator or an operand is not equal to something. So if I were to go and check whether 1 is not equal to 2, since 1 is not equal to 2, it will return true. Similarly, we have less than, we have greater than, we have less than equal to, and we have greater than equal to. And their names are quite easy to understand as well. They check whether or not one value is less than the other value or not, or whether it's greater than or not. Then there's logical operators. So logical operators are used to combine conditional statements. So if I want to check whether or not some condition is true and the other condition is true as well, then I use AND. It will return true if both the statements are true. Similarly, there's an OR statement. OR statements are used to check whether or not something is true or not. Let me just show you by an example. So if I were to use Python, I'm going to show you some Python code here. So let's say x is equal to 15 and y is equal to 16. Now if I want to check whether x is equal to 15 and y is not equal to 16, so what I can do is I can just check s is equal to 15, it returns true. Y is not equal to 16 and it returns false. Now if I want to check if both of these conditions are true, so then I can just type and y is not equal to 16 and I press enter, and it returns false because one of those conditions is false. So that is the problem, because y is equal to 16. Now if I hit this, then it will return true. So I'm checking whether x is equal to 15 and y is equal to 16. If I were to change the value of x to, let's say, 14 and check this condition again, I'll return false. Now the OR operator is actually a little different. If I were to use, instead of AND, I use OR, what will happen is it will check whether x is equals to 15, which is clearly false here, and it will check y is equals to 16. If either one of those statements evaluate to true, it will return true. So since y is equal to 16, we are getting true. But if I were to check if y is not equal to 16, since both the statements are false, it will return false. So basically what we're taking a look at is if we want to check whether all the statements are true, then we use the AND operator. If we want to check just one statement is true out of all the statements that we have provided, then we use the OR operator. And the NOT operator is used to simply revert the statement. So if I were to check 10 is not 10, 10 is not 10, it's going to return false because 10 is 10. But if I were to check 10 is not 11, then it returns true. So I'm just checking for the opposite operator, and that's going to work. Now let's move ahead. And then comes bitwise operator. So bitwise operators are a bit difficult to understand, so let me just explain using Notepad. So underneath the hood, inside any computer programming language, numbers are represented, or any value is represented using binary. So binary is basically just some combination of zeros and 1. So when you hear something like integer can hold 32 bits, basically what it means that it has 32 zeros, 32 positions that can be filled with either 0 or 1. And any value that we see on the screen is due to some combination of 0 and 1 in those 32 positions. To give you an example, let's say that I have a 4-bit number. 4-bit number means 4 binary digits, number formed by 4 binary digits. So I will have this will be 0 since all the 4 numbers are 0. Now what we're doing is I want to check if in case you don't know anything about binary numbers, I can give you a really quick refresher here. Each position is represented by 1, 2, 4 and also so there. So 4, 8, 4, 2, 1. So what happens is if each position, let's say, so these are the positions that we have. We have 4, 3, 2, 1. So if any of these numbers is turned to be 1, then that number is raised to the power of 2. Let me give an example. If let's say this was 1 and this was 1. If this was the binary number that we had, which was 0, 1, 0, 1. So the way we do this is we take a look at it and we go 2 raised to the power of 4 and you multiply it by the binary digit that's there, which is 0. And we do the same thing for all of them. So if I was to do the same thing to all of them, let's just do this. Now we will go 2 raised to the power 3 and the number at the third digit position is 1. Then 2 raised to the power of 2 and the number should be 0 and 2 raised to the power 1. 2 raised to the power 0, sorry. This would be that. This would be 0th position and first position. So all we have to do is just go 1, 3, 2, 1 and 0. That will work. So this should be 3. This should be 2. Should be 1. This should be 0. And we multiply it by 1. So as you can see, the number at the 0th digit is 1. So we multiply it here by 1. Then at the first position is 0, second position it's 1, and the third position is 0. So what ends up happening is we end up creating this sequence in which we go 2 to the power of 3 is 8 multiplied by 0 plus 2 to the power of 2 which is 4 multiplied by 1 is 1. Then we go 2 to the power of 1 which is 2 multiplied by 0 and we go 2 to the power of 0 which is 1 multiplied by 1. And this ends up giving us 0 plus 4 plus 0 plus 1 and we get 5. So this might seem a bit complicated, but that's how the numbers are calculated underneath the hood. You can take a look at some binary refresher that will take you look at what it means. Now because we only have 4 places to put zeros and 1, since we have 4 digits, we could go from a number that has all zeros to all 1 and everything in between. This could end up in numbers ranging from 0 to 16. So if we have 4 binary digits, then we can make numbers, we can represent numbers in binary format ranging from 0 to 16. Anything above that, we have run out of space, we can't do anything about that. 0 to 15. So that's how we will do it. And anything in between, any configurations like 1, 0, 0, 0 could also represent some number between 0 and 16. Now we come to bitwise operators. So what they do is they, instead of operating on the numbers that we see, they operate on their binary forms. So let me give an example. We have an AND operator. So what AND does is, if I were to give you 0 and 0, it will return 0. Similarly, 0 and 1 will return 0. 1 and 0 will return 0. And 1 and 1 will return 1. So what it does is very much like the AND operator that we had taken a look at previously in the logical operators section. It takes a look at all the operands. In this case, we have two operands because it's a binary operator. And we take a look at the left operand and the right operand. And if both of them are 1, then we get 1. If either one of them or both of them are 0, then we get 0. So this is what it looks like. Similarly, for OR, what we end up doing is, just as we did in the logical operator, just one of them need to be true. So 0 could be considered false and 1 could be considered true, and then we'll get the value. So since both of them are false, both of them are 0, we get 0. 1, we get 1. For the second and the third one and all of them, we get 1. So as you can see, this is what the operators do, the binary and binary OR operators. XOR is a bit special. So XOR is used for exclusive ORs. That means both of them should not be same. Either one of them has to be 1, but if both of them are 1 or both of them are 0, then the value that is returned should be 0. These are exclusively used in the building of logical gates and all that, but they are also used very much in programming. And there are some very nifty tricks that you can do with binary operators that could allow you to create more efficient programs. So do take a look at them. So these are all the operators that we have studied so far. Let's take a look at left shift and right shift. So what left shift does is, let's say that I have a number like this and I want to shift it by 2. So this number represents 1. Now what I do is I want to shift, I go left shift 2. This basically means that whatever number we have, shift it to the left by 1. So what happens is, it will shift all of these zeros by 1 and pad the left part with 0. Basically move it to the left hand side by the positions that I have. So since I have given 2, it will do it twice. So as you can see, first one was at the 0th position, then it was shifted 2 times. So now it's 1 and 2 in the second position. And from 1 we have come to 4. Right? So that's how this works. So this is what the operator, left shift operator, does. It takes the binary format and shifts it by 2. Now on the other hand, we also have right shift operators, and it does exactly the same thing, but it does it in reverse. So if I were to give it this and just change the left shift operator to the right shift operator, it will give me back the original result. It will give me back 0001 because it will shift these two to the left. There are nothing there, so it's removed, and add 2 zeros at the beginning, and we get this. We remove this and we get this. So this is what the binary operators do. Binary operators work on the binary format. They shift it to the left, they shift it to the right, and at the very end, let me show you what the NOT operator does, because this is very something that's not shown very accurately. NOT operators turn the number from turn all the bits from 1 to 0 and 0 to 1. So if I were to give it 0001, and if I were to use the NOT operator right in front of it, what will happen is it will take a look at all the binary digits and it will flip them. So if it's 0, it's converted to 1. Again, it's 0, convert to 1, 0, convert to 1, and 1, then convert it to 0. So essentially, we are just converting the numbers. Now, when you do use it, make sure that you understand how the signs work. So in binary format, all the numbers that are stored in the negative numbers, there is a few nifty things that go on in the background. So make sure that you understand how the signs work, and when you shift the numbers, their binary representation will flip. So all the numbers that are 0 will convert to 1, and all the numbers that are 1 will be converted to 0. So that's how the binary operators work. They are very easy to understand once you understand the basics of how binary works underneath the hood. And you can do some pretty powerful and pretty efficient things underneath the hood when you understand the binary digits work. So let's move on. And then we have identity operator. So what identity operator does is it's used to check whether the object that we have is the same or not. Let me give an example. So if I were to open Python and I were to use the ID method and I were to pass it a number 1, you see this long number, this is what's called the ID of the object. Since Python is an object-oriented language, numbers are represented as a object of integer class. So if I were to try to figure out what the type is of 1, I'll get class of integer. So if I were, and similarly, if I were to check type of 2, I get this. And if I were to get the ID of 2, it's this. As you can see, these two numbers, the ID of 2 and ID of 1, are not similar. Similarly, when you create your own classes, you create your own objects, they have their own IDs as well. This is used to differentiate between two objects that have almost the same structure, but still there are two separate objects. So if I have two different kinds of strings or two different kinds of numbers, let's say I have 11, and I check the ID of this, it's this. And this is this. So as you can see, both of them have 11 and they don't have the same ID because strings are immutable. So as you can see, these have the same numbers, 1818752 and same. So these are used to check whether the ID of two objects is same or not. So if I were to check with the is and is not operator, if I were to check 1 is 1, since both of them have the same ID, it will return true. But if I were to check 1 is 1, it will return false. So this is what happens with this. If I were to check 1 is not string 1, then it's true. So that's how it works, and this could also be applied to objects. When you're learning object-oriented programming, you can create your own objects, and then you can take a look at that. And then comes the membership operator. Now this is also very quite useful, and I think Python has it and many other languages don't. So it's an operator that allows us to check whether or not a number is in a sequence or an object. So to give you an example, let's say that I have a list of numbers. So I have 1, 2, 3, 4. Okay, I have 1, 2, 3, and 4, and then nums. So I have 4 numbers in a list. Now, if I want to check whether a number, let's say entered by the user, is present in this list or not, then I can simply, instead of just going through each, running a loop and then going through looking at each number, going is 1 equal to the number that the user entered, is 2 equal to, is 3 equal to, is 4 equal to that number, I could just make Python do it easily by typing 4 in nums. Let's say the user entered the number 4 and it returns true because 4 is present. If I were to check 8 in nums, it will return false because 8 is not present in the string. But if I were to add it and then take a look at nums, and now if I check if 8 is in the nums, it is. So that's what the membership operator does. If you want to check whether something is not present in nums, I can just do this and it will return false. And if I were to go and remove dot pop, so 8 is removed. If I take a look at nums now, and if I check whether 8 is not in nums, it will return true. So that's how that works. So membership operators are just used to check whether or not something is present inside a container or inside a group of sequence that we have. And with that, we have come to the end of operator section, and we'll move on to data types in Python. So a Python token. In Python, every logical line of code is broken down into components. These components are called tokens. So there are many types of tokens. The normal types of tokens that we discussed are keywords, identifiers, literals, and operators. So everything that you write in Python is a token of one kind or the other. Let's take a look at them one by one. So keywords, what are keywords? Well, in Python, keywords are special reserved words. They hold special meaning. So these words are something that you cannot use to define a variable. So they convey a special meaning to the compiler or the interpreter. When the compiler or the interpreter takes a look at this word, they'll understand that it has to perform certain action. It has to allocate memory, it has to create something on the call stack, it has to do something in the background instead of just treating it as a normal variable. Now, each keyword has a special meaning and a specific operation. So we'll take a look at them one by one. We'll come across many keywords. We'll take a look at them, what they mean one by one. We should never use keyword as a variable, because that's going to cause a lot of problems when we run into later code, and we'll understand what that means in a moment as well. So these are some of the keywords that Python uses. So as, and, continue, break, except, del, len, from, import, pass, lambda. There are many others, and these all hold special meaning. And as you get deeper and deeper understanding of what Python has to offer and how you can use Python to create your own applications, you'll understand where these keywords are used. The main point that you should understand is you should never use them as a variable name. So again, let me show you an example. Let's say I open the Python console. Now, if I want to type RET is equals to 7, this works just fine. But if I were to type return RETURN, that's a special keyword, and we'll take a look at what that means in a moment. But if I were to assign it to 7, I will get an invalid syntax error, mainly because return is already a keyword. If I were to type return 1, again that would work just fine. But if you try to use some keyword for this is going to cause a problem. Now that is done, let's take a look at something else. So these are the keywords, but there are other tokens as well called identifiers. So an identifier is mainly a name that is given to something in Python that we can give that allows us to identify it later on. So these could be names given to a variable, names given to a function, a class, or an object. In case you're not familiar with function or class or object, you are familiar with variables because this is what we just discussed. But functions, classes, objects, everything else will be discussed later on. So don't worry about if you don't understand it as of now. You'll get to understand it throughout the runtime of this presentation. So there are certain rules that we need to follow when we're naming an identifier. The first thing is no special character except underscore can be used as an identifier. So we can't use a special character to be an identifier, a variable name or anything. Similarly, keywords are not something that you can use in place of an identifier. So as we already saw, we can't use return, we can't use for. There are many other keywords that you cannot use as variable names, as something that you can use as an identifier. Then Python is case sensitive. So there a variable which is named var with V capitalized and a variable named var with every character in lowercase. These are two different identifiers. So if I were to type var with V capitalized equals to 7 and type small v small a and small r equals to 7 and if I equals to 8, and if I were to print the values of both, we will get different values. So these are two different things. In when Python interpreter takes a look at it, it will assign two different buckets for them. Then the first character of an identifier can be an alphabet or an underscore, but not a digit. So as we have already seen that we can use any alphabet as the starting character of our identifier or variable name. On the other hand, we can use underscore as well, but we cannot use a number. A digit is not something that we can use. So that's you can use it afterwards. It could be the second or the last character or anything in between, but can't be the first one. So let's take a look at them. If I were to open the Python console, we have several ways of doing it. In Python, a variable is also an identifier. So let me just show you the casing problem. So variable is 7. And if I were to name it with a capitalized V, it's a 7. And if I were to name all of them capitalized, it's 7. So let me just change it. Now it's 7, it's 71, and it's 72. So if I were to print VAR with everything in lowercase, it's 7. If I were to print it with V capitalized, it's 71. If I were to print it all capitalized, it's 72. So all of them hold different values. And the last thing is we cannot start it with a number. So let's say 1 VAR equals to 7. We'll get a syntax error. But if I were to do it V1AR, this is just fine, it will work. V1AR and it works just fine. Now we come to literals. So literals are just raw data that is given to a variable. So literals can be of many types: string literals, numerical literals, boolean literals, special literals, and we'll take a look at them one by one. So as you can see, we can have several kinds of literals. This is some code that's been written for you, and we'll take a look at string literals first. So found by enclosing a text with quotes. Both single quotes or double quotes can be used. So this is some code that you can take a look at, and you can type it in your own console. You can type it in any other kind of environment in which you can run Python code. I will expect you to run it in console because that's where you get the most immediate feedback, but it's your choice to run it in any other environment if you're comfortable with it. So let me just show you what we can do here. So I open this, and as I've already discussed, we need to enclose our text within quotes to tell the Python interpreter that it's a string. Let's try it. So if I were to give path is a variable and I want to assign a string literal to it, I can type sample path, press enter, and it works. This is sample path. If I were to type single quotes, this wouldn't make much difference. It's going to be just the same. It's going to work just fine. Now the reason why we have single and double quotes for this, it's mainly because in C and C++ and many other languages like Java, single quotes were used for handling a single character, not a string, but a single character. So a single character would be something like A. That's a single character. A string with length of 1 is something that's called a single character. Now the way it worked in Java and C was that if you were to attach multiple characters one after the other, so let's say A, B, C, D, and then you were to do it that way, then that would be a string. And for that you can't use single quotes, you have to use double quotes. I'm simplifying things a lot because there's a lot undergoing like the null pointer and all, but you don't need to worry about that. You just need to understand why there's 2 quotes and why there's 1 quote. And that's the thing I'm trying to get across. So if a person shifts from C++ or Java to Python, they will be expected to use, or they will think they'll be using a single quotation mark for a single character, and that would work. And for that to work, they have created they have allowed for us to use both single quotations and double quotations. There's also one thing that you could do. You could use 3 single quotes as well. So if I were to write a really long line of code instead, or a really long line of string, I could just start it with 3 quotes. I press enter. As you can see, the prompt, instead of it being 3 arrows pointing left, it's now become 3 dots. Now I can type anything. Let's say that I'm typing this. I press enter. It's still allowing me to type. I type this. Let's say that you're typing a paragraph or a note or an email or something like this. I can do it this way. Now let's say that this is everything that I wanted to type, including the enter character. Now if I want to end it, again I type 3 single quotations, press enter. I get back the prompt with 3 arrows pointing left. I type in the word line, press enter, and as you can see, I get everything. This \n characters is something that is used to determine a new line. So if I were to print it using the print function that we have already discussed, press line, as you can see, it starts here, enters or creates a new line, prints everything wherever the \n character comes in. Then at the end, it again starts a new line and then ends it there. So the \n character is a special character that tells you that there is a new line here. So you don't have to worry about that as of now, but just understand that that's how we do it. It's not just strings though. There are many other different kinds of literals as well. There are numeric literals as well. And numeric literals allow us to use variables that can store numbers. Now we can have positive and negative whole numbers with no fractional part as integers, as we have already discussed. We could have real numbers. Real numbers are numbers with fractional part using the float variable, and we could have long. Long is also something that could be used to store values, but the important thing is that it could store a much larger value than integer. So as you can see in the description, it says an unlimited string of integers followed by uppercase L or lowercase l, and I'll show you what that means in a moment. And then it's also something that you could do. You could store some complex numbers, so numbers with real and imaginary parts. Now if you worked with mathematics, if you worked with real and complex numbers, that you will understand what I'm talking about. If you've not worked with it, that's totally fine. It's not something that's used very often. It's only used in special cases where you need to display complex numbers. So in our case, let's just take a look at this. We have a positive and negative numbers, so we can store that in integer as well. Let's say that I want to store negative 77. I can store it in number, or positive 77. I can store it in number, and the type of number will still be a class of integer, right? But if I were to attach capitalized L here, that would cause an error. Oh, because it's a newer version, so never mind. So if that was the case, then I could do that, but it's not. Yeah, so as you can see, it's working fine. Now if I were to do a lot of other things like floating point numbers 1.56, and if I were to get the type of it and press enter, this would give me a class of float. So float, as we have already discussed, is something that is used to store floating point numbers or fractional numbers or real numbers, however you want to call it. So that's how we store that number. Now there are many differences between how these are stored in underneath the hood. They are stored using binary format, and we don't need to get into that. But the thing that we need to understand is that when we're using binary format underneath the hood, Python takes a look at the data type and then decides how it wants to set the binary format of that number. So that's why we do it that way. Now there are many other ways you could do it, and you could use many other tricks as well to store other kinds of numbers, convert float to integer, divide two numbers and make it convert to float or anything else. That's also doable, but it's mostly that you're supposed to do it easily. That's there. Make sure that you're using the easiest option. Make sure you're choosing an option that works for you. In Python, the value of an integer is not restricted by the number of bits, so it can expand to the limit of available memory, and no special arrangement is required for storing large numbers. Now, that is mainly because in Python you don't need to, as I've already told you, it's a high level language. It's not a low level language, so you don't have to worry about changing the types or the available bit size of a number when the number becomes large. Python will do it for you automatically. It will take a look at the number, it will take a look at whether or not it's exceeding the current memory bounds, and it will assign a larger memory bound for it so that you could add more numbers to it, unless and until it reaches to a point where it's overriding the available memory. That then there's no memory to store the number and it will cause an error. And no special arrangement is required for storing large numbers. Python again does it for you, so you can just follow on working on your application instead of working with the nitty-gritty details of how things work underneath the hood. This is why I told you that you don't need to worry about the binary arrangement underneath the hood. Python will do it for you. Then comes Boolean. So Booleans evaluate to true or false. True and false are basically a human construct. So let me just show you what that means. If I want to check something, let's say that there's a user and I'm building an application and I ask him to enter a password. He says the password is ABCD. He's creating his account. He says ABCD. Then it comes to confirm password and he writes ABCD again. Now I want to check whether or not password and confirm password contain the same number. So I press password equals to confirm password. I press enter and I get a boolean value of true. So this is what allows me to understand how to move forward. If it returns true, then I can basically move ahead and tell the user, okay, everything worked perfectly. I'm going to store it in the database and do whatever I want with it. On the other hand, if it had returned false, let's say the confirmed password was abcd1, the user mistyped it, and now I check whether or not they are equal, I get false. So this is what boolean values are. You can assign them yourself. So let's say bol equals to true. Make sure that you understand that the first letter is capitalized. So smaller letter true will not work since Python is case sensitive. So if I were to type bol, that's true. And I can also assign false to it. Press enter, and this works as well. So this is how that works. Now that boolean is understood, let's move ahead and see what other things that we have for us. So we have special literals. These special literals are something that we can use for ourselves. So these special literals in Python are called none, which means that the variable is yet to be initialized. So if you're coming from other languages, there's a concept called null, N-U-L-L. So that's basically what Python uses, but instead of null, we use none. So let me give you an example. Again, let's say that the user is entering something, the confirm password, and the confirm password field has been left blank. So instead of writing something inside it, he chose to write nothing and they submitted. I will get a none value here. That means absence of a value, that the user has not provided a value. So that basically means that if I print confirm password now, I will get nothing because nothing is there. It contains no value. It's empty. Think of it as a box that contains nothing as of now. And when the user does enter something, that box will contain that value. So that's what none is used for. It's used to define absence of value, not an empty string, not any other kind of string, not zero, not anything else, but an absence of value. And the type of none is none type, in case you were wondering. And now we have operators.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
So let's take a look at some data types in Python. So data types in Python could be divided into two parts, immutable and mutable. So immutable data types are data types that cannot change. On the other hand, mutable are data types that could have their values changed. So for instance, string, numbers and tuples will have some value assigned to them, and then when we want to change them, instead of adding something to it, it will create a new data type for that. It will create a new value for that variable to hold. On the other hand, in mutable we have lists, dictionaries, sets, and in lists we have several types as generic list or tuples and all. We'll take a look at them one by one. So let's take a look at them. So we have numbers. So a number is basically, as we've already discussed, data types such as integer, float, and complex data types. They come in numbers. So as you can see, a whole number with no decimal point is integer. A fractional number, a number that has one or more numbers after the decimal point, is floating point number. And a complex number is a number with real and imaginary parts. So again, complex numbers are not that prevalent. Mostly we use integers and floats. Complex number have some use case, but not a lot. Then comes strings. So a string is basically a lot of characters that are enclosed within either a single or double quotes, and they are used to store text. So a string literal could look like this, as we've already seen. So there are some operations that are being performed on string, and we'll take a look at them now. So if I were to open my Python prompt, let me just define a string. So string equals to, hopefully you can see this, and if I type A, B, C, D, E, F, G, H, press enter, this is a string. Now if I want to take a look at the length of the string, how many characters are there in this enclosed within the double quotes, I will type length string, and I have 8 characters. 1, 2, 3, 4, 5, 6, 7, 8. So that's correct. Now let's say that I want only the first 4 characters. This is what is known as slicing. This could be done with a string or with any other character as well. Firstly, let me show you what happens if I do this. I get A. This is what is known as indexing into a string. Basically what I'm doing is I'm saying in the string variable, whatever data it holds, I want the data that is stored within the first position. And in string, everything starts with the position starts from 0. So 0 is the first position, 1 is the second position, and by that logic, since there are 8 variables, 7 will be the last position. I press 7 and I get H. If I try to go outside these bounds, let's say I press 9, I get index out of range. Basically, there is nothing after the position 7. Everything outside that is not accessible by Python. We have not assigned any memory to it. So that's illegal for us to do, and that's why we get an index error, as you can see here. Index error mainly because we are using this, and this is what is known as an index, something that is enclosed after a variable named enclosed within 2 brackets. So now that we know how to access a single variable, a single character in a string, let's say that I want the first 4 characters. First 4 as in A, B, C, D. So I start from 0 and I want everything before the fourth character. Why? Well, because 0, 1, 2, and 3 are the first 4 characters because it starts from 0. So we have 0, 1, 2, 3, which are first 4 characters. So how do I get all of them at once? Let's say there are 15 and I want 0 to 14. So what I can do is I can type 0. After that I type a colon and I type 4. This means get me everything from the beginning of the string and right before the fourth character. So the fourth character is E and before that is D. I want everything from A till D. Press enter and I get a substring of it, which is A, B, C, D. So this is what slicing a string looks like. This is what's known as a slice operator. Now you can do it every other way as well. It's not necessarily that you start with 0. You can start with 3 to 4, which will give you, I think, just one character, which is D. Now another thing, if I were to leave this off, what do you think will happen? Pause the video and try to think about it. But if I were to do it now, it starts from 0. So it defaults to 0. If I were to start it with a number that's this, it will give me an empty string because it makes no sense. So that's how you do that. And finally, if I were to leave 4 off, since we know what happens here, I think we can probably guess what's going to happen here. I'm going to press enter and you can see what happens. What happens is we take everything from 5 till the end. So we have the 5th character or this the 6th character in this, which is on the 5th index, is let me just print the string again because it's gone out of character. So it's this. So this is 0, this is 1, this is 2, this is 3, this is 4, and this is 5. I want everything from the 5th character till the last character. So this is what that means. And finally, I can use negative indexing here as well. So I want everything from the beginning till the removing the last one character. If I were to remove the last 2 characters, I can do this. And this works just fine as well. So that's how slicing works. Another operation we can perform is replace something in this. So let's say string dot replace. If I were to show you the example here, as you can see, it says replace ed with e, and it will do that here. But let me just show you. Replace f with g. I press enter, it returns another string to me, which is a, b, c, d, e, g, g, h. Now if I were to take a look at the string variable that contained our value, it has the same data. So when we perform this replace operation, what we're actually doing is we're saying give me another string in which you have replaced all the f's with g's. This is especially useful if you're trying to remove some content out of a long line of text. So let's say that you have 17 lines of text in which you want to remove all the, let's say you want to remove all the vowels for some reason. You could just run this and see if there is any A, E, I, O or U and just remove that. That will work just fine as well. So now that we're done with string, now we're done with data type in string, let's move ahead. Now comes tuples. Tuples are a sequence of immutable Python objects. So what does that mean? Well, let's say that you want to store the number of or the name of weeks or in string format in a variable. So we have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, 7 days in a week, and all of them need to be stored in a single variable. Now there are many ways to do it. One important thing that you need to notice here is that this data is not going to change ever. There is no time in future are you going to go that we need to add another day to the week. That doesn't seem very feasible. So because it's not going to change, we are going to use an immutable data structure or an immutable type, which means adding something to it is going to be it's not going to be something that's allowed. So let's say that I want weeks. Now I want to store everything in one. I could certainly create variables that say sun, which will contain Sunday, and similarly Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. That's certainly doable, but again it runs into the same problem. Let's say that we had 14 things that we needed to store. Let's say that we had 100 things that we needed to store, and we needed to access them using one variable. That would be very difficult to remember the variable names of 100 different kind of variables. It would be better if you could store them just in one variable and then access them using the position syntax that we had discussed earlier in string, like this one. So this is where tuples come into play. So let's say weeks, and I enclose it in brackets, but that's not really necessary. But I would do that here. Now let me just type in Sunday, and you could type it with me, Monday, Tuesday, Wednesday, Thursday. Make sure that you're separating them with commas. I'm typing a space after commas to make it more readable. That's not really necessary. Friday, and finally Saturday. Press enter. I press weeks, and this is what we get. If I were to take a look at the type of this, type, it's tuple. So now I said I used commas here, and that's not really necessary. If I were to use this would also work. The way Python identifies that this is a tuple that we want to add something to the data is by taking a look at this comma. So it takes a look at this line. It says, okay, weeks need to be assigned some value. It takes a look at Sunday. It says, okay, one string, and this comma. That means other values are also going to be assigned, and this is a tuple. Even if I had not put the parentheses before and after, opening parentheses and closing parentheses to enclose this list, it would work just fine. Now, one thing that I would like to show you is if I were to go weeks 0, I get Sunday. Weeks 6 should give me Saturday, right? But if I were to assign some other value to it, let's say any gibberish value, I press enter and it gives me another. Tuple object does not support item assignment. Now this is one of the major advantages of using immutable object. It does not let anything in the data that you have already entered to be manipulated. So if you have entered a list of something that you know is not going to ever change, then tuples are the best option for you. So this is why we use tuples. So now let's take a look at something else. We have lists, dictionaries, and sets. So lists are very much same to tuples. One major difference is that you can make changes in a list. So if you have dynamic data that changes rapidly, then you can use a list for that instead of creating new tuples for every change that has occurred. Let me show you an example. Let's say that instead of weeks, I wanted to store, let's say that I wanted to store salaries of people, right? I can store salaries of 3 people. Let's say that it's stored in thousands. So 10 means 10,000. 15,000, 20,000. Press enter. And now if I were to take a look at salaries, press enter, I have 3 salaries. If I were to take a look at the type of salaries, I would get list. It's not a tuple, it's a list. That means that if I want to change the salary of a person, because it does happen that a person gets promoted, they get an increment or whatever happens. They say that the person at the index 0 is now going to get a salary of 18,000. And now it does not throw any error because I am using a list and I can store any kind of data. It's still a list. And if I were to print it, now it's 18. Another cool trick that I can show you is that instead of this doing it like this, let me just assign 10 to it. And let's say that the thing that I want to do is I want to, instead of assigning a new salary, I want to add 8,000 to the guy's to the person's current salary. Now there are many ways to do it. First way to do it would be salaries of 0 equals to salaries of 0 plus 10. So what happens here is I take a look at this. I want to assign the value at index 0 to be the current salary of the person and add 10 more to it. Let's add 8 more to it to add consistency. So as you can see, this is what it looks like. And now if I were to look at it, it works just like that. But as you can see, the typing, this is quite long. It's a bit repetitive. So you get, if you've already taken a look at the operators slide that we have taken, that we have gone through, one operator there was plus 8. Now what will happen is it will add 8 to the already existing salary of the person at index 0, which is 18. So 18 plus 8 would give you 26, and that's what we've got. So you can do it this way. You can add, remove, you can add data to it as well. So I could go salaries dot append. Append will allow me to add a new salary for a person. So let's say that it's 28. I press enter. Now instead of 3, it contains 4 salaries. Append is not something that you could do on a tuple. So that's how you do it. And another thing is that instead of storing all everything as an integer value, you can store data of any type. Let's say that I want to store 1 a and I want to store a floating point value as well. This is also doable. So I can type mixed equals to this. This is one of the advantages of using Python. Many languages don't allow for this kind of intermixing of data when just trying to store it in an array or in a list. So you can take a look at that. Now if I were to type mixed, I get this. I can store any other kind of data. I can even store another list inside a list. So if I wanted to store another list, 155, comma b, I'm just adding some gibberish value just to show you. This is doable. I can add another tuple to it. This time I need to put this parenthesis. So to describe, I'm adding a tuple, 88, 77, and it's done. Now if I take a look at mixed, I have this. If I want to take a look at mixed of 4, right? It's tuple, and I can take a look at the type of the tuple to see if it's a tuple or not. And it's a tuple. And if I were to take a look at the type of something at index 3, it would be a list. So you can nest any kind of thing, but just don't go too crazy with it. That could cause a problem. You will not be able to comprehend the data that you have if you go extremely benign on it. Then we have dictionaries. In other languages, they are called hash maps or hash tables. So a major advantage of using a dictionary over a list is, firstly, it allows you to create a key value pair. So again, let me just show you. So if I want to associate a person's name to the person's salary, instead of doing a list which could only be accessed using a numeric index like 0, 1, 2, 3, what I can do is I can create again salaries equal to, and I can create a dictionary like this. Add 2 curly braces. Inside it, add the key, which would be the person's name. Let's say John, and end the quotation. And now the person whose name is John gets 15,000. Let's say that there's another woman who's named Jane. she gets 14,000. Let's say that there's another woman named, another man that's named Johnny, and he gets 5,000. Press enter, and now if I were to print salaries, it will display the key value pairs. If I were to take a look at the type, it will give me a class of dictionary. So that's all good, but one thing that it allows me to do now is I can access it using the person's name. So let's say that I have salaries. I want to get the salary of Jane. Press enter, I get 14. That means Jane earns 14,000. Let's say that instead of Jane, I want John. As you can see, John gets 15,000. And if I were to use a name that doesn't exist, I'm going to get an error. This is called a key error. This key does not exist. Now, a way to come across this or come over this is, instead of indexing directly, you can use get. So I want salary of John, but if it's not available, give me 15. So I'm getting 15 because that's the salary of John. And if, let's say that I were to use some other key that is non-existent, the person named John ASD is not available in our dictionary. So if I press enter, I'll get 18, which is the default value. I could set it to anything. I could even set it to 0. So now if I try to access a person whose name is not available in our dictionary, I'm going to get 0. So that's one of the major advantages. Another is really fast. So even if you have like 10,000 records, the way hash table works or the dictionaries work underneath the hood is, instead of it going through all the 10,000 names and finding the name that you want it to find, it does some clever tricks and makes it really, really fast. This is why if you are doing something that requires really fast access to some data, and you can give some unique key for that data to be accessed, then definitely use dictionaries instead of using lists, because in lists you could in lists do something like this. Store a list of list in which the first thing is the person's name, second thing is the person's salary. I could do it here as well. The first thing is the person's name, Jane, and the salary of Jane is, let's say, 80. Okay. Now, if I wanted to, I could define a function that could find this or do a lot of things. But the important thing to understand is, if it was, let's say, 10,000 records, and I wanted to find a person's name let's say that a person's name was not John or Jane. I wanted to find a person whose name is at the end of the list. Let's say I don't know where the name is. Let's say that the person's name is Andy. So we go through the entire list searching for the first element and checking if that first element is Andy. And if it is Andy, then we print the salary. If not, then we print 0. Now, for that, we have to take a look at all the 10,000 elements. In dictionary, what we do is we can just give the name, and dictionaries will do some clever tricks behind the scene that you don't need to worry about, and it will instantly find it for you. So always use a dictionary when you have large sets of data and you want to constantly find things in it. If you want to just store some data and you know you can access it using numerical indexes, and the data keeps changing, then use lists, because in tuples you can't change the data. So if I have some, let's say I have 0, and I want the person with the employee ID of 0 to have salary of something, then I could press 0. Here it's not going to work because I've reassigned it to a dictionary, so I'm getting a key error. But you can understand my point. On the other hand, let's say that I have a data set which does not change and I want to access it using numerical indexes. Then tuples come into play, and you used to use tuples. And finally, we get to sets. Sets are by far one of the most underused data sets, and you need to understand why we use sets. So sets are again unordered collection of immutable data which has no duplicate elements. So what does that mean? Let me show you. I can create a set. By the way I'm showing you how to create dictionaries and all, that's not really necessary. Let's say that I want to create my sample dictionary. I can just use the keyword dict function and it will work just fine. Now it's an empty dictionary and I can add data to it. Another thing, you can add data using dictionary and typing in the name and then assigning a value. This will work just fine. Now the thing you need to understand is, similarly you could use, instead of this, you could use tuple. This will create a tuple, and L list will create a list. Now I want to create a set. So let's say that I name it S. Now I can do it this way, but I won't be able to add anything because this will be taken a look at as a dictionary. So the best way to do it is use the keyword set or the function set. And now if I take a look at S, it's a set. So what is a set? Set, if you have worked with mathematics and you have worked with Venn diagrams and everything like that, you are quite understandable of what set is already. A set is basically something that contains a lot of values, but it does not contain any duplicate values, and it allows you to check whether or not something it contains a value or not in constant time. So let me give an example. I think s dot add 1 would work. Now if I take a look at s, it has 1. If I were to add 2, it contains 2. Now if I were to add 2 again, it instead of containing 2 elements named 2, it contains 1 element which is 2 with the value of 2. Now if I want to check whether or not something exists in a set, let's say 1 in S, and it will show you true. This is the in operator or the membership operator that we have already taken a look at. And if I were to take a look at whether let's say I want to check whether 5 exists or 3 exists, it's going to be false. So why are we doing this? Well, one thing that you can take a look at here is that it again, since we are using set, it is extremely fast for us to perform this operation. Let's say that there were a million records in this, and I wanted to check whether something exists in it or not. The first intuition that comes into our mind is to take a look at everything that is inside the set, all the 1 million things, and compare it with the data that we want to find. If it's not there, then we return false. If it is there, if it's found in while we're taking a look at all the 1 million data points, then we return true. Now again, that is fine, but if it's 1 million records, then it takes a lot of time. And let's say that you had to do it constantly. Let's say that you had to check whether or not something exists in those 1 million records 10,000 times, 20,000 times. That's a lot of computation. So again, sets do some really complicated mathematical things underneath the hood to basically just check whether or not something exists inside it in real time. That's why it doesn't contain any duplicate values in this as well. And so I can do 1 in S as well. If I were to assign a list of 1, 2 to it, and then instead of 1 in S, I can type 1 in L, and that will return true as well. The difference here is that it takes a look at all the elements, 1, 2, and whatever, and finds if something exists in it or not. Whereas in set, it's extremely fast. So if you have some data that you want to keep track of and want to check whether or not another value exists, or you want to deduplicate the data, you can do that as well. So use set when you want to check memberships really fast. You can perform the union, intersection, and all that, and that's very easy to do with sets as well. So now let's take a look at how to deal with sets and how to deal with different data types. I'll show you some hands-ons to further strengthen your knowledge of data types. So let's take a look at the setup that we're working with. So we'll be taking a look at data types. We'll be taking a look at lists, sets, dictionaries, and tuples, the things that we have already discussed. But instead of typing into the Python console that we had done earlier, let me show you how. This was the console that we had typed code into. Now for typing out single lines and executing them, this console is actually very good. But let me just exit out of it. When you want to type in a lot of code and you want to open a code file and do execute it and run all that, I would recommend that you use Visual Studio Code. So let me show you what it is. Let me just open a new window. And here type in VS Code. Press enter and open this. Once you've done that, you can download it for Windows or for any other operating system that you have. After you've downloaded it, you can install it like any other software that you install. But after doing that, just right click on a folder that you want to open it into, type and press the open with code function. It will open VS Code for you. So it's done. And as you can see, there are no files as of now in this folder. The folder's name is hands-on, in which we'll be performing the hands-on. Let me create a file called app.py. Py is the extension, the Python extension presenter. Now, just to make it clear, you don't have to use VS Code if you don't want to. You can use Notepad for this as well. Just go to the folder, create a file named app.py, and right and click on edit. It will open it in Notepad, and you can make the changes there as well. There's virtually no difference. Now what we need to do is I open this, and let me just make some changes. I'll increase the font size so that you can see a little better. So it's loading some extensions, and while it's doing that, open the command prompt. To do that, just go onto the address bar, delete everything, type cmd, press enter. The reason why we do it this way is because we want to open this command window in this folder, so that the files that we create, the app.py file, I want to run it using the Python command. If you've installed Python, then it's already available for you. Here you can do it this way. Now if I open this, as you can see, I can type in a lot of things. So let me just increase the font size. I think it's now I'm going to type some Python code. Hopefully it's visible to you all. So in Visual Studio Code, you can write code, and the reason why I'm choosing this is because it shows you some syntax highlighting. It shows you if you've written something wrong. It auto formats the code for you. It does a lot of things for you right out of the gate. So to perform this, what I'll do is the first thing we'll have to do is we have to use lists. So let's say that I create a list named nums equal to, and the numbers that I want to insert in it are 1, 2, 3, 4. So the first task I want to do is I want to print it. So I print nums, save the file. When you save it, this icon changes from a filled circle to closing to an X. Now that that is done, open the command prompt and type python Python and the name of the file, which is app.py. Again, I press enter and it's there. Let me just increase the font size here as well, so that it's easier for you to see. Let's say it's 28. That's easier to see. Right. Yeah. So again, Python space and the name of the file, which is app.py in our case. And one thing that you should notice is that app.py is in the folder in which the command prompt is open. So it's C user, my username, desktop, and in the desktop we have a hands-on folder inside which we have created the app.py file. This is why this is working. Another thing you can do is you can press this command, but it would work sometimes and sometimes it won't work. So I don't like doing it that way, and it gives you this line of code as well, which is fine. But we're doing the same thing. We're typing Python and the name of the file. So you can do it either way that you want. Now that is done, let me just add a comment. So a comment is basically something that you add in a code so that you can explain your code better. Now if I type anything here, this code will not be executed by interpreter. It's just for the reader of the code. So any person who's reading the code can take a look at the comment and understand. So I'll type declare array and print. Declare list and print. Right? If I run this again, it's not going to make any difference because it's a comment. Now that that is done, let me show you how you can add something to the list. So you get the append method. In the append method, I can type in a number. It could be of anything. It doesn't need to be a number. It could be a string. It could be an object as well. I'll type in a number though. Let's say that I want to add 5 to it. I save it. I print it again. Run it. And I think I've run into an error. Yeah, I want to print nums. Sorry. And as you can see, now nums has 5 in it. I can do a lot of things in it as well. Instead of that, I could use the pop method. Pop method removes the last element if I don't pass in an index. So if I were to store the value, what it does is that it removes the value and returns it so that I can also take a look at what was removed. And now if I print nums, run this, This is the number. I added 5 to it. It's this. Remove the element at the end, which was 5, and now I printed it's 4 again. But a cool thing that we can do is instead of not specifying the index, we can actually specify what is the index of the element that you want to return. So if I want to remove something at the beginning of the list, I type in 0. This would remove 1 from it. So if I run this again, instead of 5, we'll see 1 removed. So 1 is removed, and now it's 2, 3, 4, 5. So again, you can do a lot of things with it. One of the things was this. Now let me show you something that's really interesting. So if I want to print all of them, what I do is I use the for loop, and we'll discuss this in a later slide, but just to give you an example of where looping is useful. If I have 10,000 elements, instead of accessing them one by one and writing things like print num0, and then I keep going on like print num1, num2, num3, so print all the 4 numbers, what I can do is I can just print a loop and tell it that I want to print everything inside the list. So everything in this list, I want to do something with it, and what I want to do will be indented here. Do you notice that I put a tab after this, or Visual Studio Code does it for me? This is what's called indentation. This is what tells Python what is the code that I want to execute in a particular block. So if I type print x, and if I do this, as you can see, it's printed 2, 3, 4, all of them in a new line for me. So this is what the loop looks like. Now, if I had not done it this way, if I had done it this way, then Python would have no idea whether or not I want to include this line in the loop, whether this should be executed in the loop or not. Or to give you another example, now I want to print done. Done will be printed at the end of the file. So if I run this, it's printing done after each execution. But if I unindent it, if I push it to the left side, I run it again, and now it's printing done afterwards. So Python looks at it, goes, okay, everything that's underneath this for loop that's indented 1 point to the right is going to be something that needs to be executed within this loop. And this is how Python reads your file and understands what is the code that I need to perform and how. So make sure that you understand the indentation. Now that we have looped over this as well, let me show you something about tuples. So instead of 1, 2, 3, 4, 5, if I remove the parenthesis, what do you think will happen? Press enter. So it prints everything, but it immediately gives me an error that there's no way to add something to a tuple. If you remember, we have already discussed that tuples are not something that you can add something to, they're immutable. So that's why we do this. So instead of appending, I don't think we can remove things as well. I press enter, and pop is also not available. But you can print them, you can loop over them, just as we did earlier. As you can see, 1, 2, 3, 4, 1, 2, 3, 4 done. It's completely doable. Now let's move on to dictionaries. Let me type this dictionary, dictionary, or let's say I'll call it cell. I'll define a dictionary the way I did previously. Jane 15, John 20. I need to add it as a string. Now that that is done, if I print it, let me just remove this. It's this. I want to add something to the list or to the dictionary, I can just do it this way. I want to add Andy to the list, and he earns 25k. Now if I were to print this, let me just, yeah, now we're getting Andy here as well. As you can see, Jane, John, Andy. So this is working. If I want to delete something from the list, let's say that Andy, I don't want to print, I don't want Andy in this list anymore. I use the del keyword. Inside, I just type in sal of Andy. I run this again, and Andy is removed. So that is fine. That's how you remove an element from a list or a dictionary. Other operations we have already performed. One thing that we haven't performed is looping over this. So let me just show you. For item in, and here things get a bit complicated. So instead of just sal, I have to type items. If I just want to loop over the keys, I can type sal.keys. And if I print item, what do you think will be printed? So pause the video if you want to think about it and then answer. But what will be printed are the keys. So the keys are Jane and John. Remember, a dictionary is a key value pair. These are the keys. These are the values. So Jane earns 15. John earns 20. So we type it. We print in the keys. Now if you don't want to print the keys, let's say we want to print the values. I do that. Now I can only print the values. But let's say that I want both of them, items, and I want key as well as val. Now I can print key, comma, val. And as you can see, I'm printing Jane space 15, which is the key, comma, value. So we're getting the data that we want. Now another thing that we can do is we can print Jane in cell. Print it and we get true. It's the same operation, it's a membership operation, but if I were to type in DSF, I'm going to get false. So again, this is what it means. And now let's take a look at a set. So let's say S, create a set. Another thing you can do is you can use this symbol, but instead of typing a key value pair, you just type in the keys. So if I print the type of S and I run this, it's a set now. So if I were to keep it empty, then it would become a dictionary, because this is what the default Python behavior is. So this is what it looks like. We have a set for us. Now if I want to add something to the set, I just use the add method. I want to add 1, and I want to add 2, I want to add 3. And now if I were to print S, it's 1, 2, 3. So this works fine. But if I were to loop over it for X in S, let me just print X, as you can see, we get all the numbers in it. And if I were to print the same thing that we did earlier, 1 in S, I'll get true. And if I were to print 4 in S, I get false. So this is what this looks like. This is what our code looks like. This is how it works. So hopefully that was informative. Now let's move ahead and see what else can we learn about Python. So now let's take a look at comprehensions. Comprehensions are quite an interesting feature in Python. They're very easy to use. They're very informative, and they are quite fun to work with. So let's see what they mean. As of now, we know how to create a list. I asked you to create a list, and let's say that I tell you that, hey, I want you to create a list, and in that list, I want you to enter number from 1 to 5. What are you going to do then? And let's say not 1 from 5. Let's say that I say, I want you to enter in a list. I want you to create a list and add a number from, let's say, 1 to 10. Or it could be anything. It doesn't even have to be 1 to 10. It could be any arbitrary number. So how do you go about doing that? Well, we know we can do it using loops, and that's how many languages ask you to do it. So I'll create a list which is empty, and for let me show you how to loop to a certain extent. I want to loop for x in range, which is a function that allows us to loop over a particular range. I want to loop from 0 to 10. So it will loop from 0, 1, 2, 3, 4, 5, 6, 7, 8 till 9. Not 10, because the end is exclusive. So always remember that. And now if I do L dot append x, and finally we can print x, not xl. So if I were to clear the screen and type in this, as you can see, we get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now this is fine, but a major problem that you can see with this is the fact that we have to write a lot of code. Wouldn't it be nice if we could just compress this all into a single, compress all of this into a single line of code? Because we are just instructing the computer to add something to a list, right? So this is possible using comprehensions. I define an empty list. I tell it add X to the list. Now Python is waiting for me to define what X is. So I'll go for X in range 0 to 9, and that's it. Now this is something that many other languages don't provide you to do. Python is quite easy to use, so you can do that. Here we only get 0 to 8, mainly because it has to be 10, like we did earlier. And this works. Now this is just list comprehension, but I can perform many other kinds of comprehensions. So list is this. Let's say that I want to perform a tuple comprehension. So for this I have to use parentheses. And let's say that I want to perform a set comprehension and a dictionary comprehension. All the data types that we have discussed so far could be, all the containers that we have discussed so far for the data types could be used to perform comprehensions, as we are about to do now. Comprehensions are quite easy to understand once you get through the basics. So let's see. Let me just print all of them one by one. So
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
we will print the tuples, then we will print the set, and then we will print the dictionary. So let me just show you. This is what tuple comprehension looks like. What will it be for set? Just changing it to parentheses will work. Now for dictionary, we need a key value pair. So let's say that we want to store key as the current number, which is the number from 0 to 9, and the value as the square of the number, which is number divided by itself. So this is what it looks like. Now for a number to be key value pair, I want to define the key, press colon, and then define the value, which is x multiplied by x. Now if I were to print it, as you can see, we get this, we get a generator object, and we get this, and we get this. So this is what it looks like. Now generator objects are quite easy to understand. You can just, let me type in comma, press enter, and so you will get run into error. So don't do it this way, but you could use tuple, and now you press enter and you get a tuple out of it. So this is one of the problems when it comes to tuple comprehensions, that you can't just use it this way, right? But this is what comprehensions look like. They're quite easy for you to create once you understand how to create them, and it's very easy for you to understand how to write code like this, and it just allows you to write succinct code, or code that's easy to understand. Now that that is done, let's see what else we have to do. So now let's take a look at conditional statements. So a conditional statement is basically a statement that allows you to change the flow of execution, or the path of execution, when a provided condition evaluates to either a boolean value of true or false. So suppose that we had some way of figuring out whether or not you're sick or you're healthy. So what happens is, let's say that you want to make a decision. First thing is, we ask you, are you sick? So let's say that you are sick, then we would advise you to go to the doctor. But let's say that you are not sick. That means the condition whether you are sick or not evaluates to false. And then you can go out and play football, do whatever you want. This is where conditional statements come into play. And we encounter conditional statements every day during our lifetime. We have encountered conditional statements. I think you probably encountered conditional statements today as well. Waking up, when you're waking up, you decide whether or not to sleep for an extra 5 minutes, whether or not you are late for a meeting, whether or not to take a cab or a taxi or walk to the place that you work, whether or not to eat at one place. These are the kind of situations that allow us to think of conditional statements in a more rational way. So this is what it looks like. We have many ways of doing this. One is the if-else statements. So the statement looks like this. We have the if keyword. Inside that keyword, that's a condition. If that condition evaluates to true, then statements 1 and everything before the else statement gets executed. But if, say, the condition is false, then everything underneath the else statement will get executed. We'll look into it in more details when we are performing the hands-on, but right now just understand, if the condition is true, then statements 1 is going to execute, and if condition is false, will execute the else statement, which is the statements 2. Now, there are many ways you can construct an if statement depending on the logic that you're trying to build. You can construct a nested if else statement, you can construct if else and else if statements, you can construct a lot of different kinds of if else statements. So you're not limited to just use if and then else and then your conditional statement ends. You can use if this not true, then if this is true, then if this is true, then if this is true. Then you can take a look at a lot of conditions that way, or you can nest them one inside the other. That would work just fine as well. So now let's take a look at some conditional statements. Again, we have the same setup. We have an app.py file. Py is the extension for the Python executables or the Python scripts that we write. So to write it, let's first take a look at conditional statements. So there are a few keywords that we use in conditional statements. Keywords like if, else, and elif, which is short for else if. So let's take a look at this. So let me define a number named x and it's equal to 20. Now if I check if x is less than 20, then I will print x is less than 20. Else, and now else print x is not less, or you could say x is greater than 20. So now this is a statement, but it's a little incorrect. I mean, it's not incorrect in the way the syntax is structured. So if I write this, it says x is greater than 20. And we know that's not true because x is not greater than 20, it's actually equal to 20. This is where the else if statement comes in. So we can add multiple conditions and attach code to it that will execute when one of the conditions satisfied. So if I type elif x is equal to 20, and remember to put two equals, mainly because we're not assigning a value, we're trying to check whether or not a condition is correct. Print x is equal to 20. Where on this again is correct. So this is where if, elif, and else come into play. If for condition, and a conditional statement will always start with if, not with elif, and neither will it start with an else. Then we'll check, okay, if this is not true, else, if this is true, then do this, and if this is true, then do this. Make sure that you understand that only one of these statements will get executed. So in no condition will it happen that this will also get executed and this will also get executed. So if I were to do x is less than, and if I run this, it's still going to execute the first statement, which is x is less than 20, even though the second statement is also true. So make sure that you understand that. And now let's take a look at nested else if. So this is what it looks like. Again, I could have made the same mistake. I could have just put equal and that would have caused an issue. Now, nested else if basically means an if statement, and I want to check if x, let's say x is less than 20 and is less than 15 as well. And I put it 10. So I will print something out there as well. X is less than 15, and I can type in else. I can write some code. X is greater than 15, and finally else. X is greater than 20. So if I run this, x is less than 10, 20, and x is less than 15, which is true. Now if I were to give it a value something between 15 and 20, x is less than 20 but is greater than 15. So what's going on here? Let's take a look at the path of execution. We assign a value of 17 to x. We check this condition. We check if x is less than 20. it is less than 20, we go down, we print x is less than 20. We go down, we check x is if it's less than 15. It's also true, so we go down and we print this. We skip over these statements because one of the conditions has evaluated to true. We go down here, and since that condition has also evaluated to true, it's fine. But now if I type x is equal to 21, what do you think will happen? Just one statement gets printed because it comes here, sees if x is less than 20. Well, x is not less than 20, so it just skips over everything inside if and moves to else and prints that, and it's done. So this is where nested if statements and else if statements come into play. You can nest it really deeply, but your code becomes really difficult to read if you can do it like this as well. If x is greater than 15 or something like this, and then again underneath that you can type another if, but it makes your code really difficult to read. So make sure that you understand the trade-offs when you're using if and else if statements. Now let's take a look at looping statements. So a loop is a process in which we have a list of statements that execute repeatedly until it satisfies a condition. So let's say that I want to print something 50 times. Instead of me having to write it one time and then copy and paste it 50 times, what I can do is I can instruct my Python program to repeat something or repeat printing something 50 times, and that way when the condition that is satisfied is that it has this statement been printed 50 times. If it has, then we print that. If not, if it hasn't been satisfied, then we keep on looping and keep performing the task that is inside the loop. And if we have satisfied the condition, then we exit out of the loop and move on to the next statements. So there are many kinds of looping constructs. The first thing is we have a for loop. So a for loop basically allows us to write code in which we can basically iterate over a lot of things. So this is what the flowchart looks like. We take a look at the variable and we check, is there a variable in the list, and if it does not have any variable that are remained to be performed the task on, then we perform the rest of the code. Else we perform the statements, we move on. We perform the statements, we move on, and we keep doing that over and over and over again. This is where the looping statement comes into play. So then we'll have an example of this when we're performing the hands-on, so don't worry if you don't understand it as of now. Then comes the while statement. So the while condition is something that is also used in loops, but the fundamental difference is while loop is used to loop over a bunch of statements in which what we're trying to see if a particular condition is true or not. Instead of looping over a particular list of things, we can just use a while loop and loop over some things until a specific condition is true. So here what we're doing is we're setting a variable a to 1, then we're checking whether a is less than 5. So 1 is less than 5, we print 1. We add 2 to a, so a is 1 and 1 plus 2 equals 3. So now a is equals to 3. Is 3 less than 5? No, it's not. So the condition evaluates to false and we print it. So we print 3, we add 2 to it, 3 plus 2 is equals to 5. So a is now containing the value 5. We check whether 5 is less than 5. That's obviously not true. A is equals to 5. So we end the loop, and since there are no other statements left to be executed, we exit the program. Now when we're looping, there are certain keywords that help us in the loop. These are break and continue. So what do they mean? Well, the break keyword allows us to end the loop prematurely. So let's say that I have a list of names. Let's say that I have a list of names from a list that contains alphabets from A to Z. What I want to do is I want to print everything in the list, but if the character in the list is D, then I want to stop the loop. I want it to not continue any further. I want to just exit out of the loop. Anything after that is not going to be printed. So this is where the break statement comes in, and it's coupled with an if statement. And we'll take a look at this in an example when we're performing the hands-on. But now just understand that if you have a condition in which you want to exit a loop abruptly or prematurely before the loop has actually ended, then you can use the break statement. The continue statement, on the other hand, does something quite similar. So you can take a look at the break flow chart as well if you are unfamiliar with what it's doing. Basically, we check a condition and we check the break condition. If the break condition is true, then we break it and exit the loop. If the break condition is not true, then we continue with the loop as long as possible. Again, this is a bit esoteric, so I'll explain it in the hands-on when we're performing it with the code. Then comes what we'll try to do, which is looping and using continue. So continue does something similar to break, but instead of breaking the entire loop, what we do is we skip over that loop. So let's say that I'm again doing the same thing, a list containing all the alphabets from A to Z. I want to print it. They are ordered in any way that you like. What we're doing is we're taking a look at the alphabets and we're printing it on the screen. But if the alphabet is D, then we don't want to print it. We don't want to perform anything that's being done to other alphabets. So what we do is we take a look at it. We see, okay, if the current character is D, then we use the continue keyword and we skip over the rest of the statements that are used to execute the loop, and we just move over to the next character. So that's what continue does. And now we'll take a look at a hands-on in which we'll be performing tasks using all the keywords that we have discussed as of now. Let's take a look at some loops. So again, we are in our app.py file, and I'll write some code for you to run to understand loops. So we'll take a look at for loop and while loop. The first thing I'd like you to see is we're going to be printing a number from 1 to 10. So let me just show you. So this is a classic example of loop for x in range. Range is a pretty common function used in Python. If you've never used it, I would suggest getting comfortable with it. It basically means, I'll explain the code in a moment. So what we're doing here is we're instructing Python that, hey, I want to loop over something. Every time the loop iterates, I want the value to be stored in x, and what I want is the range to be going from 0 to 10 minus 1, which is 9. Always remember, range is exclusive of the end. So if I were to type 11, that will go from 0 to 10. So that is done. Now what happens is when I print x, what it will do is it will start ranging from 0. So it takes a look at 0, prints 0, goes 1, increments it by 1, goes to 1, prints 1, 2, 3, 4, 5, 6, 7, 8, and it goes to 9, prints 9, and then it is out of range, so it stops abruptly. So let's see. If I were to run this, as you can see, it's printing, but let me show you a trick. When you're printing something, type the end equals comma, right? So in space. So now if I print this, instead of each thing being printed on its own line, what's happening is it's going to print it with a comma and a space between the next element. As you can see, that's the reason why there's a comma and there's space here as well. So that is done. And so this is how you loop over a range. But let's say I don't want to loop over a range. Let's say that I want to loop over a list of numbers. So again, nums equals 1, 2, 3, 4, 5, right? Or if you remember with comprehensions, x for x in range 0 to 10. Now we have all the numbers that we had earlier, and this is what it looks like. I run this again. Okay, for x in range, and now it's doing the same thing. So we have numbers here, and for each number we are looping over that. Now that that is done, one thing I can show you is after looping we can take a look at some of the statements that we had learned earlier. So break and continue. So let's say that I only want to print till 4. Let's say that this is a shuffled list and I want to break the loop and not print 4. So if x is equals to 4, then break, else will print x. So I do this 0, 1, 2, 3, it encounters 4, and since the condition is satisfied, executes the break statement, gets out of it, and the program is not ended yet. If I want to type something below it, I can type like this, done, and it prints it there. What's happening here is I have just as soon as I encounter the number 4, I just quit the loop. So everything that's after 4, it's not being executed in the loop. If I change break to continue, notice what happens. So we have 0, 1, 2, 3, 4 is skipped, then we have 5, 6, 7, 8, 9. So what happens, it takes a look at the number, it's 4, and we continue. We say we don't want to print 4, we move ahead. So this is something that can be helpful. Let's say that you're trying to print something out of a list, and you don't want to print the name of people whose salary is less than, let's say, 40K. So what you can do, if person, let's say that for each x0 index is x dot salary is less than 40, then continue. So this would have the same effect as it did earlier. This is what it means. So this is where we move on to the while loop. So let me just define a number is equals to 10, and instead of 4 we'll use a while loop. While a is not equal to 0, print a, and then a minus equals 1. So if I run this, it prints numbers from 10 to 1 in reverse order. So what do you think is happening here? So basically I have defined a variable named a, and I'm checking whether or not it's equal to 0. If it's not equal to 0, then perform this task. One thing that you need to make sure is if you're trying to check whether something is equal to something, and if it's not, then you need to manipulate it inside the loop. If I don't do this, then this will run forever. As you can see, it's going to keep printing on 10. I've interrupted it using Control C. I don't want it to run forever. So if I do this, then it understands how to do this. It'll take a look at the number. It's 10, print 10, and in decrement 1, it becomes 9. 9 is not equal to 0, print 9, go ahead, remove 1. 8, not equal to 0, print 8. 7, and this is how we go till 0. We print 1, then we in decrement 1, which becomes 0, and we take a look at this. So we go, okay, is 1 equal to, is 0 equals to 0? That is true. So this statement evaluates to false, which is not equal to 0. So what happening is we are printing the things until this statement becomes true, and when a becomes 0, this statement becomes false, and we move out. So as long as this evaluates to true, our loop is going to continue. Another way of reading is, while this is true, keep executing whatever we are executing. So that's a while loop. Now, why use while loop over for loop? There can be many scenarios where you want to use for loops. I like using for loops mainly when, as you can see, if I can travel back in time. Yeah. So mainly I like using for loops when I have a list of values, something that I can easily access in a loop like this. Doing this with while loop would be a little difficult. Let me show you how. So I would need to have an index, start it with 0, and check while index is not equal to the length of nums minus 1. That is one way to do it. Or you can check if while index is less than nums value minus 1. I will print nums, the value is at index, and I will index plus equals 1. If I run this again, it will do the same thing, but I had to write a lot more code, and I have to keep track of this index variable. Similarly, Python's for loop does all of this behind the scenes for us, so we don't have to manage these external variables and all that for us. There's advantages to this, but if you want to if you want to have access to the index variable, then you can use a while loop, or you can use a clever for loop as well. But for most scenarios, when you have a list of values that you can iterate over, using for loop is better. And when you have working with a specific condition, then using a while loop is better. So it's completely up to you. It's your choice. Whatever feels the right tool for you, you can use that. But I would certainly recommend using for loops for iterable statements. Right, now let's take a look at functions in Python. So functions are one of the most fundamental things that you need to understand when you're learning any programming language. They allow you to encapsulate code and then reuse it in many other parts. We'll take a look at what that means and how you can accomplish things with functions. But the first thing that you need to understand is that it's a very, very, very important topic, and you need to get a really good grasp of how functions work before you can move ahead and discuss other things and learn other things in Python. So make sure that you pay attention and understand it thoroughly. So a function is a block of code that is organized in such a way that it's reusable set of instructions and can be used to perform some related set of actions. So it's used to organize a reusable set of instructions that are used to perform some related actions. So we'll take a look at what that means. Basically, it means that we wrap up some piece of code that is entirely used to perform one thing, and that is then used, that wrapped up piece of code is then given a name, which is the name of the function, and then we use that name instead of copying and pasting the entire code. Again, we'll take a look at what that means and how to accomplish this. If you don't understand it as of now, don't worry. So there are two kinds of functions in Python. The first is a user-defined function, which is something that we create as developers, as programmers. And then there are some functions that are built into Python. So you don't have to create their implementation yourself. Python will have already done it for you. So the user-defined functions, as I've already told you, are created by users. This is what the syntax looks like. We use the def keyword. Def is a shorthand for define. We give the function name. We accept some arguments. These arguments are basically values or things that our function will perform some actions on. And then we do some calculations or any other kind of task that we wish to perform. And finally, and this is not a necessary statement, but if you want to return something, you can do that. Returning something basically means this would be the result of the function. Now sometimes your function may not have any result to perform, and if that's the case, then you don't return anything, you just omit the return statement completely. To give you an example, there's a function right beneath it that says def add is the name of the function. We pass in two parameters, a and b. We create a sum which is equals to a plus b. So anything that we have a plus b, and we return the sum. Now, to be quite honest, this is a very trivial example, but to understand how functions work, we need to move our way up from really simple to complicated examples. Now, there are many built-in functions as well. These functions have already been written by the developer of the Python language, and they have created these functions for us to use. So some of them are these. We have an abs function, which is used to store the absolute value of a number. So if you have a number that is in negative, that is negative 17.4, then if you use the abs function on that, you will get 17.4. Absolute basically means it converts negative to positive. Or in other terms, you can get an absolute value where you perform some mathematical operations on it. Then you get all, and returns true if all items in an iterable object are true. So if I have a list of a list, and everything inside that list is true, then it will return true. If any one of them is false, then it returns false. Then we have any, then we have ASCII, then we have bin, which is used to take a look at the binary version. We have bool, we have many other functions, min, max, whatsoever. So you can use them if you wish to. If you are trying to perform some task, make sure that there is a instead of writing your own function, make sure that there is a function available for you. Then there's lambda functions. Now this is a concept that gets overlooked quite often, but lambda functions are very powerful. So lambda functions are basically anonymous functions that have no name, and it contains a single expression. A single line of code is there in a lambda function. So these are used to pass some task that we want to perform in a function. Let me give you an example. So this is how lambda functions can drastically improve the readability of a code. So let's say that I want to create a function in the way that I have done as of now. So I want to create a function called multiply. So I can do it using multiply, def multiply x comma y, and then I return x multiplied by y. But if since you can see it's a very simple line of code, I can simply just do r will be the variable that will be pointing to the lambda. lambda will accept x and y as parameters and will return x multiplied by y. Now to call the lambda, all I have to do is use the r, which is the name of the lambda, and I put parentheses in outside, and inside the parentheses I pass in the two statements. If I don't put a parenthesis, then it would simply be a variable that holds something. I'm not calling the function, I'm not executing the code that's inside it. So I pass into N3 and I get 36. Now another thing that lambda does really well is that it allows you to remember some things. So let's say that I have created a function called def my function. I pass in a number named n. This number now will be remembered by the lambda that I have created inside that function forever. So if I return a lambda in which I will accept another parameter called a, and what it will do is it will take that number and add n to it. This way I can create multiple functions that do the same task but where the value of n is different. And this is very trivial example, by the way, very mundane, but you can think how far you can take it. There are many great Python programmers who use lambdas in very clever way to write code that's very readable, quite simple, quite easy to understand once you understand what lambdas are, and it's quite comprehensive. Take a look at a function that's so simple to understand. So take a look at that as well. Now let's take a look at some functions, and we'll implement some functions in Python. Again, we have the same setup. Here we'll define a function. So let's say that I have some task that I want to perform. Okay, and it has several steps, and all of these steps will need to be performed regardless of where I execute the task. This example will also show you the importance of functions. So let's say that I want to download file. Okay, and URL. Now I'm not going to actually download the file, but I'll just print the steps. So establish connection. Then these are the typical connection steps you need to perform when you're trying to download a file from the internet. Open the connection, download data, close connection. So now if I want to download anything, any file, let me just print the URL. Or another thing I'd like to show you is that you can add strings or concatenate strings. So this way. So if I do this, then it will print establish space connection space and then add whatever URL is right at the end of it. Open connection, and let me print the URL, download data, and close connection. Alright, so if I were to call this function download file, and let's say that the URL is ftp : www.abc.org. Now if I were to run this, let me just run this here, it's going to perform these tasks. But the major advantage of using a function is now if I want to perform the same task over some other place, I can copy and paste it into different files and it will do the same thing over and over again. So if I were to print this, as you can see, it's done everything for me. Let's say that I want to change the URL def.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
IJK, and if I run this, it's downloaded it for all different purposes. But now let's say that I want to change something in this step. After downloading it, I want to log it to some place. Let's say I want to make sure that this is recorded in a database that I had downloaded this file. So log to db, and this is the URL I downloaded it from. Now if I run this, as you can see, this change, let me just so I've added 2 lines, so this is what it looks like. Now it looks a bit clear. Let me clear the screen and run this again so that you can see, and it's downloaded it but as you can see that this step is now added to all three of the files. This is the advantage of using a function. So whenever you want to make a change to some particular step, some particular well-defined process, you can just make a change in one place, and everywhere that process is being performed, those changes will be reflected there. So if I had to add something else to the download file procedure, this will be executed by all the functions or all the files that are calling the download file function that I have just described. So that's one advantage. And now let's take a look at returning some data, right? So let's say x comma y. I get in two data and I perform some task. Now I want to return x multiplied by y. Let me call it, again this is a very trivial example, multiply, right? And if I want to multiply two numbers, multiply, you multiply x and y. Now x and y are going to be numbers, so let's say 15 and make 10 comma 15. Now if I were to run this, 150 would be the expected answer. If I were to run 25, 250 would be an expected answer. So we have gotten both of them. But one thing to notice is that it's a really simple function. So defining it like this is going to take a lot of time and it's really unnecessary. So one way you can change it is you can write it like this. Let me just show you the code that was earlier there. And I am just going to change it to multiply equals to a lambda that will take in x and y and return x multiplied by y. Run this again and this is performing the same tasks that we had performed earlier, and it's printing the same thing that we had printed earlier. So there's no change in functionality, but we have changed the implementation. So what is the advantage? Now this function I can send as an argument to any other function. This is where it gets a little difficult to understand. So let's say that I want to print. Let's say that I want to, one thing I can do is def create multiplier, and it will give me x and y will be given to me on the time of execution. So now what I can do, I can return a lambda that will take y as a function and it will return x multiplied by y. So let me just delete this. Now this works, and now I will create multiply, create multiply 10, and now I will just pass in 15 and 25. I run this and I get the same answer. Now as I've already told you that this is a function that you can pass into another function. Let's say I create another function named execute, takes in a function and takes in an argument, and all it does is that return calling that function with that argument. So execute 15 would be the other argument, and multiply, and we want to execute. If I run this again, it's doing the same thing, but it's doing it for me. Now I can make changes to it. I can basically log the calls to a console called f with and okay, I've gotten an error. Yeah, I need to convert it to a string. Now it works. So it called f with 15 and it called f with 25. So I can log this to a database to make sure that it's being executed correctly and so on. So there are multiple things that you can do, and lambdas are actually very powerful, but this is how you get started with it. Hopefully this was informative, and let's move on to the next. Now let's take a look at arrays in Python. So in Python, arrays are basically lists. Arrays are used to store multiple values in a single variable. As we've already taken a look at tuples and lists and dictionaries and sets, we'll be taking a look at a lot more in a future video, but arrays are basic programming constructs. In Python, you have arrays in the form of lists. So you don't call them arrays, you call them lists, which sounds more readable and more intuitive. So Python does not have a built-in support for arrays, but Python lists can be used instead. So you can, instead of creating 3 variables to store all the 3 strings as we have done in the code listed below, like this, we can do it in an array, and we can just use them ourselves. So there are many operations that you can perform in an array, and we'll take a look at all of them one by one. First is we can access an element in an array. So accessing an element basically means we'll be accessing it using its position in the array. So if it's at the first position, we use the 0th index. 0 is the index is the number inside the parentheses after the array name. Similarly, if it's the second, then we use 1 because it's indexed from 0. And if we use an index that's not present, then we get an error, index range error, I think it's called. Then there's modifying the element. Now, if you're using a tuple, that's not possible, but in lists, it's completely possible. So instead of doing something else, you could just modify the element using the same thing that we did previously. You can take a look at the length of the array. Length basically means how many elements are there in the array. We can loop over an array and perform tasks the way we want to. We can add an element to an array using the append method. That would add an element at the end of the array. We can remove an element from a given position. So we could go cars, which is the name of the array, dot pop 1. This will remove the second element in the array. If I were to not give an argument, then it will remove the last element automatically. Instead of passing in 1, if I had passed nothing, then it would just remove BMW from the cars array. Then we have removing specific elements. So if I have a specific element that I want to remove, I can use the remove method on the array. And we'll take a look at all of them. Then there's Python classes and objects. So classes and objects are quite interesting. They're very easy to understand. They're quite interesting to use, interesting to see, interesting to build applications out of. They are the fundamental building blocks of object-oriented programming, and we'll take a look at that in a later module. But here you need to understand what classes and objects are. So a class is basically a container or a blueprint that defines what an object should look like. And the object is basically the in-memory representation of a class. So since Python is an object-oriented programming language, almost everything in Python is an object. And it has properties and it has methods. So class is like a blueprint for creating an object. So in the example, as we see, we have given a class, created a class. And we said whenever you create an object of a class, this should have a property named X, and the value of that property should be 5. Now this is a very, very high level overview of classes and objects. We'll go into much more detail in a later video. But here you need to understand that classes and objects are how they are related. Classes are the definition. Objects are the concrete implementations. Objects are what you use in the real world. Classes are what define what your object's structure should be. And then we come to file handling. So what is file handling? Let's take a look at that. So file handling is one of the most important aspects of any application that you use. It's used to permanently store data on a disk or on network location or anywhere. We will need file handling if we have to read or write from the files. Python provides a really easy way for us to read and write to files. So there are many file operations that you can perform. Some of the most important ones are opening a file, reading a file, writing a file or creating a file, and deleting a file. So to open a file, the syntax is quite simple. You use the open method that takes in 2 parameters. First parameter is the path to a file, and the second parameter is the mode. So the mode basically is a single a string that is either R, A, W, X or something like this. If you pass in R as the mode, the file is opened in the read mode. That basically means that all I want to do in this file is I want to read from the file. I don't want to make any changes. I just want to read the data. The A mode makes it append. This means that anything that's existing in the file, don't overwrite it, just add data at the end of it. Then there's W, which stands for write. This opens the file and creates it if it doesn't exist, and it overwrites any data that's already existing. So that's the difference between writing and appending. Appending adds data to the end of the already existing content in the file. Writing will overwrite everything. Then there's X, which basically just creates the specified file, and it will return an error if the file already exists with the same name. We can read the file using the read method. This will read the entire all the lines from the file into and show us that. We can also specify how many lines we want to read, and if you want to read it line by line, then we can basically just loop over it, and we'll take a look at all of that in the hands-on. Then to write an existing file, we must add a parameter to the open function. Now A would be, as I've already told you, to append a file, append items to a file, and W would be to write contents to the file, right? Then there is delete. Okay, so X is used to create a file if it doesn't already exist, and if it does already exist, then it will return an error. And finally, we come to delete. So deleting is basically allowing you to remove a file or delete a file that already exists. You can do it using the OS module. You can write os.remove, give it the path of the file. It'll check if the file exists, and if it does, it will be removed from the disk. So now finally, let's take a look at the hands-on of file handling. We'll take a look at what it means and how you can perform file handling in Python. As of now, we only have app.py file in our hands-on folder. So let's first try creating a file. So I will create F as the file handler. Using the open function, I will write in the file name. Let's say it's sample.txt. And I want to create it, so I will use the X flag and I will close it. Closing the file is important because all the changes that have been made so far are made in an in-memory buffer. So when we use f.close, all those changes get written to the file. So make sure that you close the file so that the changes that you made to the file gets persisted. Let me remove that. Run this, and now if I take a look at it, as you can see, sample.txt is already created. But if I run it again, I will run into an error that says file exists, which means that the file that I wanted to create is already there. So now that we have done that, let's try some other tricks. Now the problem is, whenever I use the open keyword, it's obvious that I want to close it as well. So instead of me having to write f equals to this and then write everything and then close it, I can wrap everything inside a with keyword. So with open file, and I want to write something to it as f. Now anything that I write within this block and it's indented, that would mean that I want to, after this block, I want to end or close the file. So instead of me having to manually write f.close, this will be done automatically for me. So let me just do this. Now let's just f.write, and what I want to write is sample line. Save it, run it. It's done. If I open, Control B, open it, and it's sample line written to it. But let me just add a backslash and then write sample line again. See what happens when I do this. I run this again and I open it. It enters sample line and then enters a new line. But if I were to then write something else, or if I were to run the same code again, this would cause, it won't be the appropriate thing that I want to do. So if I do this again, it's got the same thing. Run it again, it's got the same thing. So instead of this being added to the end of the file, what's happening is the file is being opened, everything inside it is being removed, and then this is being added to it. But what I can do is, if I remove this, put it backslash n, and I type a. Now if I run this once, and if I open sample.txt, it's there. As you can see, I've added a new line and here, and then remove a new line. Let me just remove it completely. Run it again, open sample.txt, there's a new line. Run it again, another line. And if I keep running this multiple times, as you can see, multiple times the line has been added at the end of the file. So that's what the append method does. Now if I were to just read from it, so for L in f dot read lines, and all I want to do is print L. As you can see, it's printing the thing that I want to print. If I were to just remove the backslash n from my side, this will print each line with a backslash n. So this is what it looks like. So we are able to read from the file, we are able to write to the file, and we are able to do a lot of things. So with that in mind, our file handling is done. Obviously, there's a lot more that you can do with the file handling things, but this should help you get started. It's very easy in Python, as I've already told you. Use the with keyword to avoid having to write f.close on every file handle that you've opened. If you don't use the with statement, then make sure that you're closing the file before ending the script, or your changes will not get written to the file that you're trying to write it to. So let's see what else you have to do. Alright guys, so now we'll take a look at object-oriented programming, or OOP, in Python. So let's take a look at the agenda. We'll begin by understanding what is object-oriented programming, and we'll get an introduction to what it is. Then we'll take a look at a real-world example of object-oriented programming. Then we'll move on to object-oriented programming concepts, the fundamental concepts like classes and objects. Then we'll learn about inheritance. Then we'll learn about encapsulation. We'll learn about polymorphism, and then we'll move on to learn about modules, standard library in Python. We'll learn how to install packages that you might need to use. And finally, we'll learn about exception handling, which is one of the most important concepts in the entire of Python. It allows you to write code in a way that manages errors on runtime. So we'll take a look at all of that. So let's move it. Let's take an introduction to object-oriented programming. So object-oriented programming is a programming paradigm where you can use a real-world entity which is called an object. So object-oriented programming is basically about mapping a real-world object in our code. So let us consider an example. Let's say that we have an object for parrot. Now a parrot has certain attributes and certain behaviors. Attributes are basically data about the parrot that we are interested in. So data such as name, age, color, and this data can be arbitrarily selected. Only the data that you need about the parrot needs to be in the object. So there might be other data about the parrot that you might not need. So the data such as the species of the parrot and so on, if you don't need that, you don't need to include that. And then there's behavior. So singing, dancing, or any other kind of behavior that a parrot might have could be attributed there. A behavior is basically a thing that the object performs, some task, some process that the object referring to the parrot performs. So let's take a look at an introduction to object-oriented programming. And now we'll be taking a look at basic principles of object-oriented programming. So some of the basic principles are polymorphism, classes, inheritance, encapsulation, classes, and object. Let's have a real-world example of object-oriented programming. So as a human being, we can be classified into a male and a female, and these are the common functions between men and women. They can speak, they can hear, they can walk, they can see. So now if we consider a human being as a class, so a class is basically a description of what an object should be like. Think of it as a blueprint of the house that describes what the house should look like, how wide should a room be, what should be the dimensions of a room, how many rooms, how are they connected with each other. That's what a class is. It's like a blueprint that objects are created from. So every human being has certain body parts: nose, hands, legs, heart, eyes, and so on. And they have some common functions as well. They can walk, they can listen, they can speak, they can see, they can smell. So these common features are called attributes. So attributes are basically data about the person. So as you can see, the person's name, age, and all that could be considered an attribute. On the other hand, they could have certain behaviors as well, and we'll take a look at that as well. So male and female are inherited class from human being. So a human being is supposed to have certain features that is these features are inherited and the specific things that make them different are then overridden. Let's give an example. Let's say that there's a person who's a male and the name is Victor and the age is 24. Now we can have an object of the class male and we can have attributes such as name and age associated with it. So class is just a logical definition. Objects are the physical in-memory representation of that physical existence. Then you don't need to know the detail about how you walk, how you talk, how you listen, and so on. These decisions are hidden and encapsulated. Encapsulated basically means that they are not visible to the person and they are bounded together with the data that they operate in. So for walking you need two legs, for hearing you need ears, for seeing you need eyes, and all of that is encapsulated or grouped inside a single entity or a single object. Now, on the other hand, the class of a woman can be a wife, a mother, or a teacher, or any other profession that they can espouse, and at the same time, having being able to perform so many tasks at the same time. This is what is called polymorphism. So let's take a look at classes and objects. We'll take a look at other concepts such as encapsulation, polymorphism, more detail in later slides. So, what are objects and classes? Well, class is like a blueprint of a house, and object is the actual house that has been built from that blueprint. So you can think of a class as a definition of what a house should be like, and then the object is basically a concrete implementation of that house or of that blueprint. So object is the basic unit of object-oriented programming. It should be clear by the name object-oriented programming that objects are the basic unit. Now, an object represents a particular instance of a class. There can be more than one instance of an object. So, for instance, if you have class, you can have 7 objects of the same class. There can be multiple instances, and all of those instances are called an object. Now, each instance of an object can hold its own relevant data. So, if you have 7 houses and they can all hold data about the color of the walls, they can all be different. So, that's what the difference between classes and objects are. And we'll discuss more of it when we are performing the hands-on and understanding the code, but as of now, that's what this is. Now, objects with similar properties and methods are grouped together to form a class. So this is what our classes and objects are. So how to create a class in Python? In Python, the class, we use the class keyword. We then give the name of the class, and then we just underneath that, we define the variables and all that for in an indented code block, and the attributes are the variables and the behavior is the function. So let's move ahead and see what all of these mean. Now after that, if you want to create an object, we can just call the class like a function and it will return an object to us. And there are a lot of more intricacies in that which we'll discuss in the hands-on, but as of now you need to understand that this is what this piece. Now here object 1 is an object of the class with the name of class name. So how to access class members is one of the most important concepts. So you can create an object and using the simple class, and then right after the class you can put parentheses like you're calling a function. It will return an object to you, and in that object you can use the name of the class member which you want to use. So as we know that we had created a variable named variable inside a class name. So after that we create an object. We use the object name. We use the dot operator which gives us access to the members of the object. And then we click on that and we create I was just created. And that way we have several objects here. Now we print them and this is what it looks like. And now let's move ahead and see what this means. So there's another thing called the init method. This is one of the several magic methods that are present in Python, and we'll discuss those as well. The underscore underscore init underscore underscore method. This is also called a magic dunder method because it's got 2 underscores right at the beginning and right at the end. This is a special syntax for special methods that are supposed to perform special tasks. So to give you an example, we have an underscore underscore init method. This is also called a constructor method. This is a method that gets called the first time when the object is created. So when you create an object out of a class, this will get called automatically. So as you can see, we have defined a class, we have defined an underscore underscore init underscore underscore method. This is also called a constructor method that takes in a certain parameters. Self is the object that will be created and returned. So if you want to make some changes to the current object, you can do it here, such as attaching some properties. So we are adding some name, branch, and year to the current object. We print a student object is created, and then we send it back to the user. So when we create an object, these things get set to the object, and then that object is returned and assigned to OB1. And then we use the print details method, in which we pass in self, which is the object current reference to the current object, and then we print the name. As you can see, this is what it looks like. So here's some test for you. So create two vehicles called car 1 and car 2. We can set car 1 to be red, convertible, worth $70,000 with the name of Ferrari. We get car 2 to be blue. It should be a blue van named Jeep and worth $15,000. How do you do that? Well, we create a class named vehicle. After that, we define the name and kind by default, and we set the color there. We get the description defined there as well, and then we return the description. So now our code will go there. We will create new classes, and we'll create objects, and we'll print them. So how do you create an object, and how do you set these objects, and how do you do that with the vehicles? So we'll have to perform that, and in the hands-on, let's see how to do this simple task. So to give you an example of how things are working, we have an app.py file which is inside a folder, and I'll be running command prompt here. And now what I have to do is I'll show you what classes and objects are like. Let me create a class, the name dog. And if I were to create an underscore underscore init method, and what I'll do is I'll accept the name for a dog. Self.name equals name, and that's it. Def I'll create two behaviors. So a dog can talk, and the voice that a dog makes is woof, and I think I'll have to expect a self parameter. Always remember, when you're defining a method in class, the first parameter needs to be the self parameter, and this is injected by default. So you don't have to pass in any current objects or anything like that. And this will be done for you by the Python interpreter. So let me just correct this, and then I'll create another web function called print name. Now again, this will need a self parameter, and what I'll do is I'll use the print method, and I'll get self dot name. Now let me just show you a trick. So we know how to concatenate strings. Let's see how to interpolate strings. Interpolation basically means we create a string, we leave some places there to be filled with data later, and that will be filled by Python. We provide the data. So let me show you. So I say my name is, and I put this two curly braces. So I open a curly brace, I close a curly brace, and now I use the dot format method, and I pass in self.name. So what will happen is Python will look at the string, it will go my name is, then it will take a look at these curly braces, and it will understand that I want to provide some data to be replaced for this curly braces to be replaced with. And in the dot format method, I pass in the data, which is self.name. So now let's call the function. So let me just create a dog, which is the class that I had just created. This will require a name. I'll call it Charlie. I think I ran it by mistake. So the name of the dog is Charlie, and now I can call the actions. So if I call dog dot talk, it will print woof, and if I type dog dot print name, save it, and now if I run it using this, I can just type in Python HON and the name of the file is app.py. I press enter, and as you can see, I print Wolf, and my name is Charlie as well. Now, another thing that you need to notice here is that this method has a special meaning here. So this gets called automatically whenever I create an object. So if I were to create another object, let me just print something here just to make print object with name created. Now I use the format method again. Sorry. And in that method, I'll pass in the name. This is done, and now this dog was created. I create another dog. Let me call this Bruno. And Charlie and Bruno. And now Charlie will talk, then Bruno will talk. Then Bruno will speak its name, and then Charlie will speak its name. Now that is done, watch what happens when I run the code. So object with name Charlie gets created, object with name Bruno gets created. So as we have created Charlie first and Bruno later on, this function gets called for Charlie, this function gets called for Bruno. We create both the functions, then we print then talk is the method that gets called, and first Charlie talks, then Bruno talks, and then we ask them to print their name. So Bruno prints their name, and then Charlie prints its name. So this is what it does. But another thing that I'd like to show you is if I print it. So if I were to print Charlie, now these are objects, these are not string. So if I print both of them, what do you think will happen? And we get the name of the class, and this is the class of dog, and we get the IDs. So that's not very helpful. What if I wanted to print, whenever I print Charlie or Bruno as objects, I want to print their name, right? So what I can do is, since we're in a class and we have magic methods, I'll show you one more. It's called str. And what I'll have to do, I'll return some string. Here all I have to do is return self.name and run this. And as you can see now, instead of printing that long string of a name and class name and all that, it's going to print the name of the dog, or the object of the name of the name attribute of the object. So this is what it looks like. There are many other magic methods, and I encourage you to check them out on the documentation page. But as of now, I would definitely suggest that you read more about it. This is what it means. Hopefully the topics that I want you to get away with is the constructor method, how to create a class, how to create an object, how to call methods on those objects. Now these two objects, instead, they don't have the same, they have the same structure, but the data in them is different. So the name, the attribute name is different for both of them. This is why when we call the print name method, Bruno prints Bruno and Charlie prints Charlie. So make sure that you understand that as well. It's a difficult concept when you're starting out with programming to get around, but once you get the hang of it, it's very easy. So with that in mind, let's move on to the next topic. All right, so now let's take a look at inheritance in Python. So inheritance is basically acquiring properties or behaviors of another class. The class that is being inherited from is called the parent class, and the class which is inheriting things is called the child class. There are many other terminologies. We will take a look at them one by one. So to give you an example, you would have inherited a few qualities from your parents, and they would have inherited certain qualities from your grandparents, and this would have kept going on however long your family chain is. Now in a family tree, traits such as hair, color, eyesight, and anything other than that gets passed down from generation to generation. So this is what inheritance means. There are many different kinds of inheritance in Python, and we'll take a look at them one by one. But for context, these are the 5 types of inheritance. We have single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance, and hybrid inheritance. So let's take a look at them one by one. So single class inheritance basically means that there's one parent class, there's one child class, and we inherit from the parent class and the child class, and the child class is the class that inherits from the parent class. So here's an example. Let's say that we have a class of fruit and then we have a class of citrus. So the class citrus inherits from the class fruit, and as you can see, the syntax is quite easy to understand. We create a class using the class keyword. We give the class a name, and right after the name we put the class that we want to inherit from in parentheses. After doing that, inheritance is complete, and then we can perform other tasks as well. So now let's take a look at multiple inheritance. So a class can inherit from multiple classes. Now this is not possible in many other languages, such as Java, but you can in C++, in other languages such as C++, and even in Python you can inherit from multiple classes. Just be very careful. By inheriting from multiple classes could cause a lot of issues if you're not careful. So make sure that you understand that. So we have a class A and we have a class B, and we want to inherit from both of them. So to do that, we can simply, instead of just passing in one class's name in the parentheses like we did earlier, we can pass it multiple classes name and separate it by comma. So that's how you can inherit from multiple classes. Then there's multi-level inheritance. So multi-level inheritance is just single inheritance repeated multiple times, or repeated in different combinations of classes. So let's say that I have a grandparent class, then a parent class, and then a child class. The grandparent class gets inherited by the parent class, and then the parent class gets inherited by the child class. So that's how the relationship goes. Just one class at each level is inheriting one other class. This is what multi-level inheritance means. So this is an example. Let's say that I have a class A and a class B, and I inherit from class A to class B, and I inherit from class B to class C. This is multi-level inheritance. And then comes hierarchical inheritance. So in this, one single class is being inherited by multiple classes. So just for clarification, your parents have certain qualities that get inherited by you and your siblings, your brothers and your sisters. This is a hierarchical inheritance. And your grandparents had certain features that get inherited by your parents and their siblings. So your father, your uncle, and everyone had inherited the behaviors, the mannerisms, or certain other qualities like hair color or eyesight from your grandfather. So that's how that works. And finally, we have we'll take a look at the code first. So we have a class A, and then this gets inherited by both class B and class C. And finally, we have a hybrid inheritance. Hybrid inheritance is basically a combination of any two kinds of inheritance that we had seen earlier. So if in the example we have hierarchical inheritance between classes A and classes B, C, and D, and then we have multiple inheritance in class E and class B and D. So this is how hybrid inheritance works. This is the code that explains the relationship that we had seen in the previous example, or somewhat the relationship that we had seen in the previous example. Class B and C are inheriting from class A, that's a hybrid inheritance, and class D inherits from class B and C, that's a multiple inheritance. So inheritance, when we're working with inheritance, there's a function called super. So what does that do? So let's say that I have a parent class of vehicle and a child class of two-wheelers. What I do here is that I use the super function, and then after calling the super function, I can access any property or method on the super class. So if I want to call a method from the super class, I use the super function. Super class is the class that I'm inheriting from the parent class. So I call that, and then I call the start function on it. Then I print I have two wheels, and then I call the stop method there. So when we come to inheritance, there are certain concepts like overloading and overriding. So overloading and overriding, separate concepts. Let's take a look at them one by one. Overloading is basically one function with different parameters. So we overload the function so that we can understand what kind of behavior we want. Depending on the number of parameters, a function will get called. So in the add function, if I type in 3 integers, it will call the second function. And if I pass in 2 integers, it will call it the first function. So there's another way of overloading a function. Instead of creating multiple functions with different parameters, what you can do is you can act on the function parameters based on the data type and the size of the data. So that's how you can do that. This is what's happening here with checking if it's an integer or a string. If it's an integer, then the beginning the result that we're about to return should be 0, which is an integer. So that when we add numbers to it, we don't end up affecting the result. On the other hand, we can assign an empty string to it if it's an instance of string. And then we perform the concatenation operator again and again and again, or add addition operation, and then finally we just return the result. Now we come to overriding. So overriding basically means changing the functionality of a function that we had inherited from a superclass. So let's say that I have a class called A. It has many functions. One of them is say hi. So it says I am in A. I create another class called B, inherits from class A, but I want to change the implementation of the say hi function. So I do that by defining another function with the same name and the same parameters, and then I print change the implementation, and now when I call the say hi function, the B class's version of say hi will get called. So let's take a look at some examples. Here's the code, and we'll take a look at multiple forms of inheritance, overloading and overriding. The first thing is I'll create a class named base. Let me give you a more intuitive example. Let's say that I have a class named person. Now person has several attributes. I will create an init function. Okay, now here I will firstly, the person is always going to have a name. Let's just keep it simple and keep it at that. So I will self dot name equals the name that is passed. So this object will now have a property name, which will be set equal to the name that the function that the user passes. And now def say name, which takes in self, and all I will do is I will print self dot name, and we are done. Now let's create another class. Now a person could be a lot of things. So let's say that engineer, and I will inherit from person. Now def self dot profession equals to engineer, and finally I can create another function, say profession, that will take in the self parameter, and we will print self dot profession, and that's basically what we're trying to do. And now I can create another class with a similar structure, and here this will be a doctor. So let me first complete the implementation for the doctor. Now one thing that I'd like to show you is this is single inheritance, right? So one class is inheriting from one class, and now if I create an engineer, so and if I print dot say name, so obviously I had not to pass a name as of now, and this is going to cause some issues. I want you to figure out why. If I run this, let me just run this. As you can see, I've gotten an issue. It says engineer has no attribute name. Can you figure out why that is? Let me tell you why that is. If you want to take some time and figure it out, pause the video and think about it. And if you'd like to know why this is happening, I'll tell you. So with the engineer, let me pass in a name first. So let's say the name of the engineer is John. The reason why is I'm setting the name, but this constructor function is not getting called. So I'm not setting the name property here. All I have to do to solve this is use the super function that we have already described, and using the super function I'm going to call the underscore underscore init method. Inside it, all I have to do is I have to pass the name. Now that that is done, if I use the function now, I'm calling the person's name John. So this is working, and we are working for fine as of now. Now if I were to use, instead of this, I were to use say profession, and I'm printing the profession of the person, which is this. Now the problem that I'm getting here is that I'm printing the return value, which is nothing. So if I do this, then it works. The name, if I remove this and I run this again, it works. So as you can see that this is what it means. Now if I were to do this again, and if I were to change it from engineer to doctor, I'll show you certain example of where inheritance is so useful. So I'll pass in the name doctor, and if I were to create a doctor, I have to change this here as well. And let me just name Dr. Jane, engineer say name, engineer say profession, and now I'll do the same thing, but instead of it being an engineer, I will doctor. Now if I run this, as you can see, John is an engineer, Jane is a doctor. So this is working. Now the major advantage of inheritance is that it allows us to remove code duplication. So instead of us having to copy this code into multiple implementations of things that require this, we can just reference it here. We're saying anything that's in person you can use. So now we're using this. So if I were to change the implementation, instead of it being just printing the name, my name is right. And now if I were to print this, as you can see, the implementation is changed in both of them. Imagine this is a large system and I have a lot of code. So instead of me having to then run through all the professions that I have and changing this in copying and pasting it in every file, I can just change it here and this change will be reflected in all the files. So that's the major advantage of inheritance. It allows us to remove code that needs to be copied multiple times, and we can safely change the implementation, and the other functions will work exactly the way they are supposed to. So that was multiple inheritance. But let's say I wanted a multi-level inheritance. So how would we go about doing that? So let me just remove all of this. Let me create a class. This is going to be a really generic example. Class A, and I will create init, pass in the self and print. Instead of printing, let me just pass. This keyword is used when I want to tell Python that there's nothing, no implementation here. If I leave it open, then I'll get some error. As you can see, I'm getting an error here. Expected an indented block of Python. So I'll just put in pass here because I have nothing to tell right now. Then B, and finally class C will inherit from both A and B, right? And now all I have to do, if I want to, I can basically add a few other things. So I can create a function named tell, or another thing I could do is say class name. I could do that as well, but I think the most important part here is, let me just print if, and I have to pass in self here, even though I'm not going to be using self. Print So now I can copy and paste the same thing. And this, copy and paste it here. Okay. Now all I have to do is I have to create an object. Let's say I call it obj and I create C. Now if I were to print dot print A, again I'm making the same mistake. Print B and print C. From A, from B, from C. So these methods get inherited in this class. This is multiple inheritance, and there's hybrid inheritance, and then hierarchical inheritance. I don't think I need to go into any details of that. Basically, this would be just B inheriting from A and C also inheriting from A, and then that would be it. So hopefully this was useful. And now let's take a look at overriding and overloading. Let's say I have two functions. Let me create a class called base class, has nothing to inherit from. Def add, it takes two functions a and b, and it will return a plus b. Right? Now let's say that I have another function def add, it takes a, b, c, and it also takes in the parameter self, and it will return a plus b plus c. So yeah, indent it properly. Yeah. And now if I were to print, let me just create an object. And here I can call needs to be an equal. So add, and I pass in two numbers, 2, 3. And another thing I can do is I can call 2, 3, 4. Now if I call the functions, I have two functions with the same okay. Add is missing one position requirement for C, A, B, C. Okay. I think it should work. For some reason it's not. We'll take a look at that. Okay, if I were to pass in 5, okay. So we can have multiple functions. Let me just remove it out of the class so we don't have to deal with multiple functions. Yeah. Okay, this will work just fine. So yeah, self is also needs to be removed because we are outside class. So we can add multiple functions. In Python, I think we need to, yeah. So this is how this could work. Let me just clear the screen. And yeah, so this could work just fine if I have overridden the functions, but you could have multiple. This is what overriding would look like in a function. Let me just show you what overriding would look like. I have a base class, and then let's say I have a derived class that will take a base class, and here what I have to do is I will use the add function again, but a comma b, but what it will do is instead of just adding a and b, it will also add 1 to it. So, or also I need to use the self keyword. Now if I were to create base derived derived, and now what I can do is print base dot add 1 comma 2 and derive dot add 1 comma 2 comma 3, or I could just add 1 comma 2 is fine. As you can see, it's giving me different results based on the implementation that I have. But let's talk about overloading. So I want to create a function that handles multiple things. What I can do is, instead of doing it this way, I can star args. So this is what it will do is, however many arguments I pass. Let me just go up. Even if I were to pass in 3 arguments, 4 arguments, 5 arguments, it will perform the same task. So now if I take a look at, if length of args is equal to 2, then return args of 0 plus args of 1. If it's not the case, then result equals to 0, and for x in args, result plus equals x, and then we return the result. So I can pass in multiple arguments. Just make sure that you're putting a comma before them. And if I run this now, I have to syntax is incorrect. I need to put this, and now it will work. Yeah. So this is what overloading means. So I have created multiple implementations based on the number of arguments that have been passed to me. I can create functions as well. So I can create add 2, and here I'll add 2 functions and all that. So that's how overloading and overriding works. So hopefully that's clear. Now let's move on to the next topic. The next topic is encapsulation in Python. Let's take a look at that. Encapsulation is basically abstraction plus data hiding. Abstraction is showing essential features and hiding non-essential features to the user. So depending on how your application is set up, let's say that you have an application that manages the payroll of a company. Now, since it's managing the payroll of a company, the user does not need to know what kind of database it uses, what kind of file system it's using, what kind of language or what kind of drivers it's using in the background. That's all things that you have to do. So you can abstract those details out of the program and just focus on the UI and all that. So that's what abstraction means, just showing the essential features and hiding the non-essential features for you to deal with. So this is what it means. So while we're writing an email, you don't know how these things are actually happening in the backend. This is one example of abstraction as well. So when you're writing an email on Gmail, when you send the email, you don't know how the things are being put into an HTTP request, how they're being transferred from other email servers, and how the email reaches to the person. So encapsulation deals on the concept of public and private. So public basically means a function that anybody could access. So far we have created only public functions. Private functions are functions that other people are not supposed to access. You can access them under very strict and rigorous circumstances, but it's generally discouraged. So if you want to access something, then you can use update software. Then you can use a syntax that we're showing down below. So let's say that we have a class named car. It has an init method, and in that we have an update software method. It's a private method. The way we know it's a private method is that it's been preceded by 2 underscores. So whenever we start a function name with 2 underscores, that means that it's a private method. So we create an update software method, we create a drive method, and then we call the update software method. I create an object called red car. I call the drive method since it's public. But if I want to call the private method, this is how I do it. So I call underscore the class name and then 2 underscores and the function name. Now again, this is not something that you should do. It's generally discouraged to call private methods on your own. So if possible, don't do it on your own. But if you have to, then this is one way you can do it. So you can change the value of a private variable using a setter method as well. So let's say that I have a private variable called max speed. Let's say I'm creating a car game. In that there's a max speed function. So instead of me having to reach into the function and then exposing the max speed variable, what you can do is you can call a max speed function, set max speed function, and pass in the maximum speed that you want to. So using the red car dot underscore underscore max speed will not change the private variable because it's private, but you can use a setter method to do that for you. Now let's take a look at a hands-on to understand how that works. So let's say that I have let's say that I have a function called some let's say I have a class called some class, and here I have a function, let's call it public. I'll print.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Public function, and now I can create a private function. Always remember, underscore underscore means private. This takes in no functions, so I will just print private function. Now I think I'm getting some error, mainly because this is supposed to be a class and they need to accept a self parameter. And now if I were to create an object, and now if I were to call the obj dot public, this would work. So it's calling the public function. But now if I were to call the private function underscore some class underscore underscore private, it's calling the private function for me. So that's how this works. Now let me tell you how to deal with the private variables. So let's say that I have a self dot underscore underscore private equals to instead of it being private, let me call it balance and set the balance to be 0. So let's say that I'm creating it for some account. Now I want balance to be private, mainly because, let me call it INIT. The reason why balance is private because there can be certain rules that a bank has depending on how the things are set up. We might have multiple rules. So it could be that a balance can never be equal to 0, or it could be that a bank has that whenever you open an account, a balance should be minimum of 10. So we can set it here. Now also when we're setting the balance, there could be multiple procedures that we need to follow, that we need to log the old balance, then update the new balance, and then log that as well. So these are the kind of things that we'll take a look at in the set balance function. We take self, we take balance, and what we'll do is self dot b underscore underscore balance equals to, all right. So I need to put a comma here. All right. So now instead of this, I can create account, and I can also create a get balance function. So def get balance self, and what it will do is it will return self dot underscore underscore balance. So now all I have to do is print obj dot get balance. I'll print it again, and before that I will change the balance, set balance to be 20. Now if I were to run this, what do you think will be the output? Let me just, so okay, I'm getting none here. Okay, obj is an account. I call the init method def. Yeah, self.balance is being set to 10, and then I'm passing in the balance, or I could also do it this way, self.set balance to be 10. Still getting none. So we have self.balance, we have self.set balance, we have an account, and we are using the obj. Let me just print it here. Okay, so we're getting the balance, but we're not able to return it mainly because it's a private thing. So that's why we're not able to return the function. So make sure that you're understanding that. So you can't return a private value, but you can use it underneath. So as you can see now, I have 10 and 20. Let me just remove this. And if I were to print get balance instead of we're printing 20, but if I pass it here, save this and run it again, as you can see the current balance is 10, and then it gets printed to 20. So that's how that works. Hopefully it's clear to you, and let's move on to the next topic. Alright, so now let's take a look at polymorphism in Python. So what is polymorphism? Well, polymorphism basically means it's the ability of a class or an object to perform certain tasks or adapt to perform certain tasks based on the environment. So to give you a bit more context, let's say that we have functions with the same name but they behave in different ways. That's polymorphism. You might also recall that this is also what's called as overriding. So this is basically that. So you have different, you as human beings, we behave differently with our friends and with the elders and people we respect. So that's very akin to what polymorphism is. So a single person behaves differently at times. Similarly, objects can have say the same method that performs different tasks depending on the environment. So polymorphisms with a function is quite simple, as you can see here. We have a function called in the Pacific, in which we pass in an object of fish, and the fish will swim. So we have two fishes. One is shark, one is clown, and both of these fishes will swim differently. So that's polymorphism in a way. Let's take a look at polymorphism in more detail using some code. Again, the setup is quite the same. I have an app.py file, and I'd like to show you how I'm going to do this. So let me first create a class named worker, and that class will have a function or a method rather called work that will take in a parameter of self. And now all I'll do is I'll print working. Now that that is done, I'll create another function called perform task. This will again take parameter of self, and what it will do is it'll print performing task, and instead of after this I don't want there to be an empty line, so I'll change the end parameter, and now I'll call the self.work function or method. So that is done. Now what I'll do is I will create two classes. One is the class of a delivery person, so class delivery man, and this will inherit from the worker class. And here what I'll do is I'll override the work function, and it will take in a parameter of self, and all I have to do is change the print statement here, print. Delivering goods. Similarly, I'll place another class. This class will be called lumberjack. This will also do this, but here the task will be different. And now it's time for us to perform the task. So what we'll do is I will create an object of delivery man, and I'll create another object for lumberjack. Fine. And now all I have to do is I have to perform the tasks. So delivery man dot perform task, lumberjack dot perform task. So even though the perform task function is going to do the same thing, since we have overridden the work function in both of these classes, our code is going to perform differently. So for one thing, we are performing the task of delivering goods, and for the other, delivering cutting goods. So you can mix and match a lot of these tasks and perform and make it to work the way you want it to work. Now let's move ahead and see what else we have to do. So now comes the title of modules. So a module is basically, let's take a look at what modules are. To put it simply, a module is simply a file that contains some Python code. Modules can define functions, classes, and variables, and can also include runnable code. So there are some predefined modules in Python standard library that we can use for our basic purposes, and we can create our own modules. So there are two keywords that you need to be aware of when you're working with modules. The first one is the from keyword. The second one is the import keyword. So the from keyword allows you to specify the things that you want to import from a module, and the import keyword basically just imports one entire module into the current scope. So I'll show you what that means. And let's take a look at some module code. So again, the setup is the same, but here what I will do is I will create another file and I'll call it utils.py. Here I will define two functions. So a function will be add, and what we'll do is written x plus y, and I'll do the same thing here, but instead of adding it, it will be multiplying. Now that I've done this, I can now use the previous thing. So from utils is the thing, and my code editor is recognizing this as well. We will import add. So if I want to just import add from utils, I can do that, and I'll do add. I'll just print it, add 7,9. Now that that is done, if I run this again, here it goes. And now if I wanted to import the multiply function as well, I can do that. And that works as well. So it's working perfectly fine. But if I wanted to import everything, instead of me going to write everything like from utils import add multiply divide absolute and all that, I could just import utils. And now instead of add, I will use utils.add, which I've already run, and utils.multiply. And it's working the same way. So this is how modules work in Python. Let me just close this one out. Let's see what else we have to do. So let's take a look at the Python standard library. So Python standard library is a very extensive library which offers a wide range of facilities. So it's basically pre-bundled set of code that Python ships with, so that you don't have to write everything from scratch. So the standard library contains built-in modules. They provide access to functionalities such as I/O, which is file I/O or disk I/O or something like this, and they provide ability for us to take a look at data types, functions. We have modules that are already available in the Python library, and there are many other modules in Python's standard library that allow us to perform some very common tasks, which we can take a look, building CSV files, taking a look at the operating system features, so on and so forth. So let's take a look at the Python standard library code. So again, the setup is quite the same. We have the this standard library, we'll be taking a look at the Python standard library. Essentially, what we'll be doing in this one is that we will create 3 files inside the data inside a folder named data. So let me just do that. I have no folder as of now. Let me create a folder called data. Inside it, let's say that I will create 3 files. Sample.txt, data.txt, and let's say I create another file called demo.txt. Now I want to take a look at all the files that are inside the data folder. There are many ways to do it, but in Python, since it already ships with a OS module that provides me with this functionality, I can type port OS, and now all I have to do is I will print os.list directory. This is a function. This will take in a path, and the path is the data folder. Now if I run this, as you can see, it gives me all the file names. Let me just clear it out. Yeah, this is what it looks like. So there are 3 files in this folder, and these are the name of the files. Now I can take this a lot further. There are a lot of things that you can do using the OS module, and there are many other modules that you can perform a lot of tasks with. Similarly, if I wanted to just use this, I could do it like this: from OS import list directory, just to revive the previous examples. And if I were to use it now, this is what it looks like, and it works just fine. So let me just remove this. This works. And now let's take a look at what else we can do. So we will be installing packages, and when we're installing packages, we use let me just show you. We use something called pip. Pip is the package manager that comes with Python, and it allows us to use code written by other developers, and we will use the code written by other developers so that we don't have to solve the same problems that has already been solved by other people. So in this example, we are installing the Colorama package, which we will be using in our hands-on. So let's take a look at that. So as of now, Colorama package is not installed. For me to install the Colorama package, I have to type in the command pip install Colorama, COLORAMA. So pip install Colorama, and I press enter. If you've installed Python in your system, then this will work just fine, and it will take some time. It will take okay, so the Colorama package has already been installed on my system. This is why it's saying requirement already satisfied, but in case you don't have it, it will work for you. Now all I have to do is I have to import some methods. So let me see, Colorama, I will import the init method. Also from term color, I will import colored. So what I'll do is, firstly I'll initialize call the init method, and now all I have to do is I have to print something. So I'll print it. Firstly I'll type in hello world, and in the here I will have to wrap it inside the colored function so that the output is colored. Here I passed in the text, and now I need to pass in the colors. So the colors would be white and on red. So white, this should be a string, and on red. Now if I go to my system, type in pip Python app.py, as you can see the background color is red and the foreground color is white, exactly how I wanted it to be. So instead of me having to write the code to change the colors of the strings that are being returned, having to deep dive into how the terminals work and how to accomplish this task, this has already been done for us. We can just use the Colorama package, and we can use the term color and all that. So this is how that works, and hopefully that's clear. You can install any package that you want to install. Just make sure that you're understanding what is the package you're installing. Is it a good package? Has it been used by other users? Is it tested? Is it pure? And all that. And now we come to exception handling. And this is an important concept, so make sure that you understand this. So an exception is basically a runtime error. This could be caused by a lot of things that are outside your control. Let's say that you're building an application that works with a database. Now it could be that the database for some reason is not working. Maybe the table is not there. Maybe the web server that is hosting the database management software is causing some issues, has run into some issues, and now you need to perform some other tasks. So these are runtime issues that you can basically expect these things to go wrong and write code that should be performed when these things go wrong, such as displaying an error message and doing something else. If you don't do it, then your program will exit immediately. One of the most common runtime exceptions is file not found exception. So exception handling is basically writing the code to handle these exceptions to occur. We are basically expecting things to go wrong, and we are writing code to handle if these things go wrong the way we want them to go wrong. So there are certain keywords and you need to understand their meanings before you jump into exception handling. Things like try, except, finally, raise, catch, and all that. We'll take a look at what these mean. So let's take a look at try. You can create your own exceptions if you want to and raise them appropriately where you think it's appropriate. But as of now, what you need to understand is that these exceptions you only need to create your own exceptions when the already existing exceptions don't make sense. So let's take a look at try. Try allows you to define a code block that could potentially throw an exception. So underneath the try keyword, as you can see, we have indented a function named throw exception. What happens in this function is that it takes a look at the function. It might throw an exception, and if it does throw an exception, then we catch it and we perform certain tasks. We catch it using the except block. So except allows us to define a code block to check whether when an exception occurs, what do we do then? So here we are raising a custom exception, and we are expecting it to go wrong and raise that custom exception. And in the except block, we're typing when a custom exception is thrown by this code, then perform this task. Here we're just printing the message returned to us by the custom exception. And then we go to the finally block. So the finally block gets run whether an exception is thrown or not. So let's say that you have a database connection and you want to close it. You can think of it like this. Even if your throws an exception, your database connection will get closed no matter what. So that's why we use the finally block. It's basically used to free up resources that are not going to be used. So if you've opened a file or you've opened a connection to a network and your code throws an exception and it exits out prematurely, then that connection remains open. So the finally block basically allows you to take a look at the code, and then if there are some resources that you need to free up, you can free up there. And then there's the raise keyword. Raise allows us to create our own exception and raise them the way we want them to. So this is what it means. And in this example, we're creating our own exception, and then we are raising these exceptions as well using a function called raise custom exception, in which we are basically using the raise keyword and instantiating a new exception. And now let's take a look at some code. So all we'll be doing here is we'll be creating an exception, throwing an exception, and learning how to handle custom exceptions as well. So the first thing I'll do is I'll create a function called throw exception. I will accept a number here, and if the number is equal to 0, then I will, instead of throwing, I'll use the raise function and exception. And here I'll pass in an argument that will show the message that I want to display on the screen, which would be argument 0 is not dead, else we will print number. So now if I were to use the throw exception function, pass in 0, and if I were to run the code, as you can see, this throws an exception. and this exception is causing our program to stop abruptly. So if I'm typing done here and if I run this again, the last line does not get executed. Our program exits here. So if I were to handle this, then this would work. For instance, I'm handling exception as ex and I will print it. Save it, run it again, and now it's working fine. It's showing me that argument 0 is not accepted and we're printing the done statement. Now, another thing is just the else statement could be used here as well. So else statement is used when the code associated with the else statement will be called when nothing, well, the exception is not thrown. So I will type in not thrown. Only when the exception is not thrown. Here the exception is being thrown. So if I type in 1, this will work fine. So it prints 1, which is because we're printing it here, it's not raising the exception. Then it goes ahead and goes not thrown, and then we print the done statement. So it's working fine. Now let me show you what the finally statement would do. And if I were to type, and now if I were to type this, as you can see, it prints done. But if I were to pass in 0 and press this, as you can see, this is still printing done. So this is used to run code whenever we need to make sure that a piece of code is being run even when things are not working out. So even if there was some reason because of which our code would exit abruptly because an exception was not handled, finally block would run completely fine. So now that that is done, let me show you how to create your own custom exception. So let me just create a class called my exception. It takes an exception. Now I would have to init. Now as you can see, I am inheriting the exception class. So I would use the super method. Here I would have to pass in the current class, self object, and I have to call the init method here. An issue that I can see is I need to pass in self, and now here I'll pass in the init method, at least in the current exception class. I don't have to pass in anything, and now I need to just set the self args. Here it's a tuple, so all I have to do here is just paste my exception, save it, and now if I were to create my exception, yes, my exception, as you can see, I'm getting it here, but I'm getting it in the way of a tuple, so everything is this way. But as you can see, I can just change it by typing a comma. Now I'm getting my exception and raised my exception, so this is working. Now if I were to try it out, and in the except block, all I will do, in the except block, I will have to specify the kind of exception that I'm expecting. So my exception as ex, and I will print ex. So we've done this and it's working fine. We can mix and match a lot of things like else and finally and all that, but here it's working fine. So let's move on and see what else we have to do.
Web scraping is a term which is used to describe the use of a program or an algorithm to extract and process large amount of data from the web. Whether you are a data scientist or an engineer or anybody who wants to analyze large amount of data sets, then the ability to scrape data from the web is a useful skill that you should have. Let's say you find data from the web and there is no direct way to download it. Then web scraping using Python is a skill which you can use to extract the data into a useful form so that it can be imported for further analysis.
So what is web scraping? Well, web scraping, also known as screen scraping, web data extraction, web harvesting, etc. is basically a technique which is used to extract large amount of data from the websites. These data are mostly unstructured in nature, and once extracted, you can transform it to a structured data and save it to a local file in your computer or to a database in a tabular or a spreadsheet format. The data displayed by most of the website can only be viewed using a web browser, and most often they do not offer the functionality to save a copy of this data for personal use. The only option then you have is to manually copy and paste the data, which is a very tedious job and can take many hours or sometimes days to complete. Now using web scraping, you can automate this process. So instead of manually copying the data from the website, the web scraping algorithm will perform the same task within a fraction of time. So this was about what is web scraping. Let's move ahead. Now next we have, is web scraping or web crawling the same thing? Well, there is a very subtle difference between web scraping and web crawling. Moreover, web scraping and web crawling are interrelated. The words web scraping and web crawling may look similar and many people use this word very frequently, but both have lots of differences between them. In simple terms, web crawling is the process of repetitively finding and fetching hyperlinks starting from a list of starting URLs. Broadly speaking, web crawling is a process of locating information on World Wide Web, indexing all the words in a document, adding them to a database, then following all hyperlinks and indexes, and even adding that information to the database. Major search engines like Yahoo, Google, Bing, etc. all have such a program, which is also known as a web spider or a bot. But when you see, on the other hand, web scraping is a process of automatically requesting a web document and collecting information from it. Strictly speaking, to do web scraping, you have to do some degree of web crawling to move around the websites. Web crawling is generally what major search engines do for searching any kind of information. Web scraping is essentially targeted at specific websites for a specific data. For example, stock market data, business leads, or supplier product scraping, anything like that. But an important thing to know is that web scraper can do things a web crawler wouldn't do. For example, they doesn't obey the robot.txt. I'll tell you in detail what exactly it is later in this session. But now just understand that they doesn't obey robot.txt. It is a file which tells that what you can crawl and what you cannot. So web scraper does not obey that robots.txt file. Don't worry, later on we'll read about it in detail. Next is submit forms with data, or execute JavaScript, or transforming the data into required form and format, or even saving the extracted data into database. So these are the things a web scraper can do, but a web crawler cannot. I hope you guys are clear with the difference. So moving on ahead, let's learn about some of the use cases of web scraping, or under what business scenario you could use web scraping. So on number one we have tracking competitive pricing. Well, web scraping helps in extracting products or service price of the competitors to stay ahead of the cutthroat competition. Next is sentiment analysis. Well, sentiment analysis is analyzing the reaction or response of a customer or a consumer. Using web scraping, it can be easily traced by extracting ratings, reviews, and feedbacks on forums as well as e-commerce websites. Next, we have market research. When you are planning for a product or a service launch, then you can use web scraping to study the market in advance, and it can help you out for the product campaign's launch. Next is industry scrutinization. Most of the time, you and your business would demand to know that who all are present in terms of market player. So in this case again, web scraping can surely help a big time. Next is content aggregation. Well, if you want to gather information from multiple documents or web server for further processing, then what you can do? Then you can just web scrape the data, then you can just process the unstructured data and convert it into a organized structured data. And it can be further used as a real-time information. Next is monitoring brand value. You can make future decisions easily and very accurately by analyzing the brand value on scraped filter data related to your brand, along with some positive and negative keywords. Next we have is the lead generation. Well, you can use the scrapped data to identify who to target in a company for your outbound sale campaign. You can even use it to locate possible leads in your target market or identify right contacts within each one. Well, this was some of the business application of web scraping. Well, if you research out there, you will find out n number of other business application for web scraping. Now, since that you are fetching data from a different website. So now that you have seen various business use cases of web scraping, and you know that what you do in web scraping is you fetch the data from other websites. So a question might arise in your mind, like, is web scraping or web crawling a legal thing to do? Well, the answer is maybe. Crawling means fetching content from the web pages in an automated manner rather than to manually opening each page in your browser. The calls made by the browser agent to the target server that hosts the web page is quite similar to the way the bot hits a page to grab its content. So now the question arises, why is crawling a taboo among those who only have learned to use the term? Well, it's mostly because it's quite often used against the website policies and breaks the ground rule of crawling. So here are some thumb rules that you must follow if you want your bot to behave humanly. The first one being robots.txt. Well, be it a commercial or a non-commercial, Indian, American or any website, one of the easiest way to find out which websites allow scraping and which doesn't is simply by checking their robots.txt file. You can do it by appending /robots.txt at the end of the website URL you wish to scrape. For example, what if I want to check the robot.txt file for amazon.com? So I'll just write www.amazon.com/robots.txt. So as you can see here, it gave me a list of allowed and disallowed link which can be crawled. You can consider this as a filter consent form that you should abide by if you want to crawl that site. It tells you what URLs you can and what you cannot crawl. This is really bot specific. Even Google's bot cannot crawl a blog page unless the site is worried about the page's SEO. Next is the public content. We'll crawl only public content keeping copyright policies in mind. If you are crawling a site only to reproduce the same content on a new site of yours, then good luck with that. You can easily do that. It's a very legal thing and no one is gonna oppose you or sue you for that. Next is terms of use. Check the website's terms of use and make sure all's well between them and you. You should definitely read the terms and condition of a website you want to scrape. If the data is under Creative Commons, you should definitely read the terms and condition of a website you want to scrape and check if the data is under the Creative Commons that you can use it commercially. So basically, if terms and conditions states that scraping is illegal, then you shouldn't scrape that website. Next is authentication based websites. Well, some sites need authentication before you could access their content, and mostly they would discourage crawling because they only want real human beings to get logged in. Next is crawl delay. Robots.txt also lists delay to be maintained between consecutive crawls to ensure you're not hitting their servers too hard. If you overload them with requests, chances are that your IPs will be blocked. Let me tell you about an ongoing case between LinkedIn versus HIQ. In August 2017, LinkedIn blocked HIQ from accessing its data available in public LinkedIn profiles of registered users. So what these HIQ guys were doing, they were just extracting information from LinkedIn. All the public information, all your public profiles which were being extracted by HIQ. So what LinkedIn did, it blocked the company from accessing its data. HIQ took LinkedIn to the court and the case is still ongoing. The case hinges on the question of who owns a piece of data and the circumstances under which the information can be viewed as residing in the public domain, accessed by all and sundry. The appeals court judges may rule that LinkedIn owns exclusive right to the data, which would not have been compiled without the entrepreneurial talents of the LinkedIn founders. Conversely, the judges may conclude that since LinkedIn users set their profiles to public, placing them in full view of search engine and general web surfers, they are giving companies like HIQ free rein to view and use the data as they see fit. So it's a knife-edge decision with strong arguments on both sides. Either ruling could have profound implication for how people like you and me interact with the data in your daily lives. So this was a story of how HIQ breached the policy of LinkedIn by web scraping their data. So as you know that for this tutorial I'll be scraping using Python. So what are the basic Python libraries that I'll be using for web scraping? Well, the first one is the request, which is used for fetching URLs. It defines the functions and class to help with the basic URL actions like digestion, authentication, redirection, cookies, etc. Next is the beautiful soup. Well, it is an incredible tool for pulling out information from a web page. You can use it to extract tables, lists, paragraph, and you can also put filters to extract information from web pages. Beautiful Soup does not fetch the web page for us. That's why I'm using the combination of both request as well as the Beautiful Soup library. Python has several other options for HTML scrapping in addition to Beautiful Soup like Mechanize, Scrape Mark, Scrapey, etc. Don't worry, we'll discuss about them in our next tutorial. For this tutorial, we'll be just focusing on Beautiful Soup and requests. So let's move ahead. Well, while performing web scraping, you will have to deal with HTML tags. Thus, it's very important that you must have a good understanding of them. If you already know the basic of HTML, it's good. But for those who don't, I'll try to cover the basic for you guys in just 2 minutes. Here's a basic HTML code. The first line, exclamation mark doc type HTML. It indicates that this particular HTML file is written in HTML5. So basically all the HTML5 documents must start with it. Next is the HTML tag. All the HTML documents are contained between an opening and a closing HTML tag. Next we have is the opening body tag. Well, this is the visible part of HTML document. Like whatever you see on the web page is mentioned inside the body tag. Next is the body tag. Well, it is the visible part of HTML document. Like whatever you see on a web page is enclosed between a body tag. Next we have is the h1 tag. Well, HTML headings are defined with the h1 to h6 tag. There are 6 different types of heading which are defined as h1, h2, h3, h4, h5 and h6. For example, h1 is the main heading, then h2 is a subheading and so on. After headings comes the paragraph. For paragraph we have a p tag over here. This tag is used to define a paragraph. There's the ending body tag and the ending HTML tag. Let's move ahead. Next we have is the table tag. Don't get confused with this style thing. The main tag over here is table. The style is just one of the attribute of a table. Like it's telling that the width of the table should be 100%. We represent the row as tr tag and the rows are divided into data using the td tag. For example, I mentioned a name over here like James. James is a data of a row. It's a cell. Fine. We add another data to same row. James Smith. Another data to the same like 45. So first name, last name and age are being added to same row tr. Now again, what if I want to add elements to my next row? So again I'll define another row tr. Then again I'll write first name, last name and the age. And then again close the tr tag or the row tag. These are some of the basics. Let's see what we have next. Next we have up here is the a tag. Well, a tag is used for hyperlinking text with some websites. For example, this is my entire tag. What we have up here is ahref equals www.intellipaat.com. So this is the tag. And what is my text that has to be hyperlinked to this website? It's visit to learn. Then we close the tag. So this entire thing is known as element. Ahref part is the opening tag or the a tag. And inside that we have attribute name as href and attribute value as www.intellipaat.com. Moving ahead, we have the enclosed tag content to visit to learn more, which will be hyperlinked to www.intellipaat.com. And finally, we have a /a as the closing tag. So this was all about the basic HTML tags which I'll be using in this session. If you want to learn more about HTML tags in detail, you will find multiple online sources freely available for you. You can just learn about HTML in detail from those websites or content.
First of all, let's begin by understanding what web scraping is. So suppose you have a website or you have a link for a website which is containing some information that's getting updated regularly, and you wish to store that information either locally or in a database or anywhere, or you wish to access that information and then perform some manipulation on it. Now usually, and before web scraping, you should usually check if that website has an open API to provide that data, so that you can just request the data using a URL endpoint. However, sometimes these websites either don't have a web API or don't have the data that you want in the form of a web API. So in that case, what you do is you parse the entire HTML content of their website as a string and then extract information from it that you need. You can then store it or manipulate it however you wish to. And that's what's known as web scraping. Now Python has a lot of packages for web scraping. So one of the packages that we can use is called Beautiful Soup. It's now in its fourth version, so I believe Beautiful Soup 4.4 is the current version. And another one is Scrappy. Now Scrappy is less for web scraping and more for building web spiders or web crawlers. Now these you can this could be considered an entire framework in itself, as it allows you to create spiders by inheriting classes and then telling it how to parse it, as you can see in the example right here. And this could be useful when you're creating a web crawler and you wish to crawl multiple pages. But if you wish to crawl a single page, if you wish to create a web scraper for just getting information from a single page that's being run, I think executed several times a day, such as a stock market website, for example, that's getting updated hourly. So you can use Beautiful Soup, in my opinion. Now Scrappy is also very good, but it's more powerful than Beautiful Soup in the sense that it is used to create web spiders or web scrapers or web crawlers, whatever you call them. So if you wish to learn Scrappy, it's the documentation page that you need to go to. There are several tutorials on its documentation page. There are examples, so on and so forth. In this session, we'll be looking at Beautiful Soup because it's very easy to get started with, and it's quite easy to use as well. So now let us take a look at what can we do with Beautiful Soup. So with Beautiful Soup, we can, if we have an HTML page offline stored, we can either parse that or we can parse an HTML page from a website. Now, parsing an HTML page from a web address, that needs you to get the string content of the HTML page. So for instance, as you can see, this is the string content of the HTML page. This will be returned as a string. Then you can parse it and then you can use it with Beautiful Soup. So before we get started with Beautiful Soup, one thing that you need to understand is that you need to install all the dependencies in your project. Now I'll be using pipenv, that's pipenv, to create an environment and then install all the packages that I need. Have any of you worked with pipenv before? If you have, then you can message in the chat box. No. Okay. So let me give you a brief introduction of what pipenv is, why do we use it, and how do we use it. So basically, suppose you are creating a project in Python using external libraries like the Beautiful Soup. There are many others like Pandas, NumPy, Django REST framework. All of these packages are available inside Python. Inside the Python, they are not available inside the Python standard library. So you need to download them from the internet and then use them. Now you can download them, but it could be the case that these packages have dependencies themselves. That is, they require certain packages to be downloaded as well, and those packages require certain packages to download themselves. And then those packages might even have versions. So for instance, let's say Django, your project only works on Django 2.1, and there were some changes in Django 2.2 which you cannot support as of this moment. Now, let's say that another person, or maybe you yourself, wishes to work with Django 2.3 to create a new website. Now, you would either have to uninstall Django 2.1 and then install Django 2.3, or you would have to create a new environment and install the Django version that you wish to use in that. So this is where pipenv comes in. So what it does is it creates a virtual environment. All the packages that you install in this environment can only be used in this when you enter this environment. So think of it as a container or a virtualized environment for you to install your Python packages. So for instance, let's say that I wish to, first of all, you need to create an environment and for that you can type pip and start or pip and shell or whatever. I usually type pip and shell and then you press enter, and it says here creating a virtual environment. Now this is important because everything that we install in this virtual environment will only be able to use in this environment. We won't be able to use it outside this environment. So it's creating a virtual environment, getting all the files required for it. Before pip-pen, there used to be virtual env. So now we have pip-pen. Virtual env is what is used underneath pip env, but pip env could be thought of as an abstraction. Now you can see creating pip file. This file contains all the packages that your project might. So as you can see, we have created a pip env and an environment, and as you can see, this is the
But from where you have to run this command, because it's saying not recognizing this command.
okay. So first of all, I'm exiting. So if you wish to run this command, first you need to install pip env. So in your PC or in your Mac or whatever you have, type pip install pip env. I'm sorry, install. Yeah, and when you press enter.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Yeah, mine is already installed, so it's not going to say that, but you can install it. Is it installing?
It's struck at 65%. Yeah, it's doing something.
Yeah, but it'll install. It'll take some time, but it'll install, and then you can use the command pip-env. Okay.
Anirudh,
Yeah.
I have a question over here.
Yeah.
So we generally use pip install. Till now, we have installed so many libraries, even scikit-learn as the TensorFlows. So we have
Yeah.
used pip install TensorFlow.
Yes.
So what is the
Yes.
difference between pip install TensorFlow and pip uh,
env.
environment
Yeah.
env? What is the difference between?
Sure. Okay. So the difference between them is that if I wish to use TensorFlow version 2.1 for one project and TensorFlow version 2.3 for another project, with pip I cannot do that because in pip packages are installed globally. So for instance, let's say that I've been using for a project Beautiful Soup version 3, and now suddenly I have a new project and I wish to use Beautiful Soup number 4, version 4. So because of having different versions, we need to either uninstall Beautiful Soup version 3 and then install Beautiful Soup version 4. In that case, the previous project that we just created with Beautiful Soup version 3, which was running, will stop working. So to avoid this problem and install these packages per project basis. So for instance, I wish to use Beautiful Soup version 4 for this project. So when I install it using pip env, only only this project will be able to use that version. So for instance, let me show you. First, let me enter the environment. So as you can see, it didn't create another environment because it had already created one, and it shows here that's the label of the environment or unique identifier. Now if I install pip env install beautiful 4 and then I press enter. Now it'll start installing. It's installed and now it's locking, which is checking all the files, and it's done. Now if I can show you just one thing, this is control O. Yeah, pip file. So as you can see, it's showing the version of Python that I'm using. It's showing that I'm using Beautiful Soup, and since I didn't specify any version, it's going to install the latest version, which is this star. So now if I wish to take this project with me on any other computer and use it, all I have to do is install pip env on that computer and run pip env space install. It'll create the same environment that I have right now with same packages that I have, and according to this, like Beautiful Soup, the latest version, and it'll use Python 3.7 and it'll start working on its own. If I didn't do this, then the problem would be that the another PC might not have the same versions of all the dependencies that I might have. So they might have Beautiful Soup version 3, version 2, maybe they do not have it, maybe they have a different version of Python, so on and so forth. So you can think of it as as a way of creating an environment or you can think of it as a way of creating a container in which your project can be developed. So I hope that clears it up.
Yes, thank you.
Sure, sure. So, okay, now that we have installed the beautiful soup library, another thing that we need to worry about is parsers. So, parsers are basically how your beautiful soup library, or parsers is basically, you can think of it as a package used by the beautiful soup library to look at the HTML content and then create an HTML tree out of it, or parse it, or understand the structure of the HTML page. So whenever you go to an HTML page in Chrome or whatever browser, what you can do is right click on inspect, and as you can see this tree like structure. This is how HTML usually works. It is a tree of nodes nested into one another in a hierarchy. So to understand how these relationships and parse all of this, we use parsers. Now, Beautiful Soup supports many parsers. I think its documentation page has, yeah, here it is. So it supports the HTML dot parser, which is Python's inbuilt library. So you don't have to install anything if you wish to use the HTML parser that is inbuilt in Python. You can also use LXML HTML parser, which we'll be using in this tutorial because it's very fast and very lenient. Now, when I say lenient, it means that if the HTML content that we're getting is not properly formatted, that is, some of the tags have been opened but not closed, so it's not completely valid HTML. There are some bugs or errors in it. Yeah, the LXML parser will try to rectify those mistakes and present the tree as it is, instead of throwing an error and saying that HTML is not well formatted, because the HTML content that we're getting may very well be out of our hands because we'll be getting it from the internet. There's also HTML5 lib and LXML's XML parser. Now, the reason why we won't be using HTML5 lib also, although it's very useful, is because it could be very slow, as you can see here, and so this could be a problem. On the other hand, LXML's XML parser is used to parse XML. Right now, we'll be parsing HTML, and it's very fast and lenient. Python's inbuilt HTML parser is also very good. However, I'll suggest that you use LXML whenever you can, because, well, first of all, it's quite fast and speed is of the importance when we're building a project, and it's very lenient, so it can rectify some of the mistakes that we get. So that will be very useful. So first thing that we need to do is install the LXML parser, and I'll install another package called requests. This is a package that is used to send requests to a website or a web server and get the response in as a string or however you wish to get it. So what I'll be doing is firstly installing pip env, and you can install multiple packages in the same command. So I wish to install LXML and requests, requests with an S. So don't forget the S because it might install another package named request. Now when I press enter, so LXML is installed, requests is now installing. This is also installed, and now it's locking. Locking basically means checking if the dependencies are fulfilled and then creating a hash out of it and then locking it. It also creates a pip env.log file, as you can see it's mentioned right here. And this is what contains the current version of our pip env file. How it works, all the things that pip env needs to create dependencies. So locking is a process. It might take some time because we've installed two packages at once. So after it finishes locking, we can start with programming.
Hi Anirudh, this is
Yeah,
Hemant.
yeah.
Actually, I joined around 7:10. Okay,
Okay.
so could you let me know that why we use web scraper?
Web scraper. Okay, fine. So many websites, they contain some information that we might need in a project. So for instance, let's say you're creating a project for predicting the stock market tomorrow. Now for that you need some data. So you can get the data from an API, that is called a web API. Many stock market websites do provide web APIs. which basically are you can think of them as URL endpoints, which you can send a request to and get the data in a format that you wish to get it in, like JSON or XML. However, you might come across a situation where the data that you want from the website that you want it from does not have the web API that you can request the data from. In that case, you usually use a web scraper. Now, a web scraper is basically just a Python program that gets all the data from the website and then parses it and allows you to extract information from that web page. So, for instance, let's say that I wish to take the title from this website. Now, I can, if it has an API, I can request that API to provide me the title. Or what I can do more generally is just to create a web API, just to create a web scraper, get the information of the HTML page that is returned when I hit this website, and then parse it and then just extract this information. Then I can do whatever I wish with it, which is basically save it in a CSV file, text file, database, manipulate it, or do whatever I wish to do with it. So, for instance, to continue with the stock market example, let's say there's a website that updates the stock market information per second, so it's instantaneous and you wish to get that information from that website. So what you can do is
Okay,
you can create a scraper.
okay. So thinking that suppose if you have not any web API for that, so you can go direct over it, means website over there, and you can collect the data what you want.
Yeah, you can write a Python code. That code will fetch information from that website or the web page and then extract the information that you need.
Okay, okay, okay. You got it. Thank you.
Welcome.
Anirudh, this is Sanjeev. So, my question is, now, for example, the website which you are showing on screen right now. So,
Yeah.
when I were reading a screen content or maybe a website content, if I
Yes.
want to read a specific content, like on the website, it is somewhere it is written as in Chinese language. For
Yes.
example, I need to read that particular targeted contents only. How
Yes.
do we do?
So, for instance, you wish to just read this content. Am I right?
Yes.
Yeah. So basically what you do is just as we'll be doing in this session is you create you install the Beautiful Soup library, then you write the code to get this entire HTML content. This is loading. Yeah. After that you parse it, which is not really difficult to do because it allows you to do it very easily, and then you traverse down the HTML tree. So for instance, this Chinese content is inside a class of simple, inside a UL element. UL stands for unordered list. You can think of it as a list with bullet points. So in a list with a class attribute of simple, so we just tell the Beautiful Soup library that okay, there is a list on this page with a class of simple. I want you to extract all the information from it, and you do that, and then you can do whatever you wish to do with it. Now you can do it with any of the web pages, and it doesn't really have to be an ordered list. You can do it with images, you can do it with videos, you can do it with paragraphs, you can do it with whatever we show, as I'll show you in this session.
So, sorry, I'm again having a question. So, for
Sure.
example, if I'm reading HTML content or any of the website,
Yeah.
and it is all showing as a text or some graphical images. So,
Yes.
how do I come to know that there are some kind of tables or maybe reports are
Oh,
attached along with that,
sure,
and
sure.
I need
So
to extract the data from that?
sure. So the first thing is when you are thinking of scrapping a website, the first thing that you need to do is you need to go to that website and look at its HTML content to figure out how to get the information that you need, because they haven't provided a web API. It's not just as simple as just taking a URL, sending a request and getting the response. So you have to do a bit of a research in this department. So you go to the website. Let's say, for instance, this is the first time I'm visiting this documentation website, and I decide that I want to extract this information as you suggested. Then I look at the HTML content of this page like this. Now you, whatever content that you wish to extract, there, because of the developer tools in Chrome or any other tools, what you can do is you can click on this button which says select an element in the page to inspect it, and then go to the content that you wish to extract. So I wish to extract these, yeah, so I wish to extract these Chinese links. So what I can do is just simply look, okay, so I wish to extract these links. They are inside inside an unordered list with a class simple. Inside them there is a list item. Inside them there is a link, and I wish to extract the text of those links. Now you can do it this way, and it's usually a better idea to be very precise about what you wish to extract. So if you just said that I wish to extract an unordered list, that would create a problem because there may be another unordered list on the web page, and you will have to then parse a lot of content just to get these three information. So be very precise and look at the content of the website before scrapping it. That way you can understand how you need to begin scrapping it. What are the elements that you need to understand? What are the classes that we need to reference in order to get the data that we wish to? Does that answer your question?
Yes, Anirudh. And will you be showing us a code or maybe a hint of that? So
Yeah.
once I choose which content I want to read, I can target my Python program to read from that link. So
Yeah, so for
will,
this session, I'll be showing you some of the code so that you can extract information from a website. So you don't have to worry about that. This session, I'll show you.
okay.
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 Okay. So this is what we have right now, and let's begin with our session today. Okay. So for this session, because we need to get some information from an HTML page, what I have for you is yeah. So an HTML page, here it is. So this is the HTML page that we'll be scrapping. You can think of it as a blog. So I'm sure you guys have visited several blogs. So this is one of the blogs. It contains posts. Each post will have a title that will have a link to a full on blog post, and this is the summary of the title. So when you click on the link, it will go to the entire blog post. So for that, first thing I'll need to do is I'll need to run a server. Now it's perfectly alright if you don't have a server. You can use any other website or anything that you wish to. I'm creating a server because it makes it easy for us to send the request, get the information from the request, parse it, and then use it. Now if I don't have a server, then I'll have to open this HTML file in Python, which isn't always the case that you can do it, because if it's a website that you don't own and so you don't have the HTML content, you need to get it from the website. So for that, I'll be using something called light server. So it's checking the version of the light server that I have. Yeah, it's working. So the light server is working, and this is the server that I have. Now if you don't have light server installed, what you can do is first install Node.js. This is Node.js. You can go there and always remember to download the LTS version. LTS stands for long-term service. So you can download it and install it. It's installed like any other package that you can find online, and then you write npm install -g. -g stands for global, so it will install it on your PC so that any project can use it. lite-server. I already have it installed, so I won't be running this command. And so yeah, so now what I'll be doing is I'll start the light server. in the current directory. Make sure that you are in the current directory. Mine is in the D drive web scraping directory. So I do it, and because the name of the HTML file is index.html, I get this. So this is the content that I'll get. Now what I'll be doing in this session is I'll be getting this content, parsing it, and then getting the information about the title, the summary, and the link of this title. So this is article1.html and article2.html and so on and so forth. And after getting the content, I'll store all of this in a CSV file, because usually when you're doing web scraping, you are getting the information from the web server in an HTML format, parsing it, and then storing it in some form or the other. So like a CSV file, an Excel sheet, a database, a small SQLite database, or a JSON format, any way you wish to do it. So let's begin. So the first thing that I wish for you to understand is that you need to have installed all the packages that I mentioned. So these were Beautiful Soup 4, requests, and LXML. So after installing these packages, what you can do is, I have this HTML file because I wish to show you how to parse an HTML file, and many websites online either don't allow for their website or web page to be crawled or scrapped in a way.
So Anirudh, one question here: this Node.js package, do you need to install in the same directory, or it can be installed in default program files directory?
Default program files directory. You can install it anywhere you wish to. There is no problem. So Sunil has asked, where can I get the HTML file? So for this session, I've created this HTML file myself. If you wish to, I'll ask the trader to upload it in Git so that you can get it. But you don't necessarily need this HTML file. You can use any HTML file that you can get. The point that I'm trying to get across in this video is how you can use Beautiful Soup and parsers and all of that to scrap any website. So because I'm using my own created HTML file, I'll show you how to use this. But you can use it with any website, provided that they give you permission to scrape it. Now, scraping is you can say it's a difficult thing, because when you scrape a website, usually those websites don't allow users to scrape their website. So if you have like seen the structure of an HTML page, you would have seen the structure of a directory that contains the HTML pages for a website. They have a robots.txt file. This file contains a list of the files and folders that the website owner or the owner of the server does not wish the crawler to crawl. Now, if you're creating a web crawler, then this might be a concern. But since you are creating a web scraper, you don't need to do that. Another thing is that when you create a web scraper, what you do is you send a request to the web server. Now, this means certain load on the bandwidth of that web server. So whenever you are scraping a website, do make sure that either you have the permission to scrape that website, or you're not doing anything labor intensive on that website so that it could essentially bring that website to a halt. Most of the time it's fine, but many a times there could even be legal actions, because the website could get down. It could be your fault. So when you're scraping a website, always make sure that that you are not doing something very intensive that ends up hanging the website, and creating multiple instances of your scraper and then scraping the website. Or another thing that you need to worry about is that that you're not scraping something that the person does not want you to scrape. So just make sure that you're not doing that. And another thing, when you're scraping it, do make sure that the information that you're scraping could not be gotten from an API, because if it can be, then it's actually very easy to just get the information by requesting it from a URL instead of scraping an entire web page or website. So
Anirudh, sorry for interruption. So when I say that if I'm reading a website or if I'm scrapping a website, how do I know that whether I have permissions to scrap the data from that website or not?
Yeah, many websites actually, so you can look at their robots.txt file. Many websites do provide that. So if you're creating a crawler using Scrappy or creating a parser, what you can do is you look at the robots.txt file. This is one of the most easiest things to do. If you're looking at the robots.txt file and they have mentioned the name of the HTML file that you are going to scrap, and they have mentioned that they do not wish for this file to be scrapped or crawled or whatever, then what you can do is you can just not do that, because that would be against the wishes of the creator of the website or the maintainer of the website. So don't do that. And yeah, that's the first way to do it. And secondly, like I said, if you are
So,
using a web crawler, yeah,
sorry, where can I check that?
so in a website, when you're crawling it, you can request it. So for instance, usually it's in the root of the directory. So if you wish to, you can just go robots.txt. Right now it's showing you what are the robots.txt file and how to use it. So let's say that there is a robots.txt file, robots.txt. This if it's in the root of the directory, then you can just replace the localhost 3000 with the name of the website. So for instance, www.mywebsite.com/robots.txt. So you can get it this way. Our website doesn't have it because it's just a local website and only I'll be doing it, so you don't have to worry about that here. This is exactly the reason why I'm using a self-created website for demonstration instead of going on a website that I do not have any permission to access.
So this scrapping activity you can do both on response page as well as request page, or only the response page, the output data?
So you can do it with so there's no request and response as per, because when you are sending the request, you're getting the response as an HTML page. So this is the data that you'll be getting as a string, and this is the data that we'll be using, like parsing it, so you get it as a response from the website. Yeah.
Okay.
So okay.
So
Okay.
I mean, the reason why I was asking, there are situations where you submit the form data to the server to get the
Yes.
response. That form data itself, you can do the scrapping, or the response what you get in turn on that you can do the scrapping.
Okay, so the first thing is the form data have nothing to do with scrapping. Scrapping can only be done with the information that's being shown on a website. So for
Okay.
instance, yeah, so form data you can submit it as a user, but for that you will have to log into the website, then fill in the information, then click submit. Now, if you wish to automate this process, this could be done using other packages like Selenium, and other automated automation packages are available. For scrapping, what we do is we take a look at the website, we look at the content that's already present there, then we send a request, get the response as the HTML page's string representation, and then we parse it and then extract the information. So forms don't really fit into this equation. If you wish to
Okay.
create a script or a program that submits a form automatically for you, for that you can use Selenium and other web automation libraries. But Beautiful Soup is not really for that.
Okay. All right.
Okay, so let's begin with scraping the website. So the first thing what you do is you create a new Python file. I'm going to call it scrape.py. Py is the Python extension, and now I'll be importing. So from bs4, which is the name of the package, import.
What is this editor you are using?
I'm using Visual Studio Code, VS Code. So
Okay.
yeah, you can use it. It's very good actually. So I'd suggest that if you are doing something important, you can use Visual Studio Code. This is the information about the editor.
Okay. Till
And
now
I'm
we are
also
using Spider, and uh,
yeah, Spider and the
Jupyter.
Anaconda, Jupyter Notebook,
Anaconda,
Anaconda. Yeah.
Jupyter.
So
Jupyter.
yeah, Jupyter Notebook. Yeah. So they are also very good. So you can use them as well, but they are more suited for data science and data analysis purposes. Here we're just extracting the information and then storing it in a CSV file. So I'll be using Visual Studio Code, and I'm also using an extension in the Visual Studio Code library. It's called Python. So Python extension. This is why I'm getting this these code completion hints. Okay, so after doing that,
For Python, which ID do you use?
Visual
for
Studio.
Visual Studio Code. Visual Studio is a full-blown IDE. Visual Studio Code is like 24 to 30 megabytes, and it's very small, and it's quite useful. Visual Studio is more useful when you're developing an entire application using C Sharp or any other Microsoft technologies.
Okay.
Okay, so if you're interested in using this, you can download it free from Microsoft's website. Visual Studio Code is the name.
Thanks.
Okay. So this is this is the class that we imported, Beautiful Soup, from the package BS4. Now we'll create a new instance of the Beautiful Soup class. So you can name it anything you want. I'll be naming it Soup. Now Beautiful Soup. Now as you can see, it has two arguments that I need to pass in it. Markup, which is basically the string representation of our HTML page. So for that, I'll use the requests library that we have installed. After that, req requests dot get, and inside the get, I'll paste in the web address. So it's http://localhost 3000, and when I get it, I want the text prompt. Text basically means just give me the string representation of the entire HTML page. So just give it to me as a string. And now I need to pass the the parser's name. So I need to pass LXML. So you can use LXML. If you are using any other parser, you need to look up the parameter that you need to pass. Inside the Beautiful Soup library documentation page, you can go, I think it's somewhere down here. It will show you how to use any other parser. Yeah. So I'm using LXML. So this is how you use it. If you wish to use the built-in HTML5 HTML parser inside Python, you need to pass this parameter. For XML, you need to pass this, and for HTML5 lib, you need to pass this. That is after installing HTML5 lib. If you're wishing to use the built-in HTML parser, you don't need to install anything. However, it could be slower than LXML. So after doing that, let me just print soup. Let's see what this gives us. So let's run this py, and the name of the file is scrape.py. So scrape.py. Now if you are using Linux or Macintosh, you need to type PITHON entirely, but on Windows, after I think Python version 3.4 or 3.6, you can type just py and it will run. So I can do this, and this is the entire string representation of the website. Now one thing that you need to notice is that it's not formatted very nicely, so it's very hard to read. So you don't know where the body starts, where the body ends, and what are all the tags that are inside the body tag. So for that, what you can do is there's a method called prettify. So after using prettify, what you can do is scrape, and as you can see, it's formatted nicely. Now we can see where each tag starts and where each tag ends. It's indented nicely. Now after this, since we don't need this, and now what you do is you go to the website and you look at the structure of the HTML page so as to figure out how to extract the information that you wish to extract. So what I want to do is what I always do is usually I take the information from if I wish to get information from multiple sites. So for instance, let's say that I wish to get the information from like for instance, I wish to get information from multiple HTML tags. So here we have multiple posts, and I need to extract the information of all the posts. what you can do is you can firstly just get the information from one post, which I have here, extract the summary, the title and the link, and then you can just replace that one with multiple. So what I'll do here is this. First, I'll show you how to extract information from a single blog post or article. So if I wish to get the title and the summary and the link of the first blog post or the latest blog post, if it's ordered ascendingly, then what I can do is I can just type POSTS, or you can also type articles, ARTICLES, is equals to soup dot find. Now we'll be using find and not find all. Find and find all are a little different. So I'll be using find. Find all will return all the instances of this. So I want a div. Now how do I know I want a div is when we look at the HTML content, I want this entire post. This is a div with a class of post. Now, so if I wish to use it, what I do is I pass in, I want the information inside a div tag, the first div tag that you find that has the class, and we'll be using a keyworded argument named class underscore. The reason we are not using class is because class is already a keyword. So then we name the class, which is I think post. Let me check again, post, yeah. And then print article. So if I run this again, now you can see we have extracted just the latest post. It is the latest post because we're getting the first blog post title and it's appearing at the top of the page. Now let's see what the information that we need to extract is. Yeah. So the first thing we wish is the title of the blog post. Second thing would be the summary, and third thing would be the link. So the link is basically this. Right now I don't have an HTML page for article 1 and article 2 because they won't be necessary here. So okay, let's look at the information that we wish to extract. So the title is inside an h3 with the title, with the class title. Inside that there is an a tag that has the text as the title that we wish to extract. So to use that, we need to do is title is equals to article dot. Now you can access them as properties on an object. So what we want is to use the articles h3 with the a which is the link. So we want to extract information from the post's h3's link. So we can do this using article, which is the entire post, then h3, which is the heading, and inside that we have a title, we have a link with the text that we wish to extract. So we go dot a, and we wish to extract the text. We don't wish to get the all the information about the tag, so we type text. And let me just print it to see if it's working correctly. Whenever you are working with data like this, you should always make sure that you're getting the correct data. So blog post one title, so we're getting the information, exactly the information that we wished. Now what we need is the summary. So the summary we can get the same way, just look at the HTML content. So it's in the summary that we want is inside a p tag inside the post. P stands for paragraph. So very similar, just go to article dot p dot, don't forget to use the text attribute. This is the text that we have, blog post one summary, and I think this is the one that we'll be getting if we check summary. and let's try it again. Scrape.py blog post 1 summary. So we're getting the information that we need. Now we need the link. Now link is a little different because let me show you. Link is equals to, so the link is very much, we get the link very much the same way that we got the title, but here we don't wish to get the text, we wish to get the value of the href attribute. Href stands for hyperlink reference, so it gives us this. We should have slash article underscore 1.html, but to get that we don't use the text property, we use the href attribute. For that we go article dot h3 dot a, and now we want the href attribute, so we access it like we are accessing a key in a dictionary. Now let's print that and see if I'm getting it. So slash article1.html, so we're getting the link as well. Now what we want is we want this information, title, summary and link for all the posts. So remember, like I said, that we first get the information for one post and then we create the HTML file so that we can get, we create the Python code that we can get this information for all the articles that we need. So for that, what we can do is we can use if for.
Anirudh, now for example, when I'm reading that link, I found that within that link there is some like values or maybe a data set is there, or like a data. Yeah. So how do I read that data?
So like inside the link there is data. So for instance, when you click the link, it opens another page and the data is on that page. Is that what you're saying?
Yes. Now, for example, this will give me some kind of rows and columns, which gives me some kind of data at that website, and I want to get the data from there.
So you wish to get the data. So for instance, are you asking that if I have a table of data on a website, how do I extract information from that table? If I'm understanding this correctly.
Yes. Yes.
Yeah. So it's basically the same process. I mean exactly the same. So let me show you. Okay, index.html. So the tables are created using, I think, the table tag. Then you create the table row with the table data, and the name of the table data could be anything like this, simple data. Now usually when you are using a web scraper, you look at the website, and most probably when you're looking at a website, they have some classes on those table data and table rows and tables, so that they can apply some CSS styling to it. Now we can use this. Let's say the name of the class is data. Similarly, I create another row and the class is data, sample data 2. Let's see if it's showing up on the website. So this is the table that you were talking about. Now if I wish to get the data, what I can do is I can just tell, let me just show you here. Okay, so I can just say soup dot find a tag that is table data with the class name as, what's the class name that I gave? Data. Yeah. So this is the data that we'll get, and I want the text attribute of it. Let me see if it's working. Py is scrape.py. So we are getting the data for a single row. Now let's say that there are 3 rows, and I wish to get data from all the 3 rows. So what I can do, like we were going to do in the demo, which we'll do, but for now let's address the query that you raised. So for data in soup.find, and instead of find we do find all. That way we can get all the tags that are of td, which is this, with a class of data. So we get all these three, and then what I do is I just print data dot text. So as you can see, I've extracted the information from the table. So you can do this with any of the websites. The first thing that you need to do is you need to take a look at the HTML content to figure out how you are going to tackle this problem. Now, it could be the case that they do not have this class. In that case, what you can do is just take the information from all the table data elements. There are only 3, and you can just use that. But in a large website, they usually do have a class attribute, so you can use that.
Got it. Got it. Thanks. And Anirudh, now for example, when this is like I'm simply read a for loop and read all the table content. I
Yes.
want to save it in a like a CSV file
Yes,
for a
I'll
later
be showing you
use.
that. Yeah, I'll be showing you that. Okay, so the thing that we're going to do is get information from all the posts. So for that, what we need to do is we need to first find all. So here we are using soup.find. What I can do is I can just click save it here. Okay, and okay. So for article in soup.find, or after we find all the div items with the class post, this is what we have. And indent it properly. Yes. So now let me just print it to show you if it's working correctly. So we'll be printing the title, the summary, and the link. I think it's called, yeah. So py scrape.py, and as you can see, we're getting the information that we need from all the posts. So there are 6 blog posts. We're getting the title, then we're getting the summary, and then we're getting the links. So it's working correctly. Now the final thing that we need to do is we need to store it in a CSV file. Now thankfully for us, Python has a built-in library for scraping for dealing with CSV files. So what we can do right now is, as you can see, there is no CSV file here right now, so we'll have to create one as well. So we can first import CSV. This is a built-in Python package, so you don't need to install it. Now what you do is you create a CSV file. So I think you do it with what, CSV underscore file equals to open. The name of the file will be storing it in a file called data.csv. Now you can name it anything you wish to. I want to call it data.csv. And the second thing we'll pass is the mode. Now we wish to write to this CSV file. So if you wish to write to a CSV file, use the W flag. If you want to read, you don't pass anything, or you can pass the R flag. We'll be passing the W flag, which means you wish to read the data. No, sorry, write the data. After opening the file, we need to pass it to the CSV dot writer, and we type the CSV underscore file. Now we can, yeah, or we can type it, name it writer. I'll name it writer. So this is what we're doing. Now you could, if you wish, to do it this way by just doing it this way. However, there is a slight benefit of doing it by creating a variable that stores the file handler, and then we pass the handler to the CSV writer. I'll show you the benefit in a minute. So this is what we're getting right now. Now when we are writing to a CSV file, we write it in terms of rows. So first thing we need to do is we need to write the headers. Headers are basically, you can think of them as the title. So at the top of the CSV file, we'll have 3 data columns, which will tell us the data that everything inside that column stored. So let's write writer dot write row. This is the method that we'll be using, and this takes in an iterable. So you can pass it anything that we can loop over. I'll be passing it a list of items. So we'll be storing the title, the summary, and the links. So this is done. Now all I need to do is create a row and then type it. So row, and then row is equals to the title, summary, and the link. Now after writing the rows, what we need to do is we need to close the file. It's always important to close an open resource, because this could result in memory leak if you don't close it. So this is why when I said that there is a certain benefit of storing the name of the file or the file pointer or file handler, whatever you call them, in a variable and then using it later. So we'll close the file, and that way the information that we wish to write to the file gets stored. Now let me run this again. Hope I haven't made any mistakes so far, and it works. And this is the CSV file, assuming all the data is written into it, and it is. Now one thing that you are noticing is there's a line break or an empty line in all of these between all of these titles. So let's just look at the file. Yeah, so as you can see that there's when you're writing it to a CSV file, it's leading to an empty file. So the reason for that is, whenever we're writing inside a CSV file, we can just instruct it to not create a new line. So here you go. It means that for a new line you don't put anything. So because we are writing using the writer, this also creates a new line, and this also creates a new line. So that's why there are 2 new lines. So for that, after doing that, we go py scrap.py. So it works. And now if we look at the file, yeah, so it's working correctly. So this is the blog post, this is the summary, and these are the links. Now one thing that you're noticing is that the links are not properly formatted. So we are only getting the end of the link, we're not getting the entire website, like localhost 3000 :/link, the link that we can just click and go to the website. So to fix that, we'll write some code, but why we're getting that is because I'll show you. So usually links are not written as absolute links, they are written as relative links. So a relative link is basically link of the current site and append that link that we have. So we have article_1.html, and we're appending it to localhost :3000. But in the HTML tag, we're only given /article. So if you wish to get the entire link, which is this, what we can do is we can again write some code. So this is basically just some normal string concatenation. We get, this is the link. Now this is where we wish to insert the link. Then we use the string.format method that is built into Python. And then
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
Always remember to close the CSV file, because if you don't close it, you might get a permission error. As you can see here, permission error, because the file is open, we are not allowed to edit it. So yeah, I don't wish to save it. After I've closed it, I run this again. It works perfectly. And now if I open it, and as you can see, we are getting the link as we wanted. So now if I wish to, I can just click on it. Unable to open because, yeah, okay. So you can't open the link from Excel, but you can open it, I think, from Visual Studio. Let me see if I can do it. Yeah. So here's the entire link. Now another problem is that they're adding 2 slashes. I made some mistake in the code. Let me just rectify that. So yeah, and now let's scrape it again. Yeah, don't save it. Py scrape.py, and there it is. So the links are perfectly aligned. They are, yeah, so it's working as we expect it to work. So I hope that covers it. Is there any question?
So, Anirudh, in the beginning of this session, or maybe before creating that scrap file,
Yes.
you have shown us to like installing a light server. So, what is
Yes.
use of that? If I'm
Okay.
writing a Python program, I'm running on a different machine.
Yes. So light server, okay, so this is the HTML page that I have. I created it. It's called index.html. Now if I wish to open it, I can open it like this. This will just open it on my local web page. But since I wanted to show you how to get the information from a website, now for that you need to send a request to a web server. So this is why I'm using light server. Light server is nothing but just a dummy offline server. It's a server that you're running on your own PC. This is why we're getting the web address as localhost, and the port is 3000. So if I were to not do that, and if I were to use like the HTML page that I have created, so for that I'll need to, instead of using the request page, I can just open it, give it the file name index.html, and I think this is how it works. I'm not exactly sure. I'll see. Py scrape.py. Okay. So, oh yeah, data.csv is open. Let me close it. Don't save. Py scrape.py, and it works. So the reason why I used light server is because I wanted to show you how to get the information from a website. But since I created the web page on my local machine, I needed to serve it using a server, a local server, if you will. So this is exactly why I use light server. If you don't wish to use light server and experiment it on your own web pages that you have created and have it with you, you can just use the code that I just wrote. Instead of using the requests library, all you can do is just open the file inside the beautiful soup, and then type in the name index.html or whatever the name of the file that you are using, provided that they are both in the same folder, the scraping file as well as the HTML file, and then you can just parse it as normal. Now I'm using the request library so that I can show you how to get the information from the server. Please paste the code in the chat box. So do you wish for me to paste the entire code? If you want, I can paste the entire code. Yeah. So this is the entire code. So I pasted the entire code, and let me just paste the one with the this one also. Okay. So I pasted the one with the request library and also the one with the HTML page. I think this should help you. You can use the request library as well as the normal page. Now you can use light server if you wish to, and if you're using light server, you can use the request library. If you're not using the light server and you're using a local HTML page, then you can open it inside the beautiful soup. And lastly, if you're using it on any other website, do make sure that they have not asked you to not do that, because that could be difficult for them to maintain the server, and it could also have legal repercussions. So is there any other question?
So the quick question is, for example, I'm reading a file or maybe a website called discoverychannel.com.
Sure.
Now, do I need to install light server or
No, you
not?
don't need to. Yeah, sure. you do not need to install light server. Light server is just for serving the web page locally. So if you are getting the information from an website that's online, like you said, discoverychannel.com, in that case, you do not need light server at all. What you need to do is you just need to type in the name of the website here. So in our case, because I'm using light server, I have localhost :3 something. Now, since you said you have discoverychannel.com, I say discovery-channel.com, and then you edit the code as per the structure of the HTML page that you get and the information that you need. And after that, you just run the code and it will work perfectly without any light server requirement. The reason I use light server is only because I needed to show you how to use the requests library to get information from a website. And I think, yeah, that's it. Any other question?
Okay, yes, I have a question.
Sure.
I have a question over here. So for a production use, means let's suppose in a production, I want to scrap a website of my competitor, and
Yes.
here they have multiple pages, definitely like Amazon. So I need to go
Yeah,
to the every page of Amazon and get the price so that I can list my price. Just
yes,
comparing with him or doing any data science. So
yes.
for that, do I need to give all the URL one by one by one by one, and how I do it recursively in multiple pages? You got my
So
question,
there
right?
are, yeah, sure. So there are multiple ways of doing it. As far as I'm aware, Amazon, I think, provides an API. I'm not sure. You can look it up. But even if it doesn't, but there are multiple ways of doing it. One way you can do it is just scrape the entire website for links, store all the links in a CSV file, and then use a Python script to take links from that CSV file and then scrape that website. Another way you can do it is instead of storing it inside a what should I say? Yeah, inside a CSV file. What you can do is use it use it recursively. So, for instance, let's say that you find a link on the website. So what you do is you go to that link and then scrape that website. So instead of just scraping the website that you have right now, just the first link that you see, you open a request to that website web link here, and then start scraping that. But you do need to be aware of the fact that when you are scraping a website, you need to take a look at the structure of the website and then use it. So for this website that we have, we know the structure. We know that okay, the information we need is inside a div class with inside a div tag with a class post, inside an h3, and inside that there is an a tag with the text as the information that we need. Now, if you're just recursively going through any links, then you may not know the structure of the page and your code will throw errors. So to avoid doing that, just make sure that you know the structure of the page, and you can do it either recursively, you can store it inside a CSV file and then use it that way, or I think the better way of doing it would be using Scrappy, because it allows you to create a web crawler which does the exact same thing that you are asking. Now, Scrappy is a much more full-fledged framework. So if you wish to use it, you should go through the tutorials as I'm showing right now. It shows you the how to create a Scrappy project, which is here, how to create a spider, how to run your spider, and the spider is exactly what you are asking about. It scrapes entire website. Also, make sure that Amazon.com or any other website that you are scraping doesn't uh, prohibits you from scraping the website. So look at their user. I think they have a user's license or something. So that will also contain that information, and robots.txt file is also there. So you can use either one. So I'd suggest that you use Scrappy for creating crawlers and going through multiple links, or you can use the technique that I just told you about getting all the links, storing them in a CSV file, and then one by one scraping all of the links. Either way, the information that you get will be there, but just make sure that the website that you're crawling is not prohibited and the structure of the HTML is known to you.
Okay, so you are saying the structure needs to be known before, right?
Yeah.
Is there any intelligent algorithm, like we have learned so many data science, that can
Yeah.
help us predicting that in any case that I don't have to know? Because if I want to scrap a whole Amazon website, it is very
Yes.
difficult for me to go to their every web page, remember
Yes.
where they have a tag and then code
Yes.
for the same. It will be very lengthy code. So do we have
Yes.
any algorithm for the same that we do and one go and
Uh,
that take care of that
yeah.
90%?
Yeah. So not that I'm aware of, but one thing that's I think helpful here is that when you are, if you're trying to scrape Amazon, you're scraping it for the information about the prices of the just trying to scrape it for the prices of the items that they're selling. Now, when you look at Amazon.com, it let me show you Amazon. Now, one thing is, let's say that I wish to look at all the shoes. Yes, the shoes under 499. I get this website, and now if I wish to get the price of all the shoes, I can just take the link that I have here, inspect this. This is inside a span with the price of a dash price dash whole. So I can scrape this website, or if I have all the links for all the shoes, I can just open them, and price will always be inside a link with the span, inside a span with the ID of price block or price. So what you can do is you can just get the link of all the websites, look at the ID or the class that you wish to get the information from, and then just use it that way. So just take a look at span, instead of getting a div with a class first, what we want is we want a span with either a class of a size, medium, a color, a price block buying price string, or with an ID of price block out r price, and that way you can get the information of all the pages. Now, as for the algorithm, I don't think I'm aware of any of such intelligent algorithms that can just assume the structure of the page and extract the information that you want it to extract. You could probably use a
Okay.
regular expression or stuff like that, but it would be very
Okay.
difficult, and regular expressions are very computationally expensive. So either you can
Got it.
create a web crawler, or you can use the already known structure of the website and then get the information.
So for web crawler also, we need to give the structure, right? We need to
Yeah,
know
you do
structure
you do
beforehand,
need to give the
correct?
structure, but one thing that web crawlers do is that they can recursively look at the other links that you provide them as well. So this is why
Okay.
web crawlers are like, for instance, Google has a web crawler. Now it looks at the website and stores the all the information that it can get, that it needs from the website. So for instance, there are meta tags, there are title tag, body tag, and if it finds those tags, it will store the information about those tags inside its database, and then recursively look at all the links that that website has to get a better idea of what this website is all about. So that is what a crawler or spider, or a scroller or a crawler or spider is. Now, scraper is basically
Okay.
that we just created. Just look at a single website, get the information from that website, and that's it. You can create a spider out of that beautiful soup library, but it would be more difficult. So I'd suggest you use Scrappy for creating a crawler. But if it's just one web page that you need to get information from, then you can use beautiful soup.
Okay. One last question. Can we pass the username and password as well with request if the site
Uh,
is
yeah. So
asked
the
for it?
yeah. So this is, I think, a question similar to the forms question that we got earlier. So username and password, if you need to pass in, then I would suggest that you should use what should I say? A Selenium. Selenium is a web automation tool. So it will open the browser, enter the username and password that you tell it to enter, and then click the button and then log in. Now, usually the information that you wish to get is gotten through either an API or through a website. If the information that you need to get is behind a login screen, then I think it's safe to assume that the creator of the website doesn't wish for you to get the information, because if it were a public information like the one that we just used, like blog posts and stuff like that, so you can easily crawl that. But if it's not public information, it's information private to a specific user, even if it's you, then I don't think they allow crawling for that. So getting information from by putting in username and password is not really something that you do with a web scraper. You just look at a public web page that's available without providing any information, and then you just get that. If you wish to get
So
information from, yeah.
so you mean to say if I need to scrap Facebook and with
Yes.
my login user ID and password that should not be also allowed. Means that is
Yeah,
also not allowed. Right?
that's actually not allowed. That's
Okay.
not should be allowed. That's not allowed. You can't do that. You can maybe write a script that uses Selenium to open the browser on your behalf and then enter the username and password, and then you can look at it inside the Selenium instance. But web scraping is not really about that. So I don't think you can do that.
Okay. Got it.
Anirudh, so
Sure.
quick question. So, for example, if I'm like scrolling through like a particular website, for example, um, Amazon, if it
Yeah.
allows me to get the data, for example, there might be a multiple pages or multiple links with the product
Yes.
name of say Puma, and I
Yes.
want to know that within the price range for today deals within the price range of say 2000 to 5000, what
Yeah.
all categories of shoes are available with the brand name Puma. How do I write a code for that, or what
So
are the steps to get the data?
sure. Okay. So one thing, as far as I can understand, you are saying that you need to filter the data and then get the data for that filter. So for instance, you are saying Puma shoes, right?
Correct. It's a, like
So
a product name Puma, and
yeah.
I want to know what all brand category or the name of those shoes with the Puma brand, which is available between 2000 to 5000 today, and I want to
So
extract the data for that.
so one thing you can do is firstly you can go to the Amazon website yourself, then search for Puma shoes like I have done. I hope you can see on the screen. So after that, what you can do is you are looking for something within the price range that you want. So you can filter it according to that. Let's say that I want a shoe with a size 4. Okay. Now this URL is what you need. If I type this URL here, I'll get exactly the same thing that I wanted to get previously. So you can scrape it by getting first of all this URL, then looking at the structure. Now on this page you will only get uh, the shoes which are labeled as Puma shoes with the price range that you either the price range I've chosen the size as the filtering factor. So the size 4 and the name Puma, you will get that, and from there you can begin scraping by looking at the structure of the HTML page. So I want to get information about all the, yeah, so this is, I can just look at this, yeah, s expand x corner responder, this is the class. You can just look at the structure of the page and extract the information about the price range or the current deal that's going on or whatever. So in the current range we have the price a dash price dash whole as 2123. So what you need to do is you need to first go to the page, enter the filtering information, go to the copy the website's address. This website address contains only the name and information about the products which are inside the filtering criteria that you provided, and then you can scrape this web address. So that way you can do it.
Got it. Thank you.
Yeah, sure. Any other questions?
So
So
is there any
and one
API available
one
to get all the navigation path of the entire website? For example, I mean, all the pages are organized on a website with different navigation path, right? So at a
Yeah,
website
so
level, if you want to capture all the details,
yes.
do we have an API?
So maybe this is also crawling recursively. So let's say that you go to Amazon as well. So usually all the links that you need to use are on the front page of let's say Amazon or any other. So for instance, if I want to, these are all this is the navigation that you wish to get the information from. So you can again, like I said, just sorry, you can again just look at the HTML content. That's all the HTML tags with the class of H menu, and inside them we have all of the information that you need. So you can do it that way. Now if you are asking me that is there any other way that we can just know the structure of the entire website, some like for instance, how many web pages are there, what are the folders inside which folder, what HTML page is there, and we need to scrap all of them. This is what web crawlers are for. Now you can use web crawlers as well. Also, some of the websites do provide information about the structure of the website. I in the about section, sometimes sometimes it's a file that they have, so you can do it that way as well. However, if you wish to scrape the entire website and not just information from one web page, I'd suggest you use Scrappy for that, to create a spider and then crawl the entire website with all the links that you can get. Or if you're using Beautiful Soup, just get all the links that you can that are of this website's domain. So all the links that start with Amazon.in, if I'm scrapping Amazon, and then scrap all those websites. So all those web pages, sorry. And that way you can do it as well. There is no, I don't think there's an API that allows you to do it. Just to type the name of the website and will get you all the file structure. There may be one, I haven't used one so far.
Okay.
Okay. Any other question? The question here is, do we need to extract the data one by one for each item? So yes, you do need to extract the information like we have done here. The best way to do it, as far as I can tell you, is just to extract the information about one item first, and then do it for all the items present on the page. Because the items have similar structure, we can just use the same code, and that way we get the information. So for instance, we needed to get information about all the posts that way, so we loop over all the posts and then get information about all of them one by one, and then store it inside the CSV file. So yes, you do need to do it.
Anirudh,
Yeah.
that reminds me to ask you one more question, that whenever like we gone through a particular structure of a website, I need
Yes.
to create that many variable to read the data and export it to my CSV file in a similar
Yes.
manner so I can use it. Is that
Yeah.
correct?
Yeah. So okay. So yes. So you do need. So for instance, let's say that whenever you're scraping a website, you are usually scraping it to get the information about a particular thing. So a website is, as far as I can tell, not extremely huge. So for instance, even on an Amazon web page, there are only going to be 10 items, 15, 20, 100. So what you can do is, you need information about the price. So like you need the information about price. So all you need to do is just go soup.findAll span with the class r price. This will get you the price of all the items on that page, and then you just need to get the price of item, that item dot txt, and that way you just need to create one variable to get the information about all the elements on the page. Now as far as your question about do I need to get the information about all the, or do we need to store information about all the variables? Yes, you need to store information of all the things that you need inside a variable. Now if you don't wish to store all the information, you can just write it directly. But even for that, you need to create a row and all. So I would suggest that when you're scraping a website, try to scrape small portion of it, or portion that repeats itself. So for instance, in our website, there are 6 posts. We are scraping just one post, and this post structure is repeating itself. If for instance there were like a million posts, I won't have to change my code in any way, shape or form. It will work just fine. Just the CSV file will be a bit longer. So if you wish to do it that way, I would suggest that just look at the repeating element, get the information that you need about one element, and then just run it inside a for loop or a while loop or whatever loop you wish to choose, and then write it inside that. And one other question we have is that if we have Wikipedia, there where is no data in there, only article, then how do we do that? Okay, so let's go for a Wikipedia article. Wikipedia. So the information that you are asking for is that if we have an entire block of text, then how do we extract information from that? So Wikipedia does actually have an HTML structure. So if you look into it, let's say for instance, I wish to extract just the history portion of it, or just the headlines of all the portions of this article. So I think all of them have MW headline. Yeah. So this also has MW headline as the class. So you just get all the titles with the MW headline. What I'm saying here is that even if the page looks like it's an entire block of text and it doesn't have HTML structure, there will be some. Now, if you wish to just extract this paragraph from the entire HTML, from this entire block of text, you can use, there are several ways. You can use a regular expression, which is used to extract a pattern, text matching a pattern inside an entire block of text. Or what you can do is you can just take this information, split it using the /n. So which means that you want to create a list of all these paragraphs and then just take the last item of the paragraph, provided that the contents structure has not changed and the last paragraph is what you want, and you can do it that way as well. So if you're using it on Wikipedia or anything like that, you can just use it this way.
And can we do vice versa? For example, if I'm developing my own website and I have like 10,000 records which is there to upload on that website. So unlike that, I'm reading from a website, I can simply write to that website so that it goes uploaded in one go, and I can have all the data available on my website.
Okay, so as far as I can understand, you are saying that if you have a website that you need to enter some information inside a form. Let's say that you have a website and a CSV file. The CSV file contains all the information about employees, and there is a form on the website that you need to insert all the information into. Can we use web scraping for that? Is that the question?
Correct.
Okay. So again, like I said, the web scraping is not really for that. For that, you need to use something called Selenium. Let me just show you. Selenium. So this is browser automation. You can use Selenium. There's also a Selenium package for Python. So if you're quite good with Python or like using Python, you can just use Selenium for that. Now you can just tell it to do it what you want it to do. So for instance, you give it the URL of the website. Tell it, okay, there's a form inside the website. I wish for you to get the record from a CSV file, enter the name of the employee and whatever it is according to the information that you get from the CSV file, and then press the submit button and then wait for 10 minutes. Then do it again, then do it again, then do it again. Now you can do it this way. Selenium is built exactly for that. As you can see, we have one for Python as well. So Selenium is built exactly for that. But web scraping is not about that. Web scraping is about getting the information from the web page, a public web page, not about sending information to a web page. So we work with responses, not with requests. This is why we're using the request library to get the response from this website, convert it to text, and then Beautiful Soup can use it. So if you plan to use it to submit information to a form, I'll suggest that you use Selenium. I think we do have courses on Selenium as well. So if you're interested in that, then maybe you should refer those. But web scraping is not really about that.
I just have one question. How to deploy this thing in production? Means you have written this code locally, and I want to deploy it, maybe automate it, maybe running after each one day or something, anything. So how to deploy this thing in production?
So okay, so the first thing that you need to understand that this is not a production ready code. Okay, this works fine, but if you're scraping a big website, I suggest that you use object oriented programming. That way you can create a class that will have methods that will allow you to scrape websites. Now after that you have made the production ready code and you're sure that it's going to work fine, then what you can do is either deploy it on a Linux virtual machine online, like using Azure, Amazon Web Services, or any other PC. If you want to run it on other PCs, if you want to run it on your PC, then you need to keep your PC running for the entire day or for forever, since it's a production server. But if you wish to run it on any other website, you can use Linux, you can use Windows or any other web server operating system, and then put this file of yours, which is scrap.py, whatever you call it, depends on you, and then put it inside that virtual machine. And inside that virtual machine, you just you can write. There are Python extensions that allow you to schedule the execution of the scripts. Or also, I think in Linux there's something called cron jobs, cronjobs. So cron jobs are built exactly for that. They schedule a command or script on your server to run automatically at a specified time and a date. So for instance, let's say that you have a web scraper, you wish to run it every hour and put the information inside a CSV file. So you can just paste this scrape.py file or any of the files that you have written the scraper in, put it inside a Linux server that is maintained by Azure or Amazon Web Services or any other service provider. That doesn't really matter. Just make sure that it's running all day and then schedule a cron job. Now scheduling a cron job is out of the scope for this session, but you can look it up. It's fairly easy. Just opening the cron tab and adding some file items. It works that way. So just schedule a cron job to run this file every 1 hour or however so you wish to choose, and then do it that way. You can probably do it that way also.
So we can't install this in Windows machine. Means let's
So we
suppose I have
can
a product.
yes, we can install it. We can in Windows. I think there's something else, or many cloud providers like Azure do provide you with facilities to run scripts regularly. So maybe you can use that. But for Windows, I'm not really aware if there's a command that allows you to schedule a running of a command. Or maybe
I
you
think
can
there's a
write. Yeah.
Windows should be able to use. Okay, fine, got it. Thank you. Thanks a lot.
Okay. Sure. Also, I think maybe there is you can write a Python script which is running in the background continuously, and then every hour it's running that script. So you can run it that way as well. But I don't think there's a command inside the Windows operating system like there is in Linux, which allows you to run a job or a script within a specified interval repeatedly.
Can we append this code, I mean web scraper code in the model building, just like I'm going to create
Machine
one
learning.
model over there? Yes, machine learning, right?
Yeah. So yes, you this code can be put in any of the more models if you wish to. But I think the way it works is that you first get the information from the website. You can store, like for instance, we got from the website and we've stored it inside the CSV file, and then we use that file, that information that you've gotten from the web scraping for training your models. So you can, or if you wish to, you can just get the entire information and not store it and just use it directly. But I would suggest that you store it inside a CSV file, because that way you will know what information you use to train your model. So you can do it if you wish to just get the information from the website and then store it in, and then start using it without storing it inside a CSV file and start using it to train your model. But it would be better, in my opinion, to just use it to store the information inside a CSV file and then use that CSV file to train the model.
So let's start off linear regression recap with this example. So this is Lauren. She's looking for a property to buy, but she's confused how to start. So she goes to one of her friend, Josh, and asks him if he could help her to find a property with bigger garden area for X bucks. Our guy, Josh on the right, agrees to help her to find a property, but he himself doesn't know how. So what he goes to another friend of him, explains him the whole situation, and asks him if he can do anything about it. He immediately says yes and start doing some calculations. Then he says to Josh that spending X bucks can get her a property of area Y. Now Josh is confused and asks him how did he find out. The friend goes like, simple linear regression. Now let's see how exactly he used simple linear regression to solve his issue. So here are our dependent variable and independent variable. Property size being the dependent variable and money being the independent variable. What this guy want to do? He want to find out a relation between the property size and money. So it's like if you want a house of bigger area or bigger property size, then you have to spend more money. So both of them are directly proportional, right? So in this case, we'll get a positive linear regression line, right? That is, spending more money will get her a bigger property. Okay. In other case, but again, our next scenario is she wants a bigger garden area, right? So imagine the scenario keeping the property area constant. The house area is inversely proportional to the garden area. It's like if you want to increase the garden area, so you have to reduce the house area. So take it like this.
Suppose you have already fixed the property and you want to construct a house with a garden in it. But now your demand is you want to have a bigger garden area. So if the size of the property is fixed and if you increase the size of the garden, then obviously you have to reduce the size of your house, right? So in this case, if you try to plot a regression line, you'd get a negative regression line, right? Bigger garden area means smaller house, right? Now let's take an example to see how exactly did he predict the value of the house. So in order to find the regression line, what he did, he took the historical data of property area sold in the particular price, okay, and he plotted it on the graph. So this was the plotted point of property area sold in past for a particular price, okay. Now what he did, he drew a regression line. Now to find out what property area she can buy with X bucks, he plots X on the independent variable scale and project it to the regression line. And then against that point, there he has the area Y. This is the area Y. So this is how he predicted Lauren can buy Y area of property in X bucks. Alright. Now let's see what he can and what he cannot say from this. So he can say that if Lauren spends X amount of money, she can buy a property area of Y. But what he cannot say is, will the property would have a good neighborhood or not? Or will the location be noiseless suburb or a bustling city? Right? So these are the questions which even he cannot answer using this graph. So the questions like, will the property will have a good neighborhood? Or will it rain tomorrow or not? Or is this mail a spam or not? All these kind of problems fall under a particular category known as classification problems in machine learning. Now with linear regression algorithm, we could not answer these problems. So that is where logistic regression comes into picture. Now let us see where this logistic regression algorithm that we just talked about lies in the machine learning algorithm tree. So in machine learning, we use two traditional learning techniques to build a predictive model: supervised learning and unsupervised learning. Again, look at the supervised learning. There are two categories, regression and classification, right? In regression, we have linear regression, and in classification, we have logistic regression and SVM. So our today's topic of discussion is logistic regression, which comes under the category of classification. Okay. So now that we have got a little bit idea about logistic regression, let's go a little bit deeper and discuss about what exactly is logistic regression and why do we use it. So what is logistic regression? Well, logistic regression is a statistical classification model that deals with categorical dependent variable. Again, you must be wondering, what are these categorical dependent variable? Well, these are some of the discrete variable that have two or more categories without having any kind of natural order. For example, temperature, area, or gender. Okay. So you can say that logistic regression is generally used where the dependent variable is binary, or where the dependent variable is binary, that is, only two outcomes are possible, either yes, no, true, false, 1, 0, etc. Right? And also remember a fact that you can use both continuous and discrete input data with logistic regression. So before moving ahead, let's look at the graph. See, there are two variables, one is independent and other is dependent. Can you figure out which one is dependent and which one is independent? So before moving ahead, let's take a look at this graph. So let's look at this graph. So over here, we have two different variables, hours studying and probability of passing exam. Can you figure out which one of them is dependent and which one of them is independent? So if you have guessed that hours of studying is your independent variable and probability of passing the exam is dependent variable, then I'd say that you are 100% correct. So now that you know what exactly is logistic regression, let's move ahead and see why do we use logistic regression. Well, logistic regression can be used as a tool for applied statistics and discrete data analysis. Why? Because it gets the output in the form of probabilities, which help us to easily classify the given data. Okay, so this is why we are using logistic regression. So now that we have successfully established the basic of logistic regression by understanding what and why of it, let's go ahead and see how logistic regression can be applied for classifying data with the help of an example. So here we are using an example of spam email classifier. we need to build a predictive model that would classify whether a mail is spam or not. So let's look at the approach that we are going to take while building this model. First, we'll try to understand the variable that on the basis of which we are classifying the mail. Next, we'll plot the label data. Once we are done with plotting the label data, we'll draw the regression curve. And finally, we'll try to find out the best fitted curve using maximum likelihood estimator. Alright? So let's get started. So step 1 is defining the variable. So let's start off by understanding what is independent variable in our case. So in our case, the independent variable is count of spam words. Well, here are some example of commonly used spam words. Word like buy, get paid, guarantee, winner, unlimited, etc. Okay, so these are the kind of words which when found in the mail is treated as spam. If the number of these kinds of words are more in a mail, then that mail would definitely be a spam mail. Okay, just for a better representation, let me put them in a bag of spam words. Let's put the bag. So there's a bag of spam words. Let's put all the words in them one by one. Buy, get paid, guarantee, winner, and unlimited. Okay. Now, what about our dependent variable? Well, our dependent variable is going to be the probability of mail being a spam. If the probability is 1, that means the mail is spam. If it's 0, it means it's not a spam mail. Well, in general, the mail with less number of words from the list of spam words will be treated as a spam mail. With 5 or more spam words in a mail would be treated as a spam mail. But there can be cases where you might find mails with less spam words being spam. Also, you might find cases where mails with more number of spam words is not a spam mail. So here our aim is to build a predictive model to classify the mail with minimum error. Okay, let's see what is our next step. So our next step is plotting the label data. Let's say this is a set of data that we'll be using to build the model. This is a very small data set, but just remember that whenever you are using logistic regression, make sure that you are using a large amount of data. Logistic regression works pretty well with large amount of data. It doesn't work that good with small amount of data. Okay, here just for the purpose of understanding, we are using small data set. Alright, so we have two variables, number of spam words and the probability of mail being spam against each mail. Okay. Next, as a step 3, we'll draw the regression line. So next what we'll do, we'll plot our data set on x-axis and y-axis with independent variable on the x-axis and dependent variable on the y-axis. So number of spam words in a mail is an independent variable, right? And the probability of that particular mail being a spam or not a spam is a dependent variable. It depends on the number of spam words in a mail, right? So let's plot these words one by one. So first we have is one word and the probability of this mail being a spam is 0. So it will be plotted up here. So next we have is 5 spam words in a mail and the probability of that mail being a spam is 1. So it will be plotted somewhere here. Next is 3 spam word is a spam mail. So it will be plotted again here. 2 words, it's not a spam mail. So I'll be plotting up here. 7 words, again a spam mail up here. 4 words, not a spam mail here. 9 words, it's a spam. 8 spam words, again, it's not a spam. So once we are done with the plotting, this is how our plotted data would look like. Now let's say that we have a new mail and now we want to figure out whether it's a spam or not. So before moving ahead, let me just tell you, in real world scenario to perform logistic regression, you need a large amount of data set. And also you might find many cases where a spam mail might contain only 2 words, where a spam mail might contain only 2 spam words. Or also it might be possible that you get a mail where you are having more than 5 spam words and even in that case your mail is not a spam. Okay, so here we are building a predictive model with primary aim to reduce the error. Okay, now let's say we have a new mail up here. Now we need to figure out whether this mail is spam or not. But how do we do that? Well, first of all, we need to plot a regression curve which would fit the best. And that curve would be our logistic regression curve. But now the question comes, how to find out which is the best regression curve? Okay, well, this will contain 3 steps. Well, the first step is to convert the y-axis from the scale of probability confined between 0 and 1 to a scale of log odds. Then drawing a random regression line out of the data that we already have. Then with the help of sigmoid function, we'll convert the log odds to the probability of mail being spam. We'll plot each mail on the base of their new probability values. And this will form our regression curve. Then finally from this plot, we'll find out the log likelihood values of each mail. Now from this plot, we'll find out the log likelihood values of each mail. The individual likelihood. At last, we'll find the log of likelihood. That would be our log likelihood of the regression curve. Now the question comes, what are these terms such as log odds or log likelihood means? So before moving ahead, let's discuss that. So what does log of odds mean? Let us explore this with the help of an example. So before we proceed any further, let me just clarify you one thing. This probability and odd, these are not the same thing. Let me explain you this with an example. Suppose this guy, he goes to fishing 5 times a week. So out of 5 times, he catches a fish 2 times and he failed to catch 3 times. Okay. So now in this case, what is the probability and odd for getting a fish for dinner? So let's first calculate probability. So probability is chances for divided by total chances. So chances for catching a fish. So what is the probability of catching a fish? That is how many times he caught a fish. That is 2 divided by total chance he had to catch the fish. So that was 5, right? So here probability of getting a fish for the dinner is 2 by 5. Okay. Next comes the odd. Chances for divided by chances against. That is the ratio of how many times he caught the fish divided by how many times he failed to catch a fish. Okay. So he caught the fish for 2 times and he failed in catching the fish for 3 times. So the odd for getting a fish for dinner is 2 by 3. Okay. So now that we know odds, now let's see what log of odds and log odd ratio are. Are they same? Let's find out. For your information, log odds is also called as logit function. Okay. So in our previous example where the fisherman was catching a fish, let's add another factor to his fishing. Let's add a factor as weather. So then we can recreate the entire scenario as he was successful 2 times on a rainy day. But on a sunny day, he was successful for 3 times. Now, the odds of catching fish on a sunny day is how much? It's 2 by 3, right? And the odds of catching on a rainy day is 3 by 2, right? As it's already mentioned that on a sunny day, he catches 3 times. So he is successful for 3 times and he failed for 2 times. So let's see he was successful 3 times on a rainy day and 2 times on a sunny day. So odds for catching a fish on a sunny day is 2 by 3. That is, he's successful 2 times on a sunny day and he failed for 3 times in a week. So odd for catching fish on a sunny day is 2 by 3. Similarly, odd for catching fish on a rainy day is 3 by 2. And now log of odds of catching a fish on a sunny day is just log value of 2 by 3. And similarly, log of odds of rainy day is log of 3 by 2. Now, log of odds ratio is nothing but the log of odds on a rainy day divided by odds on a sunny day. Okay. Next is log of odds ratio. So log odds ratio is nothing but the ratio of log of the odds on a sunny day to log of the odds on a rainy day. That is log of 2 by 3 by 3 by 2, which is nothing but log of 0.44. So here we can say that odds and odd ratio are both different things. Now let us go back to this step. So now that we have understanding of log odds, so we are ready to perform this step. Okay. So let's see how we converted the 0, 1 axis to minus infinity to plus infinity axis. So here we'll be converting the probability scale to scale of log odds. Okay. So for the log odds, we have a formula as log of probability of spam divided by 1 minus probability of spam. So here the probability of a mail being a spam is 1. Okay. So we get the value of log odds as log of 1 divided by 1 minus 1. That is log of 1 by 0. It's positive infinity. How we got that? So log of 1 by 0 is nothing but log of 1 minus log of 0. And log of 0 up here is minus infinity. So minus of minus infinity is what? Plus infinity. How log of 0 up here is minus infinity? Let's see. So in general logarithm, so we have log 0 with base b equals c. So if you convert it into exponential form, we get 0 equal b to the power c, right? So if the value of b is less than 1, so the value of c has to be extremely small or closer to minus infinity for this equation to be true, okay? And we'll get a positive infinity in the case where b is greater than 1 or our base is greater than 1, okay? So coming back up here, so here log of 1 by 0 is nothing but log of 1 minus log of 0, and we got the result as positive infinity, as log of 0 up here is minus of infinity, and minus of minus infinity is what? Plus infinity. How we got the value of plus infinity? Let's see. So log 0 with base b equals c. If we convert this into exponential form, we get something like this: 0 equal b to the power c, right? So for the equation 1 to be true, if the value of b or the base is less than 1, then in that case the value of c will be positive infinity, okay? For example, 0.1 to the power 1000 would be smaller than 0.1 to the power 100, right? So more the value of c up here, more closer will the number get to 0, right? And in next case, if the value of b is greater than 1, so for this we have to make the value of c closest to minus infinity. Why?
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
For example, we have 10 to the power minus 1, okay, or 10 to the power minus 10, which is more smaller, 10 to the power minus 10, right? So which is much smaller or closer to 0, 10 to the power minus 10, right? So that's why we have to keep the value of c as less as we can. So here, if the value of b is greater than 1, the value of c would have to be close to minus infinity in order to make the equation true. So in this case, log of 1 by 0, by default we have base as 10, okay? So that's why we took the value of c as minus infinity. So minus and minus of infinity is plus of infinity. So that's why we got the plus infinity up here. I hope this thing is clear to you. How we got the value of log odds as plus infinity. So we'll plot this up as plus infinity log odds. Now next, let's find the log odds of non-spam mail. So here we have the formula as log of probability of a mail not being a spam divided by 1 minus probability of mail not being a spam. So log of 0 divided by 1 minus 0. So we have log of 0 by 1, which is log 0 minus log 1, which tends to minus infinity. Okay, similar concept. Now we have our data up here. So first we'll assume one regression line. So now we have our data up here. So first we'll assume one regression line, then we'll project our data onto the regression line. Okay, now let's just go back to the step where with the help of sigmoid function, we'll convert the log odds to the probability of mail being spam. Okay, but what does this sigmoid function mean? So sigmoid function is the standard logistic function. The logistic function is defined as L multiplied by e to the power k times of k minus k dot upon 1 plus e to the power k times of x minus x naught. So here L is the curve's maximum value, k is the steepness of the curve, x naught minus x is the value of sigmoid point. Okay, so here the sigmoid function e to the power x divided by 1 plus e to the power x, here k equal 1 and x naught equals 0 and L equal 1. So this mathematical sigmoid function forms S-shaped curve which is confined between 0 and 1. Let's try to understand how logistic function works with the help of an example. So let's say we have a set of unspecified data, and on these data we need to apply a sigmoid function. So let's see what a sigmoid function can do by visualizing this graph. So let's say we have a unspecified data, and on these data we need to apply a sigmoid function. So plot this data and find out the respective y for these points. Okay, so what a sigmoid function is doing, it can be visualized from this graph, right? So you are giving some values on your x-axis, and using sigmoid function you can predict its probability on the y-axis, right? So this is the reason why sigmoid function is very useful while solving the classification problem. It takes any real valued number and maps onto a value between 0 and 1. Okay. Well, now that we have an idea of how sigmoid function works, let us move ahead with our spam email classifier. So we are ready to perform this step. that is converting the log odds graph into a sigmoid function graph. Now we have to find out the best MLE, okay, or best maximum likelihood estimator. So we are going to replace the log odd value of each mail to get the probability of each mail being a spam. So we have the formula up here, probability equal e to the power log odds divided by 1 plus e to the power log odds. So 1 by 1 will place the log odds of each mail into this formula and calculate the probability for each mail. Okay. For example, I have this mail which after projecting into the regression line gives us log odd value of minus of 3.2. Okay. So what we'll do up here, we'll calculate the probability using the value of minus 3.2. We'll place the value minus 3.2 in our formula, e to the power log of minus of 3.2 divided by 1 plus e to the power log of minus of 3.2. So from here, we'll get the probability as 0.03. So plot it accordingly onto the new graph between probability of mail being spam versus spam word count. So on the basis of probability, our mail would lie somewhere near to 0. So according to the prediction, this mail is not a spam mail. Again, for another mail which is projecting on a regression line, this gives us a log odd value of 5.6. So when we put the value of 5.6 in the formula, we get the probability as 0.99. So the probability of this mail being a spam is 0.99. So again, we put this into this graph. Similarly, 1 by 1 will calculate for each one of them. For this mail, after projecting onto the regression line, we get the log odds value as minus of 4.5. So minus of 4.5 when put into the formula, we get the probability as 0.01. So the prediction of this mail is not a spam mail, which is same as actual, right? So again, we plot this mail onto a graph, alright? So similarly, you can repeat this step for the rest of the email as well. And finally, we got the S curve up here. So this is our regression curve. But you must be wondering, is this the best fitted curve? Or how do we find out whether it's best or not? Well, this is when the concept of maximum likelihood comes into picture. So now that we have regression curve, let's find out the likelihood of this curve. So first find out the individual likelihood of each mail. Again, you must be thinking, how do we get the likelihood value? Well, likelihood of each mail is nothing but the probability value of each mail being spam. So likelihood of first mail being spam is 0.01. Likelihood of second mail being spam, again 0.01. Similarly, third 0.03, fourth 0.05, and so on till 8th mail being 0.99. Okay. So once you get the individual likelihood of each mail, multiply them to find out the likelihood of the entire curve. Okay. Then calculate the log of likelihood. For calculating the log of likelihood, you can just take the log of the previous result. Okay. You can just take the log of previous multiplied result. Here we are adding all the logs because log of A multiplied by B equal log of A plus log of B. Okay. So we got the value of log likelihood of this curve as minus of 0.084. Now let us rotate this line to find out the best fitted regression line. So we got the log likelihood of this curve as minus of 0.084. Now let us rotate this line to find out the best fitted regression line. Again, we calculate the individual log likelihood of each mail. For this one, let's say we got log likelihood which is shown on your screen. So final value we got up as minus of 0.207. So we got the value as minus of 0.207. So now if we compare the log likelihood values for these two regression lines, we'll see that line A has bigger value of log likelihood than line B, right? As line A has log likelihood value of minus of 0.084. So the log likelihood value for line A is minus of 0.084, whereas for line B is minus of 0.207. So minus of 0.084 is bigger than 0.207, right? So therefore we can say that line A has better likelihood value than line B. Now again we'll rotate the line. We'll keep on rotating the line until we get the maximum value of log likelihood. And then finally we'll choose a line which is having the maximum log likelihood, and that line would be the best fitted regression line. So I hope the concept of logistic regression is clear to you guys. So for now, this was all about the theoretical and mathematical concept of logistic regression. So the confusion matrix shows the ways in which your classification model is confused when it makes predictions. It is basically a summary of prediction result on a classification problem. The main key to a confusion matrix is summarize the count value of correct and incorrect prediction. So the image shown on your screen represents a confusion matrix. Let's see what exactly does it mean. But before that, let me just tell you how to create a confusion matrix. This would make things more clear for you. So let's see how. So for creating a confusion matrix, you would be needing a test dataset or a validation dataset with expected outcome values. Then make a prediction for each row in your test dataset. Then from the expected outcome and prediction, count the number of correct prediction for each class and the number of incorrect prediction for each class, organized by that class that was predicted. Okay, let's see what exactly does it mean. So here's an example. We have some expected output and a predicted output for that. So from here you can see that all the red color results are the incorrect predicted values and the green ones are the correct ones. So in total we have 7 correct prediction out of 10. Okay, so from here you can say that the accuracy of your model is 70%. Now here men classified as men are 3, 1, 2 and 3, and women classified as women are 4, 1, 2, 3 and 4. And now men classified as women, men as women 1 and men as women 2. Okay, so 2, and women classified as men 1. Now if you create a confusion matrix out of it, you will get something like this. Men classified as men 3, men classified as women 1, women classified as men 2 and women classified as women is 4. So from here you can say that total actual men 3 plus 2 is 5. Total actual women 1 plus 4, again 5. And total correct values, men classified as men and women classified as women, that is 3 plus 4, it's 7. So from here you can say that there are more errors while predicting men as women rather than predicting women as men. Okay, so this was about how you can calculate a confusion matrix. Now let's come back and see how to interpret a given confusion matrix. This is the sample of a confusion matrix. So here we have created a confusion matrix for a fire alarm. So this represents an actual alarm, this represents no actual alarm. Here predicted fire positive and here predicted fire as negative. So if the alarm goes on in case of fire, so it's a true positive event. The alarm goes on and there is no fire, so it's a false negative event. There is no alarm in case of fire, so it's a false negative event. And there is no alarm and there is no fire, then that means it's a true negative event. Okay, so let me just explain you this example. This should make things more clear to you. So actual alarm and predicted fire. So total true positive events we have 40 and total false negative event we have 10. So from here you can say that total number of times the alarm rang was 40 plus 10, that is 50. Okay, here we have false positive event as 5 and true negative event as 95. So the total number of times the alarm did not rang was 5 plus 95, that is 100. And this one is the predicted fire or not. So true positive plus false positive, that is 40 plus 5. How many times the machine positively predicted the fire? So that is 40 plus 5, 45. And how many times the machine was not able to predict the fire? That is 10 plus 95, that is 105. And total number of events, that is 50 plus 100 or 45 plus 105 is 150. So we have mentioned n equal 150 up here. That is total number of events. Okay, so this is how you interpret a confusion matrix. So let's move ahead. So now let me just show you in my Jupyter notebook how you can create a confusion matrix. Let me just open my Jupyter notebook. So this is my Jupyter notebook, and what we are gonna do is create a confusion matrix in Python. So the very first thing that I'll be doing up here is importing the required libraries. So from sklearn.metrics, so I'll be importing confusion matrix. Next, let's create some expected value. Let's say expected equal. So let's add some values in it like 1, 1, 0, 1, 0, 0, 1, 0, 0 and 0. Now this is my expected value. Now let's create some predicted values for that. So predicted equals, first it's predicting correct, next let's say 0, 0, 1, 0, 0, 1, 0, 1. So this is a predicted value. Now let's calculate the confusion matrix. So let's say results equal confusion underscore matrix. Inside this we'll pass our expected and predicted value. Expected comma predicted and print the result. That's it. Let's execute it. So here you got the result as 4-2 and 1-3. So what does it mean? So first we have is 4. So 0 predicted as 0 is 4 times. 1, 2, 3 and 4. So 0 predicted as 1 is 2 times. 0 predicted as 1, 1. 0 predicted as 1, 2. Okay. Next is 1 predicted as 0. So 1 predicted as 0 is just once here. Okay. And next is 1 predicted as 1, that is 3 times. 1 predicted as 1, 1, 2 and 3. So this is a confusion matrix. And what we can say from here, so total number of correct prediction made by machine is 4 plus 3, that is 0 classified as 0 and 1 classified as 1. Okay. And total number of incorrect prediction is 2 plus 1, that is 3. So we have 7 correct prediction and 3 incorrect prediction. Okay. And the total number of times the machine predicted the value to be 0 is 4 plus 2, that is 6 times. And total number of times the machine predicted the value to be as 1 was 4 times. Okay. So from here we can say that our machine predicts the result 7 times correct and 3 times wrong. So the accuracy of our machine is 70%. So this was all about how you can create a confusion matrix in Python.
A demo with logistic regression with the help of scikit-learn package. And we're going to build this logistic regression algorithm on top of the heart disease dataset. So let's quickly go to Jupyter Notebook and start with a demo, right? So this is Jupyter Notebook, guys. And our first task would be to load up the heart disease dataset. And for that purpose, we would have to import the pandas package. So I'll just type in import pandas as PD and I'll use this read underscore CSV method from the pandas package. So I'll type in pd.readcsv and I'll pass in the name of the dataset, which is basically heart.csv. And I'll store this in this dataset object. Now let me have a glance at the first few records of this dataset. So this is our dataset which comprises of all of these columns. And we're going to build the logistic regression algorithm on top of this column over here, which is basically target. So target would be our dependent variable and the rest of the columns would be the independent variables. Right. And this target basically means that, so you have 1 and 0 values over here. The 1 value means that the person or the patient has the heart disease and 0 basically means that the patient does not have heart disease. Right. Now let me also have a glance at the shape of this dataset. So I'll just type in print dataset.shape and this gives me a value of 303 and 13. So 303 means that there are 303 records in this dataset and 13 columns. Now let me actually have a glance at the value counts of this target column. So this value counts basically tells me the frequency of these two values. So I have these two values in this column, which is basically 1 and 0. So there are 165 records where the value is 1 and there are 138 records where the value is 0. So this basically means that in this data set there are 165 patients who actually have the heart disease and 138 patients who do not have the heart disease. Now I'll go ahead and actually visualize this. So I'll load up the matplotlib package and seaborn packages and I will pass in this target column onto the x-axis and the data is our data set, which is basically this heart disease data set. And what I'm doing is basically building a histogram and I'll plot this up over here. Right. So this is the bar plot for the value of 0 and this is the bar plot for the value of 1. And this basically tells us the same thing. So 165 is the value of the number of patients who actually have the heart disease. So this basically is for all of those patients who do not have the heart disease. Alright. Now let me go ahead and divide the data set into features and label sets. So I'm storing all of the features into this X object. So all of these 12 columns would be my features and this target column would be my label or would be my dependent variable. Alright. And this is how I'm going to divide the data set. So I'm going to extract all of the columns except the last column and store it in this X object. And similarly, I'll only take the last column and store it in this Y object. Alright. Now let me have a glance at these individual independent variable and target variable. So x dot head gives me all of the independent variables and y dot head gives me the target, right? So now that we have our independent variables and the dependent variable, let me go ahead and divide this data set into training and testing set. And for that purpose, I'd have to load up the train test split method from sklearn.model selection. And over here, I'm setting the test size to be equal to 0.2. So this means that 20% of the records are in the test set and the rest 80% records are in the training set. Alright, I'll click on run again. Now we have divided the data set into training and testing sets. Now finally it's time to build the model, and for that purpose I'll be importing logistic regression from sklearn.linear model. And I'm going to create an instance of this. So I'll just use this method logistic regression and I'll name that instance to be log model. And I'm going to fit this model on top of the train set. So I'm basically passing x train and y train as the parameters. Right, I'll click on run. Right, so we have successfully built the model on top of the train set. Now we're going to go ahead and predict the values on top of the test set. So I'll type in log model.predict and I'll pass in x test as the parameter and I'll store the result in y pred. So we have also predicted the values. Now it's time to calculate the accuracy. So I will type log model.score and I'll pass in x test and y test. So I want to calculate the accuracy for the prediction on top of the test set. Right. So the accuracy comes out to be 73%, which is actually not that bad. And let me actually also build the confusion matrix. So confusion matrix would give me a table of values which actually comprises of the correctly predicted values and misclassified values. So I'd have to import confusion matrix from sklearn.metrics, and again I'll just pass in y test and y pred as the parameters inside this function, and I'll print this out. Right. So this left diagonal which you see, this left diagonal actually represents all of those values which have been correctly classified, and this right diagonal represents all of those values which have been misclassified. And if you want to get the accuracy, all you have to do is add up 20 plus 25 and divide it with all of the values and you'll get the same accuracy. So let me actually add up a new cell over here and calculate the accuracy from this confusion matrix. So I have to divide this left diagonal with all of the values. So that would be 20 plus 25 divided by 20 plus 25 plus 10 plus 6. And this gives me a value of 73.77, which is the same as I got over here. So the accuracy is 73%, right? So we have built the confusion matrix. Now I'll also go ahead and build the ROC curve. So the ROC curve, it sort of gives me the right trade-off between the true positive rate and the false positive rate. So let me go ahead and plot this, and this is what we get over here. So on the y-axis we have the true positive rate, and on the x-axis we have the false positive rate. And basically you can understand this plot this way. So the closer this curve is to this top right corner over here, the better the model. That is, this curve needs to cover greater area. And this, what you see, red line, so this basically represents a classifier which would give you around 50% accuracy, and your model would be as better as it is far away from this red line. That is, this blue line has to be towards the top left corner, right? And this is how we can implement logistic regression model with the help of sklearn. Consider yourself to be data scientist at a prestigious telecom company, and the name of that company is Neo, and they are facing a major problem, and that basically is their customers are churning out to other competitors. Now you as a data scientist at that particular company have to make sure to stop this churning out, and also have to find out the reasons why customers are churning out to other companies. Right, so this is the problem statement, and what you're basically going to do is a bit of data manipulation, data visualization operations, and then you will go ahead and build the ML algorithms on top of this data set. So you'll start off with the linear regression algorithm, and then you'll build the logistic regression, decision tree, and random forest algorithms. All right, and we'll be working with this customer churn data set. So this is our data set which comprises of all of these columns. So we've got customer ID, gender, senior citizen, partner, dependents, and so on. Right. So yeah, so this is our first task, data manipulation, and to do this, let's go ahead and actually import all of our libraries. So I'll just type in import pandas as pd,
and then I'll also load the NumPy library. So I'll type in import NumPy as NP. I'd also need the matplotlib library. So I'll type in from matplotlib import pyplot as plt. So these are all of my required libraries. I'll just wait till these libraries are loaded. Right, this is done. Now I'll also go ahead and load up my customer churn data frame, and I'll store it into an object and name that object to be equal to customer churn. I'll just use dd.read underscore csv, and inside this I will give in the name of the data frame, which is customer churn.csv. Right, so I have successfully loaded the file and I've stored it into a new object, and also I've named that new object to be equal to customer churn. Now I'll go ahead and have a glance at the head of this. So customer churn dot head, and this is the data set on which we'll be implementing all of the operations. So this is just the unique customer ID. This column gender tells us about the gender of the customer, whether the customer is male or female. The senior citizen column tells us whether the customer is a senior citizen or not. So if it's 0, then the customer is not a senior citizen. If it's 1, then the customer is a senior citizen. And then this tells us if the customer has a partner or not. This tells us if the customer has dependents or not. This is the tenure of the customer in months, right? So 1 month, 34 months, 2 months, and so on. This tells us if the customer has phone service or not. Does the customer have multiple lines? And this is the type of internet service used, and then whether the customer has online security, whether he has device protection, tech support, streaming TV, streaming movies, and so on. And then this column is for contract. So this just tells you the contract type of the customer. So the contract type of the customer could either be month to month, 1 year, or 2 year, and there's a type of billing, whether it is paperless or not. After this, we have the type of payment method. So the type of payment method could be these: electronic check, mail check, bank transfer, and so on. And then these are the monthly charges and total charges incurred by the customer. Right. So now let's start off with our data manipulation tasks. So this is our very simple task. We just have to extract some individual columns from the entire data frame. We'll have to extract the 5th column and store it in customer 5. So let me do that. I'll type in the name of the data frame first, which is customer churn, and I would use .ilog. I would need all of the rows, and I would need the 5th column since the indexing starts from 0. So 0, 1, 2, 3, and 4, right? So this would be my 5th column over here, and I will store this in, let's say, C underscore 5. And I'll have a glance at the head of this, C underscore 5 dot head. Right, so we have successfully extracted the 5th column from this entire data frame, and this is the head of it. Similarly, we'll have to extract the 15th column and store it in customer 15. Right, so if it's the 15th column, then the index number would be 14, because again, the indexing starts from 0. Right, I'll store this in C underscore 15, and I'll also make this to be C underscore 15. I'll click on run. Right, so this is the streaming movies column, and I get the same thing over here. This is column number 15, and I've extracted only this particular column from the entire data frame. Right, this was basic extraction of columns from the entire data frame. After that, we'd have to do data extraction on the basis of a condition. We'll have to extract all the male senior citizens whose payment method is electronic check. Right, so there are 3 conditions over here. The first condition is the gender of the customer needs to be male. Second condition is senior citizen, the value of senior citizen needs to be equal to 1. And the third condition is the payment method needs to be equal to electronic check. So I'll give in all of these 3 conditions over here. I'll start off by giving the first condition, customer churn. I'll type in gender, and the gender needs to be equal to male. Right, I'll cut this and paste this inside this. After this, I'll use the AND operator and then give in the second condition. So the second condition would go something like this: customer churn. After this, we'd have to set the senior citizen value. Right, so senior citizen, this needs to be equal to 1, and then I'll go ahead and give in the third condition. So over here, the third condition, this is for the payment method column. So the payment method needs to be equal to electronic check. Right. So I have all of my 3 conditions over here. I'll just paste a cell below. Now, what I'll do is I will copy all of these 3 conditions and I will paste them inside this, and I will store it into a new object and name that object to be crandom. Right. Now I will print the head of this, crandom.head. So we see that this, so if you have a glance at this gender column, then you'll notice that all of the values are male. Similarly, if you have a glance at the senior citizen column, then all of these values are 1. Similarly, I'll go to the payment method column, then you'll notice that all of these values are electronic check. So I've given 3 conditions over here, and all of these conditions have been satisfied. So next up, we'd have to extract all of those customers whose tenure is greater than 70 or their monthly charges is greater than $100. Okay, again, we'll do the same thing. Customer churn, tenure needs to be greater than 70. I'll put this up inside this. Now, what you need to notice over here is we are using the OR operator. So it's either the first condition or the second condition, right? So if one of these conditions is true, then we'll get that particular record. So again, customer churn, and this time it's the monthly charges. So the monthly charges have to be greater than 100. These are the 2 conditions. So either the tenure of the customer needs to be greater than 70 months, or the monthly charges of the customer needs to be greater than $100. Again, I'll insert a cell below, and all I'll do is cut this and paste it inside this. Right. And I will store this in, again, crandom. Now let me again print the head of this, crandom.head. Right, now I'll head on to the tenure column. Now you see that none of the tenure or none of the values of the tenure over here is greater than 70. But if I go to the monthly charges column, then you'll notice that the monthly charges are greater than 100. So it's either or. So one of these conditions has to be true. And in this case, we see that the second condition is true over here, right? So if either of the condition is true, then we'll get that entire record. After this, we'd have to extract all those customers whose contract is of 2 years, payment method is mail check, and value of churn is ES. Right. I'll again copy this, paste this over here. Let me delete this from this. Right, so we have these conditions over here. So we'll have to extract those customers where contract is of 2 years, payment method is mail check, and churn is equal to yes. So let me put in all of these conditions over here. First is contract, and this needs to be equal to 2 years. So let me just check, how is it? Contract is of 2 year, right? 2 space year. After that, it's the second condition, and over here the payment method needs to be equal to mailed check. Again, I'll put in the double equal to operator, and I'll give in the value, and the value is equal to mail check, and then I'll give in the final condition over here. So customer churn, and this time the churn needs to be equal to yes. Right, so I've given all of these 3 conditions and I've separated them using the AND operator. Again, I will store this in C_random, Let me print this out, C underscore random. So we see that there are just 3 records, or there are just 3 customers who satisfy all of these 3 conditions. So let me have a look at the contract of this, right? So contract is of 2 years for all of these 3 customers. Next is the payment method, and again payment method is mail check and churn. All of these values are yes, right? So out of all of those 7,000 rows, only there are 3 rows which satisfy these 3 conditions. Next, this is a question on random sampling. So we just have to extract 333 random records from the entire data frame. And to do this, we'll be using the sample function. So I'll type in customer churn and I'll use the sample method over here. And inside this, what I'll do is I'll give the value of the number of records which I want to sample. So I want 333 records. I'll store this in C underscore 333. Let me print out the head of it. Right, so now what I'll do is, so whenever I run this, every time I'll get a different sample of 333 records. I'll run this again, right? So if you have a glance over here, so all of these values would be changing, the customer IDs would be changing, the indexes would be changing, right? So keep a glance or have a glance at these row IDs indexes over here, right? So again, if you have a glance at this, the row IDs are changing. So this is random sampling. I'm randomly sampling 333 records from this entire data frame over here, and I'm doing that with the help of the sample method. Right, and then this is the final operation when it comes to data manipulation. So I'd have to get the count of different levels from the churn column. So if I want to get the count of the different levels present in a categorical column, I have the value counts method. So first I'll give in the name of the data frame, which is customer churn. After that, I'll give in the name of the column, which is churn, and then I'll just type in value counts, right? So this is it. So let me just wait till I get the result, right? So we see that no, so the number of customers will not be churning out is 5,174, and the number of customers who will be churning out is 1,869. So you can do the same thing for other categorical columns as well. So let's say if I want to get the count values or the number of counts of different levels for, let's say, the contract column, I'll just change the name of the column over here. So I'll put it to be equal to contract, right? So there are 3,875 customers whose contract type is of month to month. There are 1,695 customers whose contract is of 2 years, and there are 1,473 customers whose contract is of 1 year. Right, so these were some basic data manipulation operations. After that, we'll head on to data visualization. All right. So here we'd have to create a simple bar plot for the internet service column. And yeah, we'd have to set the x-axis label to categories of internet service, y-axis label to count of categories, the title of the plot, distribution of internet service, and the color of the bars need to be equal to orange. Right. So I'll just type in plt.bar over here. Now I'll insert another cell over here. Now what I'll actually do is, so this basically takes in 2 parameters first. So the first parameter is the names of all of the bars, and the second parameter is the values for those bars, right? So the names of the bars would be coming from the internet service column. So internet service, and I actually want the value counts of this. Value counts, and from this I don't want the values, I just need the keys. And again I'd have to convert them into a list. So I'll use list over here. Now I'll click on run. Let's see what do we get, right? So these are the 3 levels present in the internet service column. So from this internet service column, what I've done is I've used the value counts method. So this value counts method has 2 things, keys and values. Now I don't want the values as such, I just want the keys. and I'll take these keys and I'll convert these keys into a list, right? So this is the list of the names present in this internet service column. Now I'll cut this and paste it over here, and this would be my first parameter, and my second parameter would be all of the values. And if I want all of the values, I'll just remove the method keys from there, right? So this over here would give me all of the values present with respect to this internet service column, right? So fiber optic, or in other words, the number of customers whose internet service is fiber optic is 3096. Number of customers whose internet service is DSL is 2421. And number of customers who don't avail the internet service are 1526, right? Now again, I'll cut this and I'll paste it over here. Now let me print this out. So this is my basic bar plot over here, right? So this is my bar plot. On the x-axis, I have the names representing these bars over here, right? So this bar is for all of the customers whose internet service is fiber optic. This is for those customers whose internet service is DSL, and this is for those customers who are not availing the internet service. And these are their counts over here, present on the y-axis. Now, I had to do some other things over here. I had to change the color of the bars. So the color of the bars was supposed to be set to orange. And for this, I have the color parameter, and I'll just set it to be equal to orange. I'll run this again, right? So we have successfully changed the color of these bars over here. Now I'd have to set the x-axis label and the y-axis label. So I'll just type in plt.xlabel, and the x label needs to be equal to categories of internet service. Let me type that down. Categories of internet service. After that, I would need to put in the label for the y-axis. This would be plt.ylabel, and I'll just put it to be equal to count. And then finally, I'd have to give in the title. So plt.title, and I'll set the title over here. And the title needs to be equal to distribution of internet service. Let me type that out. Distribution of internet service. I'll click on run, right? So this is our final bar plot, which gives us the distribution of internet service, and the x-axis label is categories of internet service, and the y-axis label is count, right? So this is how we can create a simple bar plot, and all of this. So these are the basic steps behind before you go ahead and build all of your machine learning algorithms. So the data pre-processing part is always the main part of your data science life cycle. So this is where you properly comprehend your data set. This is where you understand the structure of the data set. You understand the correlation between all of the columns, the correlation between the dependent variable and the independent variable. So by manipulating the data set and visualizing the structure of the data set, this is where you understand all of the patterns in the data set and you get insights from the data set. Right, so next up, we'll have to build a histogram for the tenure column. So again, it'll be a similar operation, plt.hist, and I'd have to build a histogram for the tenure column. So it'll be customer churn tenure, and I'd have to set the number of bins to be equal to 30, and I'd have to set the color to be equal to green. So I'll just type in color equals green over here. So this is our histogram, and this gives us the distribution of the tenure of the customers. So so if you look at it closely, so this is basically the count over here, right? So there are around 800 odd customers whose tenure is not even 1 month. So they are churning out before they even complete 1 month. And again, there's a huge peak over here. So there are around more than 600 customers whose tenure is 70 months or more than 70 months. And then rest is pretty much the same, right? So the average customer, this is the normal range of the customer. So it's between 200 to 400. And the average tenure of the customer, you can say, would be somewhere between 20 months to 50 months or 60 months, right? and this is where you have the peak. So you have the peak at the starting and you have the peak at the ending. Again, let's go ahead and add the title. So it'll be just plt dot title over here, and the title of the plot needs to be equal to distribution of tenure. I'll do that. Alright, so I have created this plot, and this is the title of the plot, which is distribution of tenure. So we've made a bar plot, we've made a histogram. Now you guys also need to understand the difference between a bar plot and a histogram. So a bar plot is normally used for all of the categorical columns. So whenever you want to understand the distribution of categorical columns, that is when you'll go with a bar plot. And when you want to understand the distribution of a continuous numerical column, that is when you'll go with a histogram. Right, so next up, we'd have to create a scatter plot between monthly charges and tenure. So tenure is on x-axis and the monthly charges is on y-axis. So plt dot scatter, x-axis would be tenure, so customer churn, tenure, and then I'll set in the column for the y-axis. This will be customer churn, and this will be equal to monthly charges. Let me just run this, right? So this is what we get over here. Now let me also set in the labels for this. So plt dot x label, and this would be equal to tenure. Let me type in tenure over here. Similarly, I'll also set the y label over here. So this will be plt dot y label, and this would be equal to monthly charges. Right, so now we also get the corresponding x and y axis labels. After this, I'll also go ahead and set the title. So it'll be plt dot title, and this would be monthly charges versus tenure. Monthly charges versus tenure. Right, so this is our final scatter plot where we have the x-axis and y-axis labels, and this is the title, which is monthly charges versus tenure. Right. And finally, we'd have to also build a box plot between the tenure column and the contract column. So tenure needs to be on the y-axis and contract needs to be on the x-axis. For this, I'll just type in customer churn dot box plot, and so now I'll set in this to be equal to customer churn contract, and after this I have the column to be equal to customer churn, and this needs to be equal to tenure. Let's see what is the error over here. Columns not found. So let me actually remove this from over here and let's see what happens. Alright, so now we get the result. So we had actually given the name of the data frame initially itself, so it was customer churn dot box plot, and now all we have to do is assign the contract onto the x-axis. So now when I said by equals to contract, what is happening is I'll have one box plot each for the different levels of the contract column. So I have one box plot for the month to month level, I have another box plot for the 1 year level, and another box plot for the 2 year level. And over here, the y-axis, this is being determined by the tenure column, right? So this over here, 0 to 70, this is the tenure of the customer. And what we understand from this box plot over here is, so if the contract of the customer is of 2 years, then most probably the median tenure of the customer is very high. So if the contract of the customer is of 2 years, then his tenure or median tenure would be around 65 months. Similarly, if the contract of the customer is 1 year, then the median tenure of the customer would be around 45 months. And then if the contract of the customer is month to month, then the median tenure of the customer would be around 15 odd months. Right, so these were all of the examples of visualization. Now it's finally time to head on to machine learning, right? So this was your data pre-processing part, where you had understood the structure of the data. You had learned how to extract individual columns, and after that you learned how to visualize the data and get some interesting insights from the structure of the data. We'll start off with our first machine learning algorithm, which would be linear regression over here. And linear regression, as you already know, so over here the dependent variable would be a numerical column, and you're basically trying to understand how does one variable change with respect to another variable. And over here we'd have to build a simple linear model where our dependent variable is monthly charges and the independent variable is equal to tenure, right? So, or in other words, we are basically trying to understand how does monthly charges vary with respect to tenure. So monthly charges, dependent variable, tenure is the independent variable. And these are all of the subsets when it comes to this linear model. So we'll start off by dividing the data set into 70-30 split, and then we'll build the model on the train set, pick the values on the test set. After that, we'd have to find out the root mean square error, and we'd have to print out that root mean square error. So let me go ahead and import the linear regression model from sklearn. So I'll type in from sklearn import linear model. After this, I'll type in from sklearn dot linear model import I need linear regression, right? So these are my two basic libraries. So I needed linear model, I needed linear regression. Now I would also require the train test split. So I'll type in from sklearn dot model selection import train test split, right? So this train test split method would help me to divide my dataset into training and testing sets. So now it's time to divide my data into training and testing sets. So before that, I'd have to get my target and the features, or in other words, I'll have to separate my dependent variable and the independent variable. So monthly charges is the dependent variable. So what I'll do is y equals, and I'll extract only the monthly charges column, and I will store it in a new variable and name that variable to be equal to y. Similarly, I'll only extract the tenure column, right? So I'm extracting the monthly charges column and I'm storing it into a new object, naming that object to be equal to y. Similarly, I'm extracting only the tenure column and I'm storing that column into x. Run columns, customer churn. What seems to be the problem over here? Monthly charges. Let me put it to be capital C over here. Right. Now let me print out the head of these two, y dot head and x dot head. Right. So these are the values from monthly charges column and these are the values from the tenure column. Now let me go ahead and divide these two into training and testing sets. So I'll use in train test split. I'll pass in x as the first parameter. So all of the features would be which are stored in x go as the first parameter. After that, I'd have to give in the target labels, and the target labels are which are basically my monthly charges, which are stored in y. And then finally, I'd have to give in the test size. So let me check what was the test size. So the test size was supposed to be 0.70. And then I'll also set a random state. So if I want to use these values again, I can just set the random state to be equal to the same value which I'm giving over here. This is smallest over here, right? So this test size 0.70 basically means that 30% of the records would go into the testing set. Oh, this has to be 0.30. Sorry for that. Yeah. So 30% of the records would go into the test set, and 70%, the rest 70% of the records would go into the training set. Now I'll be getting 4 results over here, and those 4 results are X-train, X-train, Y-train, X-test, and Y-test. These are actually the labels which we conventionally use. I'll explain what these are exactly. X-train, Y-train, and then we have so this would actually be X-test first, X-train, X-test, Y-train, and Y-test. So over here, X-train represents all of all of those values of your features which are present in the training set. X-test represents all of the features which are present in the test set. Y-train represents all of the dependent values which are present in the train set, and Y-test represents all of the dependent values which are present in the test set. And whenever we are building a model, we'll build that model on top of the train set, right? So we'll build the model on top of X-train and Y-train. Let me also show you the shape of all of these. So X-train dot shape. Let me do the same for the rest. X-train dot shape. I'll make this to be Y-train. I'll make this to be X-test. And I'll make this to be Y-test. Right. So X-train, Y-train. So the training set has these many records, and the testing set has these many records over here, right? So these are all of the features which are present in the training set, and these are all of the features which are present in the. Sorry, these are all the features of your dependent variables, and these are all of the features of the independent variables, and these are all of the target values when it comes to the test set, and these are all of the target values when it comes to the your dependent variables. All right. So now that we have X-train, Y-train, X-test, and Y-test, let's go ahead and build the model on top of the training data. Now I will go ahead and create an. So normally your training data would be bigger because so let's say your splits are either 70-30, 65-30, or 80-20. Because the more data you give for training, that is better. But then again, you can't give out your entire data for the training set, right? So the purpose of training your model is to make sure that your model learns the underlying patterns of that data. And once the learning is done, you'd have to also test how well the learning is done, right? And to test, you'd also need a sample space for that test set. So consider this simple case. So let's say you're giving an exam, but for that exam, let's say if you got 100 exercises. So your syllabus comprises of all of the 100 exercises, and you'd have to learn all of those 100 exercises. But when it comes to your test, it will have only 10 exercises from all of those 100 exercises, right? So the training needs to be done, but then again, the test space, it needs to be completely new, which is not learned by the model, during the training phase, right? That is why the training set has to be completely different, and the test set has to be completely different. And the division of training and testing set is done to make sure that overfitting doesn't happen. And when overfitting happens, the problem is this model will perform well on this particular data set, but when a new data set comes in, it'll miserably fail. Right? So this is the reason why we divide the data into training and testing set. Right. So now let me go ahead and create an instance of the linear regression model, and I'll name that to be regressor. So I've created an instance of linear regression over here, and I'll go ahead and fit the model on top of the training set. So it'll be X-train, and Y train. Right, so I fit the model on top of the training set. Now it's time to predict the values. So it'll be regressor dot predict, and I'll be predicting the values on top of the X test. And I will store this in, let's say, ypred. Now I've fit the model on top of the training set, and I've also predicted the values on top of the test set. Now I'd have to know how well the prediction has been done, and for this, when it comes to linear regression, we have something known as the root mean square error. So the lower the value of root mean square error, the better your model. And again, we have an inbuilt method to calculate the root mean square error. So I just have to import sklearn.metrics, and from sklearn.metrics I'd be importing mean square error. Now after this, so mean squared error, what we actually want is root mean squared error. So I would need the np dot square root, and let me use the mean squared error, and this takes in two parameters. First parameter comprised of the actual values which are present in y test, and second parameter are the predicted values which are present in ypred. So I will cut this, and let me ease this to be in this over here. Right, so we get a root mean squared error value of 29.39. Right, so now let's say if you build some other model with some other independent variables. Now we'll go ahead and build the model, and we'll also predict the values. Now after predicting the values, we'll also have to calculate the root mean square error. So this root mean square error is actually relative. So let's say if there is some other model, let's say model 2, and the root mean square error of that model 2 is, let's say, 39, then this model would be better than the second model. Similarly, if there's, let's say, model 3 whose root mean square error is 19, then that model 3 would be better than this model which you built over here. So here we are predicting the monthly charges values. That is exactly right. So let me actually show you that. So let's see, I'll put in ypred, and let's say I'll have a glance at the first 5 values, right? So these are the monthly charges predicted. Let me also show you y test, then 5, right? So these are the actual values, and these are the predicted values over here. Right. So this is not exactly dependent on the churn of the customer. So what we are doing is we are building an entire data science lifecycle process. So over here we are trying to understand the relationship between the tenure of the customer and the monthly charges of the customer, right? So over here what we are basically trying to understand is, let's say if the tenure of the customer is at around 10 months, what would be his monthly charges? Again, if the tenure of the customer is 30 months, what would be his monthly charges? Similarly, if the tenure of the customer is 70 months, then what would be his monthly charges? So this is what we are trying to understand over here, right? So this time we'd have to build a logistic regression model where dependent variable is churn, and independent variables are tenure and monthly charges. Again, I do the same thing. Let me actually copy these two. So this is what we did over here, Aditya, right? So this is where we went ahead and predicted the values, didn't we? Right? So I have divided my data set into training and testing set. And over here, I am fitting the model only on the train set, right? So training is happening on the training set, or the model is learning from the train set. And we are predicting the values on the test set. So this model, this linear regression model, has not yet seen all of the records present in the test set. It has only learned from the values which are present in the training set. So we'll go ahead and build the linear regression model now. Customer churn. Let me also put in Y. I'll do the same thing. So in the logistic regression model, our independent variable is monthly charges. let me put monthly charges over here, and the logistic regression, sorry, the dependent variable is churn. So I have extracted or I have got my features and my target over here. So features are basically my monthly charges and my target is present in the churn column. And I'd want to understand if the customer would churn or not on the basis of the monthly charges of the customer, right? So I've done this, and the rest of the process would be the same over here. I'll go ahead and divide this data frame into train and test. Right, so this is 65-35 ratio this time. So I'll set it to be 35. So this time 35% of the records would be present in the test set, and the rest 65% of the records would be present in the train set. And I'm storing all of those into xtrain, xtest, ytrain, and ytest. Right. After this, I'd have to import the logistic regression model. So from sklearn dot linear model, I'd have to import the logistic regression model, and I'd have to create an instance of this. So I'll name this to be equal to log model. Alright, so I have created an instance of this, and I'll go ahead and fit the model on top of the training set. Right, the entire process when it comes to implementing this is pretty much the same, right? So Python makes it extremely easy. The sklearn library makes it extremely easy. All you have to do is take in the data, find out your independent variables and your dependent variable, and then go ahead and divide those target and features into training and testing set, build the model on top of the train set, and then break the values on top of the test set, and then you will find out the metrics. So for classification, it's confusion metrics and your normal accuracy score, and for linear regression, it could be either root mean square error, mean square error, or moving averages error. So log model dot fit, and I will fit this model on top of the training set again. So xtrain and ytrain, right? So I have fit the model. Yes, we can also have multiple independent variables, Sharadata. So again, so if we have a single independent variable, then that's that's a simple model. So when it comes to simple linear regression, we have a single independent variable. When it comes to multiple linear regression, you'll have multiple independent variables. Right. So this basically means that we are trying to understand how does our dependent variable change with respect to multiple independent variables over there. And so again, consider this equation. So linear regression equation is based on this. Let me actually open Notepad over here, right? So y equals, let's say, x1 plus x2 plus x3 plus x4. So what happens in a simple linear regression is you just have one independent variable, which would be x1. What happens in multiple linear regression is you have multiple independent variables, which are x2, x3, x4, and so on. Right? And you're trying to understand how does y vary with respect to all of these independent variables. That's pretty much it. Right, so let's proceed with this. We have built the model on top of the training set. Now let's go ahead and predict the values on top of the test set. So it'll be log model dot predict. So here we change the value of x, and no, we are not changing the value of x. We have multiple x values over here, right? So this becomes mx1 plus m2x2 plus m3x3 plus m4x4 and so on. We have multiple independent variables, and you are trying to understand how does y vary with those multiple independent variables. So log model dot predict, and I want to predict my values on top of the test set, and I'll store this in again ypred. Right. So we have predicted the values now. Right. So when it comes to a classification model, we can use the confusion metrics. Right. So let me import the confusion metrics. So from sklearn.metrics, I will import the confusion metrics, also the accuracy score. Now let me find out both of this. I'll pass in the actual values and the predicted values. Actual values are present in ytest and predicted values are present in ypred. Similarly, accuracy score, I'll do the same thing. Ytest and ypred. Right, so this is our confusion matrix and this is the accuracy, right? So to get the accuracy, what you'll basically do is you'll divide the left diagonal with all of the values. So left diagonal represents all of your correctly predicted classifications. So this comprises of all of your true positives, right? So this part over here, this is all of your true positives and this is all of your true negatives, right? So when you divide this with the entire sample space, that is when you will get the accuracy. So let me do that. So that'll be 1815 divided by 1815 plus 651, and I get the same accuracy, which is 73.60, right? So I get an accuracy of 73% for the model which I've built. Now I'd have to build a multiple logistic regression model, or the dependent variable is the same and the independent variables are tenure and monthly charges. So now we have two independent variables, so I'll make the changes here itself, right? So Charada, the question which you're asking, what if we had multiple independent variables, right? So over here we have two independent variables. So this time the independent variables are monthly charges and tenure, and I'm trying to understand whether the customer would churn or not on the basis of these two columns, which are monthly charges and tenure, right? So X now would comprise of these features and Y is the same, and the ratio is 80-20. So I'll change the test size to be equal to 20 over here. I'll go ahead and fit the model. It's the same. Again, I'll predict the values is the same, right? So I build the model, I predicted the values. The only difference which I made over here is I have two independent variables this time instead of a single independent variable, right? Predicting the values. After that, I'll import confusion metrics and accuracy score, right? Now over here, again, I'm calculating the confusion metrics and this time I get an accuracy of 77.50, right? So this time it'll be 935 plus 157 divided by 935 plus 157 plus 106 plus 211. Right, so we get an accuracy of 77.50. So this left diagonal are all of the values which have been correctly classified, and this right diagonal represents all of those values which have been misclassified. So this was logistic regression, and then we've got two more machine learning algorithms left, which are decision tree and random forest. So let's build these two. Right, so for decision tree, dependent variable is the same, which is churn, and independent variable is tenure. Right, so let me manually do this. X is customer churn, and the independent variable is tenure. Let me also extract the dependent variable. So the dependent variable would be churn. You have to make sure that you put in the spellings correct, and also you have to take care of the small caps and the capital letters over here. Right, now I will go ahead and also import the decision tree classifier. So from sklearn.tree, I'll be importing the decision tree classifier. Now I'll go ahead and divide this data frame into train and test. So it'll be the same process. Let me copy this. Let me paste it over here. So the split is 80-20, which is what we are doing over here, right? So this is our feature, this is our target labels, and we have divided the dataset into training and testing set. Now let me go ahead and create an instance of this decision tree classifier. I'll name this instance to be, let's say, my tree. Right. And I'll go ahead and fit the model on top of the training set. So my tree.fit, this takes in two parameters, which are xtrain and ytrain. I fit the model. Now it's time to predict the values. My tree.predict, and I'll be predicting on top of the X test. Now I'll import the metrics, right? So let me calculate the confusion metrics and also the accuracy score. Confusion metrics. So I'll actually have to store this in a object first. Again, I'll be storing this into ypred. Let me run the cell again. And this again takes in two parameters. First parameter is all of the actual values which are present in ytest, and all of the predicted values which are present in ypred. So this is our confusion matrix now. Let me calculate the accuracy, which would be 965 plus 87 divided by 965 plus 87 plus 281 plus 76. Right, so for this decision tree model, we get an accuracy of 74%. Right, so the process is entirely the same, guys. Right, what we are doing is, again, at the risk of being redundant, so what we are basically doing is finding out our features and target variable. After that, we are dividing the features and target into training and testing split, and then we'll go ahead and build the model on top of the trained data, and then we'll predict the values on top of the test data. Once the prediction is done, we'll calculate the accuracy to find out how well our model has learned. Right, so in the entire data science life cycle, our most important part is the data processing part. Right, so because to the model building the, so it depends on your problem statement, Aditya. Right, so let's say if your dependence on your it depends on your problem statement and what exactly you're trying to find out. So let's say if your dependent variable is a continuous, if it's a continuous variable, if it's a continuous numerical, then you'll go with linear regression. And if you want, if you have multiple categories, right? So if you have multiple categories, then you'll go with either decision tree or random forest. So when it comes to logistic regression, it is a binary classifier. So let's say if you have just two labels in your dependent variable, like this case over here, right? So this is where you'll go with logistic regression. But then again, if you have multiple categories, or if it's a multi-classification problem, then you'll most probably go with decision tree and random forest. And again, when you compare decision tree and random forest is always better than decision tree, because random forest is an ensemble model. So again, through your course, you would have learned that a random forest is nothing but an ensemble of decision trees, and the accuracy or the prediction given by a random forest is better than a decision tree. So that you can actually take for granted, right? So whatever accuracy a decision tree gives, the accuracy given by a random forest is better. So just to verify that, let me actually go ahead and build a random forest model on this same data over here, right? So we'll take the same X and Y values.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
No, so again, problem statement was different, Aditya. So linear regression we use to understand how does monthly charges vary with tenure. But the other algorithms which we've built, that was to understand how does churn vary with other factors, right? So over there, monthly charges was a numerical column, but churn is a categorical column. So we can compare logistic regression and decision tree, right? So let's say if we compare logistic regression and decision tree, right? So logistic regression gives us an accuracy of 77%. Yes, right. So logistic regression till now, yes, has given us the best accuracy, right? Right. So now finally we'll also go ahead and build an ensemble model, which is random forest. So let's actually compare the accuracy given by this decision tree and the random forest. So from sklearn.ensemble, I'll import the random forest classifier and I'll create an instance of this. Maybe I'll name this as RF and I'll just create an instance. Right. And I'll go ahead and with the model on top of X train and Y train. X train and Y train I fit the model. Now it's finally time to predict the value. So rf dot predict, and I am predicting the values on top of the X test. Let me build the confusion matrix over here. Right, now let me check the accuracy. So I'll just type in accuracy score and I'll pass in y test and y pred. Y test, y pred. So we get an accuracy of 74.66 and it's 74.66, right? So there's not much of a difference when you compare decision tree and random forest over here, right? So we've got the same values, right? But normally in general, if you're building a random forest model, so you'll either get a better accuracy or you'll get the same accuracy, right? So this is your normal entire data science life cycle. You'll start off with the data pre-processing part, data exploration part, where you will understand the structure of the data set. You'll visualize the data set and understand whatever is happening underneath it. Right after that, once you understand and comprehend your data properly, that is when you'll go ahead and build your model. Again, when it comes to building your model, you will sort of follow the same procedure. You'll find out your independent variables and the dependent variable. Then you'll go ahead and divide those two into your training and testing set. You'll build the model on top of the training set.
Now let's actually start off by having a glance at the job trends of different programming languages. So here we are comparing Python, R, Angular, and C. And it's very obvious that Python is the most preferred language across various industries. So you see this blue color line over here. So this blue colored line is for the Python programming language. And if you closely observe this blue colored line, you will observe that the popularity of Python has been steadily increasing over the years. So now that we know how popular Python is, let's head on to our interview questions. Right, so this is our first question. What are keywords in Python? So you can consider these keywords to be special reserved words which exist for a specific purpose. Now you cannot use a keyword name as a variable name or an identifier. So these are some of the keywords which exist in Python, such as true, false, not, continue, and so on. And in total, there are 33 keywords in Python 3.7. Now you also need to keep in mind that these keywords are case sensitive. That is, if you look at the keyword true over here, then you see that T needs to be capital. So our next question is, what are literals in Python? And then we'll have to explain about the different types of literals. So literals are the constants used in Python. Or in other words, this is the data which is stored in a variable. And there are 4 types of literals in Python. So we have string literals, numeric literals, boolean literals, and special literals. So let's look at string literals. So you can create string literals by just enclosing the text within quotes. So here we have created 2 string literals, John and James. So we see that John is enclosed double quotes and James is enclosed within single quote. So this is how you can create string literals. Next up, we have numeric literals. So numeric literals comprise of all of your digits. Now if your numeric literal doesn't contain any decimal, then it is of the integer type. And if your integer is too long, then it will be of the long type. And if your literal consists of a decimal point, then it would be a float. And finally, we have a complex number which consists of a real part and an imaginary part. Going ahead, we have Boolean literals. So these Boolean literals comprise of just true and false values. They are generally used when we are dealing with some condition whose output is either true or false. Now we'll head on to special literal. So Python consists of this special literal called as none, and it is used to specify a field that is not created. Here in this example, I have assigned none to the variable val2. So this variable would basically be empty. So this is our third question. What is a dictionary in Python? And we'd also have to create a dictionary where the key is fruit name and there are 4 fruit names as values. So a dictionary is an unordered collection of elements, and these elements in a dictionary are stored as key value pairs. For example, here we have a dictionary with the name my dictionary, and we have 3 key value pairs. So here our first key is 1 and the value for this key is John. Second key is 2 and the value for this key is Bob. And then we have the final key, which is 3, and the value for this is Alice. Right, now let's head on to Jupyter Notebook and create our own dictionary where the key is fruit name and the values would be 4 fruit names. So I'll name the dictionary as my dictionary, and we can create a dictionary with the help of these curly braces over here. So I'll give in the key name, which would be fruit name, and after this I'd have to give in values of 4 fruit names. So let's say my first fruit is apple, and then the second fruit is mango, third fruit would be orange, and the fourth fruit would be guava. Now all I have to do is hit on run, and then let me print this out. So I'll just type in my dictionary over here. Right, so we have created a dictionary with the name my dictionary where the key is fruit name and the values are apple, mango, orange and guava. And if you want to extract the individual key and individual values, this is how we can do it. Now I'll type in the name of the dictionary, which is my dictionary. I'll put in dot and then I'll just type in keys. I'll click on run, and we see that the key for this dictionary is fruit name. Similarly, if I want all of the values, I just have to type in values over here. Now let me click on run. So for this dictionary, the values are apple, mango, orange and guava. So our next question, what are classes and objects in Python? So simply put, you can consider a class to be a blueprint and objects to be real world entities which are defined and created from classes. For example, over here you can see the actual blueprint of a house. Now, this blueprint can be used for the rapid creation of unlimited number of copies. So these copies of the blueprint are nothing but your objects. And here we have created 3 houses, or in other words, 3 objects from the original blueprint, which is our class. So I'm repeating it. So our class is nothing but a blueprint, and from this blueprint, we'll be creating a set of objects which are our real world entities. So over here, this house number 1, house number 2 and house number 3 are our real world entities which are nothing but objects created from this class. Next, we'd have to create a simple class with the name human, which would give out the name and age of the person. So let's do this. Right, so to create a class, I'd have to use the keyword class, and then I will give in the name of the class, which would be human. Now inside this, I will create 2 variables. So the first variable would be name, and initially I'll just assign none to it. And my second variable would be age. Again, I'll assign none to it. So we have created our variables. Now we'd have to get the value of name and the value of age from the user. So for this, I'd have to create some definitions or methods. And to create a definition, I'll use def. After this, I will give in the name of the method, which would be getName. And inside this, I will pass in self. Alright. So now over here, I'll just use the print function and type in enter your name. And after this, I will get the name and the self.name. So basically self.name basically means that whatever value the user enters, it would be stored in this name variable of the object. Right. And I'll just type in input over here. So this input function is used so that we can get a value from the keyboard. Right. So this is how we can get the name of the person. Now similarly, let's go ahead and get the age of the person. So I'll type in def and I'll name this method to be get age. Again, I'll pass in self inside this. Right. This time I'll use print and I'd have to enter the age. So enter your age, and then I'll store this in self dot age equals input again. Right. So we have created two get methods where we'll be getting the name and the age of the user. Now after this, we'd have to print out the name and the age. So it'll be def, and I'll create the method to be put name. Again, this will be self, and I'll just print out the user's name. So your name is self dot name, and then similarly I'll create another method which would be put age, and I'll pass in self inside this. So for this, it would be print of your age is. Let me again put in double quotes over here. Right. So your age is, it would be self dot age. So we have created our class where we have two variables, name and age, and I've created 4 methods. And out of those, from those 2 methods, I'll be getting the name and age of the person, and the rest of the 2 methods would help me to print the name and age of the person. Right. I'll click on run. So we have created this class. Now once we create our class, which is basically our blueprint, we'd have to create the objects from this class. So let's say I create an object and name that object to be person1. Now this would be our first instance, and I just have to call in human. So I'm creating a person instance of the human class. Now from this person object, I will invoke the get name and get age methods. So person1 dot get name. Let me click on run. I'd have to enter the name of the person. Let's say the name of the person is Sam. Right. So now it's time to get the age of the person. So I'll type in person1 dot get age. I'll click on run. And let's say the age of the person is 28. So now I have successfully fed in the name of the person and the age of the person. Now it's time to print out both of those. So it'll be person1 dot put age and person1 dot put name. So person1 dot put name. Right. So your age is 28 and your name is Sam. Right. So we have successfully created our class which would print out the name of the person and the age of the person. Right. So next question. What do you understand by the init method in Python? And after that, we'd have to give an example of it. So you can just consider the init method to be a sort of constructor in Python. So it is a special method in a Python class which is used to initialize the variables. So now that we've understood what init method is and what it is used for, let's go ahead and work with this init method. So now over here, what I'm going to do is create a student class with the init method in it. So let me do that. Class student, and over here, I'll just create the init method, and these are the parameters of this init method self. So, and after this, it'll take in the name of the person, and after name, it'll take in the age of the person, and after this, it'll take in the branch of the person. Right. Now, what I have to do is just store these values inside the original variables. So that'll be self.name equals name, and then our next variable is age. So self.age equals age, and then we have the final variable which is branch. So it would be self.branch equals branch. So we have created our init method. Now after this, wait, so we actually have to put in def over here because this is actually a method. Right. So we have created our init method, which is basically a constructor. And going ahead, we'll just create another method which would help us to print all of these values. Def print student, and I'll take in self, and all I do over here is print in all of these values. So print of name would be self.name. After this, we have age. So let me change this to be age over here. And this would be self.age. After this, we'll have to print in the branch. So let me just put in branch over here, and this would be self dot branch, right? So we have created the student class which has the constructor. I'll click on run. Now let me create an object of the student class. I'll name the object to be student1, and let me go ahead and create an instance of this. Now, since we have this constructor over here, so I can go ahead and initialize the student object here itself. So I'll give in the name of the student. So let's say the name of the student is Bob. After this, the age of the student is 12. And then which branch is he studying? So let's say this guy is studying engineering. Let me just put in engineering over here. Run. Now student1 dot, I will call in the print student method over here. Right, so we have successfully created this instance student1. Right, so what do you understand by inheritance in Python? And then we'd have to give an example of it. So inheritance refers to the property of one class acquiring the properties of another class. For example, let's say you have inherited your features or properties from your parents. So if you see over this family tree over here, you can understand that traits such as hair color and poor eyesight are passed from one generation to the next generation. So over here, this is generation 1, generation 2 and grandparents. So your parents are inheriting their traits or their features from their grandparents, and you are inheriting your traits from your parents. Now let's go ahead to Jupyter Notebook and work with an example of inheritance. So here what we are doing is we have a base class with the name fruit, and this base class is being inherited by another class, citrus. Now this is our base class fruit, which has a constructor, and this constructor just prints out I am a fruit. Now after this, what we are doing is we are creating another class with the name citrus, and this class inherits from the fruit class, right? So if a class has to inherit another class in Python, we'll just give the name of the base class as a parenthesis inside our new class. Now again, inside the citrus class, we have created another constructor, and inside the constructor of the citrus class, I am using the super method. So with the help of super method, I can invoke the variables and functions from my super class, right? So over here, I want the init method from my super class. So I'll just use the super method, and I'm invoking the init method from this fruit class. Now, apart from this init method from the fruit class, I would also print something else. So over here, I am also printing I'm citrus over here, right? And I'll create an instance of this class citrus, and I'll store it as lemon. Now the result is I'm a fruit, I'm citrus. So this value I'm a fruit is coming from the super class, and this value I'm citrus is coming from our new class or the child class. So this is how we can do single level inheritance in Python. So next, so what is NumPy and how can you create a basic 1D and 2D NumPy array? Well, NumPy is the most widely used Python library for linear algebra, and it is used for performing mathematical and logical operations on arrays. And to import the NumPy library in Python, you just have to use the command import NumPy. So again, let's head to Jupyter Notebook and create a 1D NumPy array and a 2D NumPy array. So I'll start off by typing import NumPy as NP. After this, I'll create my 1D NumPy array. So A equals NP dot array. Now I will give in a list of values. So this is my 1D array A, and then let me just print it out. So this is my 1D array which comprises of the values 1, 2 and 3. Now I'll go ahead and create a 2D array with the name B. So again, the syntax would be the same, np dot array. So it'll basically comprise of a list of lists. So the first list would comprise of 1, 2 and 3. And the second list would comprise of 4, 5 and 6. Let me print this out. Right, so this is our 2D array which comprises of 1, 2, 3, 4, 5 and 6. So this time we'd have to initialize a 5 cross 5 NumPy array comprising of all the zeros. So it's a 5 cross 5 NumPy array, that is there need to be 5 rows, 5 columns and all of the values need to be 0. And to initialize an array with all zeros, we can just use np.zeros method from the NumPy library. Let me just type in import numpy as np, and inside a, I'll just state np dot zeros, and I'd have to give in the dimensions of this array. So the dimensions of this array are 5 cross 5. Let me just print out a. So we have successfully created our 5 cross 5 numpy array where all of the values are just zeros. Now let's say we have two numpy arrays like this. So this is our first numpy array, this is our second numpy array. First numpy array comprised of 1, 2 and 3. Second numpy array comprised of 4, 5 and 6. Now I'd have to add the individual elements. So 4 plus 1 needs to become 5, 5 plus 2 needs to become 7, and 6 plus 3 needs to become 9. Again, our first step would be very simple. I'd have to load the numpy library, import numpy as np. I will go ahead and create my first numpy array, a equals np dot array. And the values are 1, 2 and 3. Similarly, I'll create my second numpy array, which is b. I'll change this variable to be equal to b, and the values are 4, 5 and 6. Now, to add the individual elements, I'd have to use the np.sum method. Now inside this, I'd have to give in my first parameter. So my first parameter would be the numpy arrays which I'd have to add. So I want to add a and b, and I will set the axis to be equal to 0. So when I set the axis value to be equal to 0, this would individually add the elements. So this will do 4 plus 1, 5 plus 2 and 6 plus 3. Right, and this is what we have. 4 plus 1 is 5, 5 plus 2 is 7 and 6 plus 3 is 9. Now let me actually change the axis value to be 1 and let's see what do we get. Right, so when I change the axis value to be 1, then the addition happens across the row. So when you do 3 plus 2 plus 1, you get 6, and when you do 6 plus 4 plus 5, you get 15. So now we'd have to get the n largest values from a numpy array. So this is our numpy array over here. And this comprises of 1, 2, 3, 4, 5, 6, 7 elements, 12, 43, 200, 54, 5 and 68. And I'd have to get the first two largest values, which over here are 100 and 68. Now let's go to Jupyter Notebook and let's see how can we do this. Right, so again, we'll start off by importing the numpy array, import numpy as np, and I'll create this array. X is equal to np.array, and I'll give in all of these values. Now to get the indices of values which are arranged in ascending order, we can use the np.argsort function. Now what I'll do is I'll actually insert a cell below, and I'll go ahead, I'll do Control X, I'll do Control V. So we have successfully created our numpy array. Let me just print in X over here. So this is our numpy array. Now what I'll do is I'll just copy this np.argsort of X, and I will print it over here, and let's see what do we get. So what we get over here are index values. So 0, 1, 2, right? 0, 1, 2, this is our lowest value. And then we have 5, so element at index number 5. 0, 1, 2, 3, 4, 5, right? 2, 5, and then we have 0, which is 12, and then we have 43, right? So we basically have the indices of the values arranged in ascending order. So 2, 5, 12, 43, 54, 68 and 100. So this is how it goes. Now if I want the indices of the first two highest values, then I'll just put in -2 colon over here, and I have 6 and 3, right? 0, 1, 2, 3, 4, 5, 6. So 68 is the second highest value, and then we have 3, 0, 1, 2, 3, right? So 100 is the first highest value. Now what I want to do is I want to arrange this in descending order. So to arrange this in descending order, again, I'll put in braces over here, I'll put double colon, and I'll put in -1 over here, and I have sorted the indices in descending order. Now if I take all of this, I'll cut this and I will paste this inside of X. I'll click on run, and this is how I get the first two highest values from this numpy array. So 168 are the two highest values from this numpy array. So now we'll have to give some examples for creating a data frame from list and dictionary. So this is a very common and easy question which is asked in most of the Python interviews, right? So first we'd have to go ahead and create a list, and we'd have to convert that list into a data frame. Similarly, we'd have to create a simple dictionary and convert that dictionary into a data frame. So I'll type in import pandas as pd. So I'd have to start off by importing the pandas library. Now I will go ahead and create a list. So I'll name this list to be equal to L1. So L1 equals 1, 2, 3, 4, 5. So we have created our list. Now to convert this list into a data frame, all I have to do is use pd.dataframe function. So over here we need to keep in mind that D is capital, right? pd.dataframe, and I will pass in L1 inside this, and I will store this in, let's say, data1, and I'll just print out data1 over here. So we have successfully created a data frame from a list where the list values are 1, 2, 3, 4, and 5. Now similarly, we'll create a dictionary and create a data frame out of that dictionary. So I will name this dictionary to be dt1, and the key is fruit name, and the values are apple, mango, and let's say orange. After this, we'd have to create our second key value pair. So our second key value pair would be count, and the values would be, let's say, 12, 24, and 36. Right. So we have created this dictionary. Now again, to convert this dictionary into a data frame, we'd have to use pd.dataframe, and I will pass in dt1 inside this. Right, so we have created this data frame where our first column is fruit name and the second column is count, and fruit name comprises of apple, mango, and orange, and the count of the fruits is 12, 24, and 36. So now we have this iris dataset which comprises of all of these columns. So we have sepal length, sepal width, and species. Now out of this, we'd have to extract some specified rows based on a condition. So we'd have to extract only those records where the sepal length value is greater than 5 and the sepal width value is greater than 3. So I'll start off by loading the pandas library, import pandas as pd, and after this, to load a CSV file, I'd have to use the pd.readcsv function, and I'll give in the name of the file. So the name of the file would be iris.csv, and I'll just store this in a new object and name that object to be equal to iris. Now let me have a glance at the head of this data set. Iris.head. So this will give me a list of the first few records, right? Sepal length, sepal width, petal width, and species. Now let's see how can we extract only those records where sepal length is greater than 5 and sepal width is greater than 3. Right. So I'll start off by giving the name of the data frame, and I'll put in these braces over here, and I'll give in the first condition. So the first condition is again iris, and from this I'd have to select only those sepal length columns where it is greater than 5. So sepal dot length, this value needs to be greater than 5. So I've given my first condition. After this, I'll go ahead and give my second condition. And this time I'd have to extract only those records where sepal.width. Let me type this out. And this needs to be greater than 3. Now let me also put this inside these braces over here. Let me cut this and let me paste it over here. I'll click on run. Right, so this is our list of values where sepal length is greater than 5 and sepal width is greater than 3. If I scroll down, you'll see only those values where sepal length is greater than 5 and sepal width is greater than 3. So what we do is, we give in the first condition where sepal length is greater than 5. After that, we'll use the AND operator, and then we give the second condition, which is sepal width is greater than 3. Right, so after this, we again have this iris data frame over here, and we'd have to introduce NaN values or null values in the first 10 rows of sepal width column and petal width columns. So if you see this original data frame over here, you see that these two columns comprise of some values. But then again, we'd have to fill the first 10 rows of these two columns with NaN values. So I'll start off by loading the required packages, which would be pandas and numpy. So import pandas as pd and import numpy as np. After this, I'll load the iris dataset. So iris equal to pd.readcsv, and I will
pass in the name of the dataset, which is iris.csv. Let me again have a glance at the head of this dataset. So iris.head. Right. So now to introduce NaN values, I can use the np.nan method. So now what I'll do is I'll actually create a duplicate copy of this object. So iris1, and I will store this data frame into iris1. Now I'll type in iris.ilock, and I would want to make changes in the first 10 rows and the second column and the second column, right? So first 10 rows and the second column. So the index of the second column would be 1. And what I'll do is I will introduce all of the NaN values. So np.nan, let me put an equal to over here. Now let me have a glance at the head of this modified data set. So iris1.head, right? So we see that this is our original data frame, and with the help of np.nan, I have introduced NA values from actually the first row. So let me actually change this to be 0 over here. I'll click on run. So now I have NA values for the first 10 records. Similarly, I'll also go ahead and introduce NA values in the petal length column. So over here, I just have to change the index of the column, which would be 2. Let me have a glance at the head, iris.head. Right, so now we'd have to get the number of NaN values present in each column of this enhanced data frame. So this is our data frame over here, which comprises of these columns. So we have age, BMI, HYP, and CHL. And we see that these 3 columns over here comprise of NaN values. And we'd have to find the count of the NaN values present in each of these columns. So I'll start off by loading the pandas data frame. I'll type in import pandas as PD. Let me just wait till the package is loaded. Right, so now that we've loaded the package, I'd have to load the CSV file, which is enhance.csv. And for this, I'll be using pd.readCSV function. And I'll give in the name of the file, which is enhance.csv. And I'll store this in a new object and name that object to be enhance. Now, if I want to get the count of number of NaN values, this is what I'd have to do. Enhance dot, so I have this NA function, and after this I will just print it out. Let's see what do we get, right? So we just get a bunch of true or false labels.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
So wherever there is an NaN value present, we have a true label. So over here in the BMI column, the first record, this is an NaN value. This again is an NaN value. So wherever you see true values, it basically represents all those NaN values. And if I want the sum of all of these NaN values, I just have to type in sum, and now I click on run. Right? So we see that age column has no NaN values, BMI column has 9 NaN values, HYP column has 8 NaN values, and CHL column has 10 NaN values. Now we'd have to open and read a file in Python. So let's see how can we do that. So I actually have this file with the name Sparta, and it is present in my D drive. So let me actually copy the path over here. Right, so this is just the path which I have to copy. So first, to open a file in Python, I'd have to use the open function. So I'll just type in f equals open, and this takes in 2 parameters. The first parameter is just the path. And after the path, I'll give in the name of the file, which would be sparta.txt. And the second parameter is the mode which I want to open this file. So I want to open this file in the read mode. So again, I'll just give in double quotes and I'll type in R. So R basically means that I am opening this file in the read mode and I'm storing this in this object F. Now let me go ahead and read this. So F dot read. Right, so this is the sentence which was stored in this file. This is Sparta, and we have successfully read the sentence. So let's head to the next question. So what is a lambda function? And we'd have to create a simple lambda function to add 10 to a given number. Well, a lambda function is an anonymous function. and it can take any number of arguments, but it should have only one expression. And this is the syntax of a lambda function. So you'll type in lambda and then you'll give in all of your arguments. After that, you'll put in a colon and then you'll give the expression. So let's go ahead to Jupyter Notebook and create a simple lambda function to add 10 to a given number. Right, so let me just type in lambda and I'll give the name of the variable to be a. I'll give a colon and all I have to do is add 10 to whatever variable is sent into this. And I am naming the function to be, let's say, x. So this is how we can create a simple lambda function. Now I'll call the function and pass in a number. So let's say I'll pass in 8. Now this is returning 18. So all I'm doing is adding 10 to the number which I'm passing into this. Now again, let's say if I pass 5 into this, I'll get 15. Similarly, let's say if I pass 100, I'll get 110. So we have successfully created a lambda function which takes in a parameter and adds 10 to the given parameter. So now we'd have to create a simple line plot like this, where x and y axis values range from 0 to 10, and the title of the plot is y versus x label is x axis, y label is y axis. So a simple line plot, and we can create this line plot with the help of the matplotlib package. So let's quickly head on to Jupyter Notebook. I'll start off by loading the required packages. So I would need the numpy package. So I'll type in import numpy as np, and I would also need the matplotlib package. So I'll type in from matplotlib import pyplot as plt. Alright, so now that we've loaded the required packages, let's go ahead and create our data. So our x-axis and y-axis values range from 0 to 10. So I will name x and I'll get the values with the help of np.aRange. And since the values go from 0 to 10, 0, 10, and the step factor is 1. So let me just print out x over here and let's see what do we get. Right, so these are all of the values which I have over here. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, now similarly, let me also go ahead and create the y values. It'll be the same thing over here. It's just that instead of storing the values in x, I'll be storing them in y. So I have my x and y values to be ready. All I have to do is use these data points and create the line plot. So plt.plot, and I'll pass in x, y, and this is my plot over here. Now I'll also go ahead and add the labels for x-axis, y-axis, and I'll also give in the title plt.x label. So the label would be x-axis, similarly plt.y label, and the label would be y-axis for this. After this, I'd have to give in the title. So the title would be plt.title and x versus y. Right, so we have created our line plot where the label of x-axis is x-axis, the label of y-axis is y-axis, and the title of the plot is x versus y. So it's as simple as that, guys. So this is how you can create a simple line plot with the help of the matplotlib package. So now we'd have to create a simple bar plot. And we have these fruits over here represented on the x-axis. So we've got apple, banana, and orange, and we've got the cost of the fruits on the y-axis. So let me start off by loading the required library. From matplotlib, I'll be importing pyplot as plt. After this, I just have to create my data. So I'll be creating a simple dictionary over here, and I'll name this dictionary as data. I'll put in braces over here, and it consists of 3 fruits, which are apple, banana, and orange. So apple, and cost of apple would be, let's say, $50. After that, we have banana, and the cost of banana is 20. After that, we have orange, and the cost of orange is 30. Right. So now I'll separate the keys and values from this. So let me get the keys first, data.keys, and I'll get the list of this. I'll paste this inside this, and let's say I'll store this in an object named as names. Now let me get all of the values similarly. Values, and I'll be getting data.values. So I have the names, I have the values. Now all I have to do is make a bar plot. And to make a bar plot, I'll be using plt.bar, and I'd have to pass in the names as well as the values. Right, so we have successfully created a bar plot, and on the x-axis we have the names, and on the y-axis we have the cost. Next question. So what do you understand by a module in Python? So when we write everything in a single page, it becomes difficult to track. And not just this, let's say if you want to make a change at a certain place in the project, then it would affect the entire project and may prove to be disastrous. And this is where we'll be using the concept of modules. So instead of writing one big software in one page, we would have to break it down into parts. So a module basically helps us to organize our Python code. Now let's say you want to write a program to create a calculator. Now instead of writing all of the features in the same file, you can create separate modules for addition, subtraction, multiplication, and division. Now if you want to perform addition, you can invoke the addition module. Similarly, if you want to perform multiplication, you can invoke the multiplication module. So for every single purpose, you can have a separate module so that your work becomes easier. So now we'd have to randomize the items of a list in place in Python. So let's say we have a list which comprises of these elements. So let's say the first element is Mary, and then we have had a little lamb. Now I'd have to randomly shuffle all of these elements inside the list. And to randomize the items of a list, we can use the shuffle function. And the shuffle function is part of the random library. So I'll type in from random import shuffle. So I have loaded the function. Now let me go ahead and create the list. Mary had a little lamb. Right. Now I will just pass in this inside the shuffle function. Now let me print in X. Right. So this is in place shuffling inside the list, right? So initially the list was Mary had a little lamb, or the sequence of the elements inside this list was Mary had a little lamb. And after passing this list inside the shuffle function, the elements changed and the sequence now is a lamb Mary had little. So now we'd have to write a program to get the length of the string ophthalmology without using the len function. And to get the length of the string, we can just use the for loop. So what we'll do is we'll start a for loop and it will iterate through all of the characters in this string, and we'll get the count of the number of characters present in the string. So let me name the string. So it is OPHTHALMOLOGY. So let's hope this is actually the spelling of ophthalmology. Right, now let me initialize a counter and set the value of counter to be equal to 0. After this, I'll start the for loop. So for I in A, what would basically happen is count equals count plus 1, and finally I'll print out the value of count. So what is happening over here is initially i's value is 0 and it will loop through all of the characters of the string which is present in A. And so let's say the loop starts over here. Initially i's value is 0 and it will enter O. Now the count increments by 1. Again it will head to the next character, the count again would increment by 1. It will head to the next character and the count would increment by 1. So till the end of the string it will keep counting the number of characters present. Right, and we get the result. So the number of characters present in the string is 13. So now we'd have to replace all the odd numbers in this numpy array to -1, right? So this is our numpy array which comprises of the numbers from 0 to 9, and we'd have to replace all of the odd numbers. So 1 would become -1, 3 would become -1, 5 would become -1. So wherever odd numbers are present, all of those odd numbers would become -1. Let me load the numpy library, import numpy as np. After this, what I have to do is create my numpy array. So arr equals np.arange, and it will go from 0 to 10. Let me just print out this numpy array over here. This is my numpy array. Now let me go ahead and replace all of the odd values with -1. So what I'll do is I will basically divide each element with 2 and see what is the remainder. So ARR percentage 2, and if it is equal to 1. So what I'll do is I will divide 0 with 2, I'll check the remainder. Similarly, I'll divide 1 with 2 and I'll check the remainder. I'll divide 2 with 2 and I'll check the remainder. So wherever the remainder is equal to 1, those elements I'll be changing it to equal to -1, right? So first I'll divide 0 with 2 and I'll check what is the remainder. And since the remainder is not equal to 1, nothing will happen. After this, I'll divide 1 with 2 and I'll check the remainder. So if the remainder is equal to 1, I'll replace this with -1. Similarly over here, if I divide 3 with 2, the remainder which I'll be getting is 1. And again, this value would be replaced with -1. Right, so the changes have been done. Now let me print this. This was my original array. After performing this step over here, all of the odd values have been replaced with -1. 1 has been replaced with -1, 3 with -1, 5 with -1, 7 with -1, and 9 with -1. Now we'd have to perform an operation so that we get the common items between two NumPy arrays. This is our first NumPy array. This is our second NumPy array. Now let's actually check the common items. So if we look closely at these two arrays, we see that 2 and 4 are the only two common items present among these two arrays, and I'd want to extract these two. Right, so we have created our arrays over here. This is the first NumPy array and I'm storing it in A. This is my second NumPy array and I'm storing it in B. Now to get the common elements, I have the np.intersect1d method. So np.intersect1d, and I just have to pass in the two NumPy arrays inside this as the parameters. So A, comma B, I'll pass in these two, I'll click on run. Right, so I've got the common elements present in these two arrays. Right, so we have a pandas series over here and we'd have to convert each of these elements into title case. So Mary had a little lamb. So we see that all of this are in small cases. Now I'd have to convert all of these elements into title case. So let me start off by loading the pandas library. Import pandas as PD. Now I'll create the series pd.series and I'll pass in the values which are basically Mary had little lamb. Right, so this is done and I'll store this in, let's say, ser. So I have created my series. I'll just print it out now. Right, so this is my pandas series. Now I'd have to convert all of these elements into title case. That is, M needs to be capital, H needs to be capital, A, L and L needs to be capital. Right. And as I've already told you, we'll be using the map method, which helps us to replace or substitute values or all of the values inside a pandas series. So ser.map. Now inside this, I'll use a lambda function to convert all of these elements into title case. So let me type in lambda over here, x, colon, and I just have to convert this into title case. So let me just put in title over here. Now let me click on run. Right, so we have successfully converted all of these elements into title case. Now let me store it back to ser. Now let me print ser over here. Right, so all of these elements have been converted into title case. So now we have the same pandas series. So Mary had a little lamb. Now I'd have to calculate the number of characters in each word of the series. So this is 1, 2, 3 and 4. So there are 4 characters present in the word Mary. There are 3 characters present in the word had. This is a single character, right? So we'd have to find out the total number of characters present in each words or each of these elements inside this pandas series. Import pandas as PD. Let me again create the series ser equals pd.series and I'll give in all of the elements. Mary had a little lamb. So now to get the length of each of these words present in this pandas series, I'll have to use the map method. So ser.map, and inside this I'll again create a new lambda function lam bda a colon, and since I have to get the length, I'll use the length function, and I have to get the length of each of these elements inside A. Right, so we see that the length of the word Mary is of 4 characters. In hat there are 3 characters, A is a single character, and in little there are 6 characters, and in the word lamb there are 4 characters. Time for next question. So again we have this iris data frame, and we'd have to change the column name sepal length to s_length. Let me load the package, import pandas as pd, and I'll also load the file. So pd.read csv, and the name of the file is iris.csv, and I'll store it back into iris. Let me have a glance at the head of this data frame. So it'll be iris.head. So we have all of these columns over here, and I'd have to change the name of the sepal.length column to s_length. So to rename the columns of a data frame, I have the pandas.rename method. So first I'd have to give in the name of the data frame, which is iris, and then I will invoke the rename method. Now I'd have to give in all of the column names which I'd want to change. So I'll type in columns over here, I'll create a dictionary, and my key would be the name of the column which I'd want to change. So I would want to change the name sepal length to be equal to s_length. So it'll be s_length. So this is how it goes. So iris.rename, and the original column name is sepal.length, and I'd have to change it to s_length. And I'll store it in a new object and name that object to be equal to iris1. Now let me just print out the head of this. So iris1.head. So now we'd have to build a linear regression model on top of this Boston data frame, where the independent variable is this RM column over here, and the dependent variable is this MEDV column over here, and the train and test split needs to be equal to 80-20. So this question is basically related to machine learning with Python, where we are implementing a linear regression model on top of this data set to understand how does this MEDV column vary with respect to this RM column. Or in other words, MEDV column is our dependent variable and RM column is our independent variable, and we are trying to understand how does MEDV change with respect to RM. So let me start off by loading the pandas library, import pandas as pd. Right, now we'll go ahead and also load up our Boston dataset. So pd.read_csv helps me to load up the dataset, and the name of the dataset is boston.csv, and I'm loading this file in this object Boston, and then I'll have a glance at the head of this. So these are all of the columns which are present in this data frame. So I've got Crim, Zn, Indus, Cas, Nox, RM, and so on. And MEDV is my target and my feature is RM. Or in other words, MEDV is my dependent variable and RM is my independent variable. Now I'll separate the feature and the target. Right? So pd.data frame, and so from this entire Boston data frame, I am selecting only the RM column and I am storing it into the X object. Similarly, from the entire Boston data frame, I am selecting only this MEDV column and I am storing it into this Y object. So X would have the feature values and Y would have the target value. So now I've extracted the feature and the target. Now it's time to divide this dataset into training and testing set. So the train test split needs to be 80-20, or in other words, 80% of all of the records would be present in the training set and 20% of all of the records would be present in the testing set. And to do this, I'd need the train test split from sklearn.model selection. So I'll type from sklearn.model selection, import train test split, and this method takes in these parameters. So first I'd have to pass in the features and then I'd have to pass in the target. So X, Y, and then I'd have to give in the test size. So the test size is 0.20. So this again means that the test set would comprise 20% records and the train set would comprise of the 80% of the records. And the values would be stored in Xtrain, Xtest, Ytrain, and Ytest. So Xtrain would comprise of all of the training values or all of the training records for the features. and X test is basically the test set for the features. Y train is the train set for the target, and Y test is the test set for the target. So we have our training and testing sets ready. Let me click on run over here. Alright, now it's finally time to build the model on top of the train set. So from sklearn.linear model, I will import the linear regression and I'll create an instance of this. So I'll name that instance to be regressor, and I will fit this model on top of X train and Y train, or in other words, I'm fitting the model on top of the train set. Alright, so now that we've fit the model, it's finally time to predict the values on top of the test set. And to predict the values, I'll use regressor.predict, and the parameter which I'm passing inside this is x_test, and I'll store this in y_pred. Now, once we predicted the values, I have to find out the root mean square error. So I'll import metrics from sklearn, and this is how I'll get the root mean squared error. So metrics.mean squared error, and this takes in two parameters, y test and y pred. So y test comprises of all of the actual values and y pred comprises of all of the predicted values, and I will pass these two inside mean squared error. Now when I do this, I'll get only the mean squared error, but I want the root mean squared error. So I'll use np.square root. So I would also have to import the numpy library over here. I'll type in import numpy as np. Now I'll click on run. So now we've arrived at our final interview question, and we'd have to build a decision tree classifier on top of this iris data frame, where the dependent variable is the species column and the independent variables are the rest of the column. So sepal length, sepal width, petal length and petal width would be the independent variables, and your species column is your dependent variable, and the train test split is 70/30. So I'll start by loading the requisite packages, which are numpy and pandas. So import numpy as np and import pandas as pd. Then after this, I'll load my dataset. So pd.read_csv. I'll pass in the file name iris.csv, and I'll store this in the iris object. And we have a glance at the head of this dataset. So these are all of the columns present in this data frame. We've got sepal length, sepal width, petal width, and the species column. Now out of this, the species column is our dependent variable, and these four columns, the numerical columns, are our independent variables. So now I'll go ahead and separate the features and the target variable. So these are all of my features, these first four columns. So I'll just extract sepal length, sepal width, petal length and petal width from this iris data frame, and I'll store that into this X object. Similarly, I'll extract only the species column from the entire iris data frame, and I'll store it into Y object. So I have my features and the target ready. Now it's time to divide this entire data frame into train and test split. So I'd have to import train test split from sklearn.model selection, and this takes in these parameters. First parameter are the features, second parameter is the object which comprises of the target label, and the test size is 0.30. So 30% of the records would go into the test set, and the rest 70% of the records would go into the training set, and I am storing the results into xtrain, xtest, ytrain and ytest. So xtrain is the training set for the features, xtest is a test set for the features, ytrain is the training set for the target, and ytest is the test set for the target. Now we'll import decision tree classifier from sklearn.tree. So I will go ahead and create an instance of this decision tree classifier, and I'll name that instance to be classifier, and I will fit this classifier on top of the training set. So classifier.fit, and I'll pass in xtrain and ytrain inside this. So we have successfully fit the model on top of the train set. Now we'll go ahead and predict the values on top of the test set. So classifier.predict. So I'll store the result into ypred. After this, we'll calculate some metrics. So we'll get the confusion metrics, and we'll also get the accuracy score. Right. So this is my confusion metrics, and this is the accuracy. So the left diagonal which you see in this confusion metrics, all of these are the values which have been predicted or classified correctly. So this first row represents the species of Setosa, second row the species of versicolor, and the third row the species of virginica. Right. So you see that all of the species of Setosa have been classified correctly, When it comes to Versi color, 16 of them have been classified correctly and 2 of them have been classified incorrectly. And when it comes to Virginica, 13 of them have been classified correctly and 2 of them have been classified incorrectly. So to get the accuracy, we'd have to add 12 plus 16 plus 13 by all of the values. So let me just do that. 12 plus 16 plus 13 divided by 12 plus 16 plus 13 plus 2 plus 2. So the accuracy is the same and it comes out to be 91.11. Right, so to do sentiment analysis with Twitter, we'd actually need a developer account. So we'll go to developer.twitter.com and over here, this is my profile which is already there. I'll click on apps and then go ahead and create a new application. So we have this option to create an app. And if you guys want to create a new app, you'd have to click on this, fill up a few details and you'll have your new app ready. But then again, I have already created an app with this name over here, Sentiment 123 Demo. Now let me have a glance at the details, right? So this is my app and it contains these keys and tokens. So in our code, we would have to use these consumer API keys and access token secret. So you'd have to note down these values and then put in inside your code. Alright, now let's go ahead and do some sentiment analysis. So first, we need this TweePy package, which would basically act as the API with Twitter. And then with the help of text blob, we can understand the sentiment of different tweets. So we'll import these two. First is TweePy, next is text blob. And then we'll go ahead and give the values of these four. Consumer key secret, access token and access token secret. So these are the same values. This is the API key, API secret key, access token and access token secret. And I've given the same values over here. After that, using tweepy.oauth handler, I would have to first give in the consumer key and the consumer key secret, and I'll store that in this object auth. Now, again, this auth object contains set access token. Now I'll give in the values of access token and access token secret. Now, finally, I will send this object inside the tweepy.api. So this is how we are basically establishing the connection with Twitter. So we have given all of these four values and we are authenticating this API. And then finally we can go ahead and give in the hashtag for which we'd have to find the sentiment. So let's say I want to find the sentiment for this word Avengers. So using this object API, I'll just type in api.search and it contains the keyword Avengers and I'll store this in the object public tweets. Now, I'll start a for loop. So I will go through all of the tweets which are stored in public tweets. And I'll start off by printing the first tweet. And then I'll pass the tweet.text as a parameter for this text blob function. And I'll store the result in this analysis object. Now, this analysis object helps me to find out the polarity and the subjectivity of these tweets. So it has these two things. One is polarity, next is subjectivity. So first what we'll do is we'll just check if the sentiment analysis.sentiment of 0. So basically this is the first element inside this list. So if the value inside this is greater than 0. So we are basically checking if polarity is greater than 0. Then we'll just print that the sentiment of this tweet is positive. On the other hand, if the polarity of the sentiment is less than 0, then we'll print negative. And if it is not greater than 0, if it is not less than 0, then it basically means that it's equal to 0. So we'll just print that the tweet is neutral. Now let me go ahead and run this. So these are all of the tweets which contain the keyword Avengers. So this is our first tweet. We see that the polarity is 0.0, subjectivity is 0.0 and it is neutral. Next again, this is the tweet. Again, polarity is 0.0, subjectivity is 0.0 and then again it is neutral. So you see that for most of these polarity, subjectivity are 0 and it is neutral over here. And for this case over here, polarity is 0.6. If the value of polarity is greater to +1, then it would mean that it is highly positive. Similarly, if the value of polarity is closer to -1, then it would mean that the sentiment of the tweet is very negative. And then what we have over here is subjectivity. So subjectivity basically tells us how subjective or how personal the tweet is. So we see this tweet that I just needed to share with everyone how Hertz is a truly amazing company. And for this, polarity is 0.6 and subjectivity is 0.9. And then again, for this statement over here, we see that polarity is 0.375, subjectivity is 4.7, and we see that it is positive. And then again, for this statement over here, polarity is 0.0, subjectivity is 0.0, and it is neutral. Right, guys? So this is how we can do sentiment analysis in Python. So NLP is a subfield of artificial intelligence where we teach computers how to understand and interpret human spoken languages, or in other words, natural language. So what in the world is text mining? Well, simply put, extracting information from unstructured textual data is known as text mining. Now, let's say there's a 500-page thesis on some financial topic and you come across a sentence which ends with the number 30. Now, you have absolutely no idea what that number means. It could be the number of days in a month, the amount of dollars a stock increased over the past week, or the number of items sold in a day. So this number 30 could mean anything. And without proper context, you wouldn't get the right information. And this is where text mining comes in. So with the help of text mining, we can give proper context to the words before and after the number 30. And this would help us to find out more information. Now let's look at the need of text mining. So today, with the advent of social media, companies now have access to massive behavioral data of their customers. And most of this data is present in the form of unstructured textual data. But beneath this textual data lies an enriching source of information which can help companies to boost their business. And this is the reason why text mining is being used across various industries. Now, text mining can be divided into 4 practice areas. So we've got information extraction, which basically deals with identification and extraction of relevant facts and relationships from unstructured data. Then we have document classification and clustering, which aims at grouping and categorizing terms, paragraphs, or documents using classification and clustering methods. After that, we have information retrieval, which aims at storage and retrieval of text documents. And then we have NLP, which forms the major part of text mining. So here we use different computational tasks to analyze and understand the underlying structure of the text data. Right. Now we'll dive into NLP. So when you hear the term natural language processing, the first question to pop into your head would be, what is a natural language? So any language that is used for communication by humans is known as natural language. So English, French, Chinese, all of these are natural languages. Now, since we are humans, we're able to understand these languages. But what about a machine? How is a machine able to comprehend all these human spoken languages? Well, this is where NLP comes in. So natural language processing is a subdomain of artificial intelligence where we understand and interpret human languages using a computer. Now, let's see how is NLP used in text mining. So just think about how much text you see each day. Email, SMS, web pages, the list is just endless. So with the help of NLP, we can go through all of this text data and use it for different purposes such as character recognition, sentiment analysis, and spell checking. Right. Now we'll go ahead and install Anaconda into our systems. So Anaconda is basically a free and open source distribution for Python and R programming languages. And it is specifically designed to perform data science and machine learning applications. Right, so these are the 4 steps to work with Anaconda. So first we'd have to download the Anaconda installer and then we'll install Anaconda. Then we'd have to open Anaconda prompt and update Anaconda. Right, now let me just guide you how we can do this. So first we'd have to go to this website, anaconda.com distribution download section, and you'd have to download the version for whichever operating system you're using. So if you're using a Windows system, then you'll download Anaconda for Windows. If you're using Mac, then you'll download it for Mac. And if you're using Linux, then you'll download it for Linux. Now, you've got 2 versions of Python. So Python 3.7 and Python 2.7. And we'll be downloading the latest version of Python, which is Python 3.7. So once we download this, we have this setup wizard over here. So we just have to click on next and it'll take care. Now, once the installation is done, we'd have to open up the command prompt. So this is what we get when we open the Anaconda prompt. Now inside this, we'd have to type in conda update Anaconda and we'll have the latest version of Anaconda in our system. Alright, now let me just go ahead and show how to do it. So I'll just type in download Anaconda. I'll click on this link over here, Anaconda Python R distribution. And over here, I'll click on this download. So I've got different versions over here for Windows, Mac and Linux. And since I'm using a Windows system, I'll download Anaconda for the Windows system. So this is the latest version of Anaconda, Python 3.7. I just have to click on download. Right, so once the download is done, I'll get a setup wizard and I'd have to set it up. And I'll go and click on Anaconda prompt. So this is my Anaconda prompt over here. So now that we've successfully installed Anaconda into our systems, we'll go ahead and work with the OS module. Right. So the OS module, it provides functionalities to perform operating system dependent operations. So these operations include creating directories, creating, renaming and removing files and many other tasks. And these are the different methods we've got. So we've got os.rename, os.open, os.list directory, os.make direct, os.get current working directory and os.fdopen. Now to work with the OS library, we'd have to launch the Jupyter Notebook. So we can either launch the Jupyter Notebook through Anaconda Navigator or we can launch it through the Anaconda prompt. So Anaconda Navigator basically provides you a GUI. So you can either use this or the Anaconda prompt. Now when you open the Anaconda Navigator, you have Jupyter Notebook inside this and all you have to do is click on launch. Now once you do that, you have your Jupyter Notebook right in front of you. So over here, you'd have to click on new and open up a new Python notebook. Now once you do that, you have a new page and over there you'll be performing different operations. So your first task would be to import the OS library. So you'll just type in import OS. Now if you want to have a glance at the current working directory, all you have to do is type in os.get current working directory and it will give you the current working directory. And if you want to create a new folder, then you'll type in os.make dirs and then you will give in the path. After that, you will give in the name of the directory which you want to create. So let's perform this. So again, I'll just type in Anaconda prompt over here. Now inside this, I'll type in Jupyter Notebook. Right. So now we see that we've launched the Jupyter Notebook over here. Now I'll click on new and I'll open up a new Python 3 notebook. So our first task was to import the OS module. So I'll type import OS and I've successfully imported this module. So as I stated in the PPT, the OS module is basically used to work with different operating system applications. So you can create different directories, you can open up new files, you can rename files and so on. So our first task over here is to have a glance at our current working directory. So I'll type in os.getcwd and I'll put in the parenthesis over here. Right, so this is my current working directory, C users Intellipaat. Now I want to make a new directory in my C drive. So this would be the command for that. So I'll type in os.make dirs and over here I'd have to give in the path. So I'll type in C:/ and I'll name the folder as, let's say, new folder. Let me click on run. Right, so now I've successfully created this folder. Now let me actually go to the C drive and see if this folder exists or not. So this is my C drive over here and I see that we have this folder with the name new folder. Now we'll go ahead and perform some more operations. So let's say I want to open a file which is present in my system. So to do that, I've got this command os.open and inside this I will give in the path of the file and then I'll give the name of the file. After that, I also have to give the extension of file, right? So this is a text file, so I'll type in file.txt. And over here, this is basically the flag. So over here, I'd basically be setting what sort of operation I want to do. So O_RDWR, it stands for read and write. So I've got different operations. So I can open this file in only either read format or write format or read write format. Now, after that, we set in another parameter over here, which is os.o_create. So this means that if a file with the name file.txt doesn't exist, then it'll automatically create this new file and then it'll open it up. And then we've got another operation. So if I want to have a glance at all of the contents which are present in a folder, then for that the command would be os.listdir and I will give in the path. So over here I want to have a glance at all of the contents which are present in the D drive. So I'll just give in D over here. So these are all of the contents which are present in the D drive. Right, so now I'd want to open this sparta.txt file using the OS module. So let me do that. So the command was os.open and inside this, as we saw, first we'd have to give in the path. So let me copy the path over here. I'll click on properties I'll copy all of this and I'll paste it over here. You'd have to keep in mind that you'd have to give in double slash over here. So the path over here. So to separate all of these, you'd have to give in a double slash. Again, you'll give in a double slash over here, and then you will give in the name of the file. So the name of the file is sparta.txt. After this, I'll give in the flag over here, which would be os.o_lb read and write. And then I'll give in the pipe operator. So over here, I'll just state if the file doesn't exist, then I'll tell the operating system to create it. So os.create, I'll click on run. Right, so we have successfully opened this file. Now I'd want to have a glance at all of the contents which are present in the C drive. So I'll type in os.list directory, and inside this I'd have to give in the path. So I'd want to have a glance at all of the contents which are present in the C drive. Right, so these are all of the folders or all of the contents which are present inside the C drive. Then I have a couple more commands over here. So this is the command to change the working directory. So over here I am changing my working directory from D drive to my folder. So I just have to give in the path for this, and this is how I can change the current working directory. And then we can also change the name of a file. So let's say if the name of the file was oldfile.txt, then to rename it, I'll just give in newfile.txt over here. So let's perform both of these operations. So let me perform both of these operations over here. So I'll type in os.chdr, and inside this I'll set the working directory to just C drive, C:// right. I've changed the working directory. Now let me also check the current working directory now. Right, so now I've changed the working directory to C drive. Now let me go ahead and rename a file over here. So I'll type in rename. So over here this takes in two parameters. First is the path where the file is located and the name of the file. So I'd just rename this file over here Sparta. Right, so as we saw earlier, the name of the file was sparta.txt. Let me also remove this over here. Let me just put in a single quotation mark. Now after this I'd have to rename this. So I'll copy this all again and I'll paste it over here. Now I'll change this to Sparta new. I'll click on run. Right, so now we see that we've got a new file over here. So initially it was sparta.txt. Now we've changed it to Sparta new. Right, so that was the OS module. So the OS module we saw how can we create new directories and how can we change the names of some files. Now we'll go ahead and do some proper file handling in Python. So the IO module is the default module in Python that is used to perform file handling operations, and it contains functions that return a file object called handle, and this handle is then used to read from a file or write to a file. So this is the command to create a file object. So we'll be using this function from the IO module. So open, and this has two parameters. So this is the first parameter file, and over here we'll give in the path of the file or just the name of the file. After that we've got the mode. So over here this mode basically specifies the way we want to open a file. So we've got these different modes over here, R, R+, W and W+. So R basically stands for read only mode, right? So if we open a file in read only mode, then we can't edit it. So it's only read only mode and it starts from the beginning of the file. After that we've got R+, which stands for read and write mode. So over here the file pointer again starts at the beginning of the file, and with this we can read the file as well as write something in the file. Then we've got W, which stands for write only mode, and even this, the pointer starts at the beginning of the file and it starts to overwrite the existing file. Then we've got W+, which allows us to write and as well as read. Now this doesn't start from the beginning, but it actually starts at the end of the file, right? So we can start writing from the end of the file over here. So these are the different modes which we can open a file. Now these are the different methods from the IO module with which we can read from a file. So now let's say we've opened up a file. So open, and then I'll give in the path, and I'm opening this in read only mode. Now I'll store the file in this F1 instance over here. Now if I want to read the entire file, I'll just type in f1.read over here. So this would give me the entire file over here. Now instead of reading the entire file, let's say if I want to read only the first line over there, then what I'll do is I'll type in read line. So I'm storing this file object in this F1 instance over here. After that I'll type in f1.read line, and this would just give me the first line over here. So let me perform these two operations. Right, so I'll type in import IO over here. Let me load this up. Now I'd have to open the file. So open, I'll take the path. So I want to open up the same file, which is sparta.txt. Right, now I want to open this in read-only mode. So I'll type in R over here. Right, so I've also given the board. Now let me click on run. Right, so I've created an instance of this file. Now let me go ahead and read the contents of this file. So I'll type in f1.read. So these are the 3 lines which are present in this file. This is Sparta, this is 300, and this is Intellipaat. So let me just verify this. I'll open up this file, right? So these are 3 lines. This is Sparta, this is 300, and this is Intellipaat. Now, as you see, all of these 3 lines are separated by /n. So over here, /n denotes a new line over here. Now, instead of reading all of these 3 lines, I want to read only the first line from this file. So the command for this would be os.readLine. Right, so now let me click on run. Right, so I've just read 1 line from this entire file. Now we'll see how to read a file line by line using for loop. So again, first we'd have to open up the file and save this file in an instance. So over here I'm saving this in F1. After that I'll start the for loop. So over here I'll create a new variable. So for line in F1, and this line stores every line which is present in this file over here. So it'll store the first line and then we are printing the first line. Now once that is done, it'll go back and then print the second line, and it'll go back and then print the third line, right? So this is what happens. Now after we print all of the lines, I'm just typing f1.close. So when I type f1.close, it'll just clear all of the buffers and close the file. So I'll just type in for line in f1, and over here I want to print f1, right? So let me start off by using the for loop. So I'll type in for line in f1, and I'd have to print each of the line. So I'll type print line, and I'd have to close the buffer. So f1 dot close. Let me close this. Now let me click on run. Right, so let me start off by using the for loop over here. So I'll type in for line in f1. So this is f1 and not s1. I'd have to print each of the lines. So I'll type in print line, and then I'd have to close the file. So I'll type in f1 dot close. Right, so let me run this. Right, so I've extracted each of these lines with the help of the for loop. So we've got this is Sparta, this is 300, and this is Intellipaat. Now let's see how can we write something to a file. So to write something to a file, we can use the write method. So again, we'd have to start off by opening the file, but this time we'll be opening this in write mode. So over here, I'll set mode is equal to W, and while writing, I also have to set the encoding type. So the encoding of this file is UTF-8, and what I'll do is I'll add 3 new lines over here. So I'll type in, this is the first line, this is the second line, and this is the third line, and these 3 would be added to this current file. Now instead of adding one single line, let's say if I wanted to add multiple lines over here. So for this, what I'd have to do is I'll create a list, and inside this list I'll separate these 3 items with the help of /n. So as we already know, this /n, it denotes a new line. Right, now after that we'll open the file, and over here we'll open this in the mode A+. So A+ stands for the append mode, and we'll write this entire list into the file over here. Now let's perform these operations. Right, so what I'll do is I'll copy the same command over here and paste it over here. So the file would be the same, and over here I'll set the mode to be equal to W. So W stands for write, and after this I'd have to set the encoding. So encoding would be equal to UTF-8. So I'll type in UTF-8 over here, and I'll click on run. Right, so I've successfully opened this file in write mode. Now I'd have to go ahead and write something into this. So I'll type in f1 dot write over here, and let me write something inside this. So let me add the first line over here. So the first line would be this is 1. I'll click on run. Then I'll type, let's say, f1 dot write, and I'll type this is 2. I'll click on run again. Then I'll type f1 dot write, and I'll add the line this is 3. Now let me go ahead and open the file. So this time I'll open the file in read-only mode. So I'll set this mode to be equal to R, and I'll remove the encoding from over here. I'll click on run. Right, now I'd have to type in f1 dot read. Right, so this is what I have. This is 1, this is 2, and this is 3, right? So I've successfully added these 3 elements into my file. Now, as you see over here, my file initially had these 3 lines over here. This is Sparta, this is 300, and this is Intellipaat. Now, when we use the write mode and we entered these 3 lines, this is 1, this is 2, and this is 3, what it did was, it replaced these 3 lines with this. And this happened because the pointer starts at the beginning of the file. And when the pointer starts at the beginning of the file, all that which was there initially, that would be replaced. So let me go to the file now and see how it looks like, right? So I have a single line now. This is 1, this is 2, and this is 3, because the earlier thing was replaced. Now I'll go ahead and actually create a list over here. So I'll name this as L1 and I'll add some values over here. So let's say the first value is A. I'll add a new line after this. Then the second value is B. Again, I'll add a new line after this. And then I'll add a new value, which is C. After that, I'll add a new line. Now I'll open this file in append mode. So this would be the same. The mode would be A plus. And I'd have to give the encoding again. So encoding would be UTF-8. Right. So this time I've opened the file in append mode. Now what I'll do is I will go ahead and add this. So f1 dot write lines, and inside this I'll just put in L1. Now I'll go ahead and open the file. Let's see what do we get. So I'm opening the file in read mode now. Now let me read what we have in this file. So now I have successfully added these 3 characters over here, A, B and C. So now let me open the file, right? So this was the first line. After that I added A, B and C. Alright guys, now let's see how can we work with Word document files. So we have this library with the name Python docx, and we can use this for creating and updating Microsoft Word documents. So to install this library, we'll again have to go to Anaconda prompt, and inside Anaconda prompt we'll given this command, conda install -c conda forge python docx. Right, so with the help of this command, we'll be installing Python docx library. So once the installation is done, we'll go to either Anaconda prompt or Anaconda navigator and then launch the Jupyter notebook. So we'll open a new notebook over here, new Python notebook, and we'll type in import docx. So here you have to keep in mind that when importing the library, you'd have to type docx and not Python docx. So you'll type in import docx. So once you import the library, now let's see how can we create and update a Word document. So starting off, we'd have to create an instance of our Word document. So to create an instance, we'll invoke the document method. So we'll type in docx.document and we'll create an instance of the Word document. So I'm naming this instance as document. Now once we have this instance, we can add all of the content into our Word document. So I'll type in document.add heading, and with the help of this I can add a heading to my document, right? So over here I'm adding the heading. This is a 0 level heading. So here 0 indicates the level of the heading, right? So once we add the heading, now we are going ahead and adding a new paragraph. So here I'm typing document.add paragraph and I'm just writing this is a paragraph. And after that, if I want to add a page break, so we can use this method document.add page break. So we created an instance, and with the help of that instance, we added a heading and we also added a paragraph. Now it's time to save the document. So to save the document, we'll type in document.save, and inside this, we'll give in the name by which we want to save the document. So I'm saving the document as document.docx, right? So this is how we can create a document. Now let's see how can we read a Word document. So to read a document, we'd have to start off by importing this document method from docx. And then we'll use this document method, and inside this we'll pass in the name of the document. So we'll pass in document.docx, and this is the file which we had just created earlier, and we'll save this in a new instance and name that to be doc. So once we have this instance over here, we'll use the for loop, and with the help of this for loop, we'll print all of the content inside this document. So I'm typing in for para and doc.paragraphs print para.text, right? So it will take in each paragraph over here and it will print each paragraph with the help of this for loop. Right, now let's go to Jupyter Notebook and actually perform this. So I'll start off by importing the library, which is docx. So I'll type in import docx. Now I'll go ahead and create an instance of this. So docx.document, and I'll name the instance as doc. So now that I have the instance, I can add the content into this. So I'll type in doc.add heading. Now let me add the heading. So I'll just say heading 1 over here, and then I'll add a couple of paragraphs. So this time dot add paragraph, and inside this I'll type in P1, and then I'll add another paragraph. So I'll type in dot add paragraph again, and I'll add P2 inside this. After this I'll add a page break. So I'll type in dot add page break, and I'll click on run. Now after the page break I'll give another heading. So dot add heading, and I'll give the heading as heading 2. So all of this is done. Now it's time to save this document. So I'd have to type in dot save, and I'll give the name of the file. So I will save this as, let's say, my docx. Right, so now I have successfully saved this file. Now it's time to read this document which I've just created. So I'd have to import document. So I'll type in from docx. I'd have to import document. Right, so now that I've imported this, so I'll just give in the name of the doc which I've just created. So my docx, and I will store this in a new document again, and I will name this as D1. Right, so now I have created a new instance of the document which I had created earlier. Now I'll use the for loop. So for para in D1 dot paragraphs, and I'll just print this out. So print a para dot text. So now we have the content which is present in the document over here. Heading 1, para 2, and then we added a page break. After that we have the heading 2. Right, so this is how we can work with the docx module. Now let's head on to the natural language toolkit. So NLTK is one of the most widely used packages for the purpose of natural language processing. So NLTK provides multiple packages to perform different operations such as tokenization, POS tagging, named entity recognition, and sentiment analysis. Right? So NLTK provides very easy to work with modules, and with these modules, all of your work becomes much more organized and much more easier. Now again, let's see how can we install the NLTK package. So again, we'll have to go to Anaconda prompt, and we'll give this command inside Anaconda prompt over here. So we'll have to type in conda install -c Anaconda NLTK, and this is how we can install the NLTK package. Right. Now once we install the NLTK library, we have something known as the NLTK corpora. Now you must be wondering what exactly is a corpora. So before understanding corpora, let's understand what is corpus. So a corpus is a huge collection of written text, and a compilation of these corpuses is what is called as a corpora. Now NLTK provides this huge corpora for multiple purposes. So it has got all of these different corpuses pertaining to different domains, and we can use it to perform various NLP tasks. Right, now let's see how can we download this NLTK corpora. So once we install NLTK, we'll have to go to Jupyter Notebook and then type in import NLTK. And then after that, we just have to type in nltk.download. So this would give you a setup wizard. Now all you have to do is click on download, and this will install all of the corpuses which are present in NLTK. So this is how you can import a corpus from NLTK. So there's this corpus with the title names, and we are importing this corpus. So I'll just type in from nltk.corpus import names, and this just has a list of all of different words. So to have a glance at all of those words, I'll type in names.words. Right, now let me go to Jupyter Notebook and just show you how can we do this. Right, now let me start off by importing NLTK. So from nltk.corpus, what I want is names. So this is basically the name of the corpus which you are importing. Right, now I've imported this corpus. Now I want to have a glance at the list of the names which are present. So I'll just type in names.words, and I'll click on run. So this is the list of the names which is present inside this corpus.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
So what will we be doing in this session? Well, the first thing that we'll be doing in the session is that the first thing we'll be doing in this session is that we'll be taking a look at the global data for the COVID-19 that's available. It's an open source data, so you can use it whenever you want and however you want to. And we'll be building a model that can tell us the number of confirmed cases and fatalities that are expected to occur the next day. And that will be done by analyzing the trend of the data that we have right now. So our model will do all of that for us. Just a quick reminder for those of you who are not comfortable with Python, you can stick with me till the end of this session, and I'll guide you through some resources that can help you out with that. Also, another thing that you need to understand is that we aren't going to be diving deep into the mathematics of how a random forest works and how that works. I'll show you the general overview, but it doesn't really matter whether you are very math heavy or tech heavy person. The point of this session is to show you that even if you are not very educated in math, or even if you are not very comfortable with math, you can still get around with using machine learning algorithms, using data and making sense out of the data that you have. So with that in mind, let's take a look at what we have next. So let's take a look at the data that we'll be using. Now the data, as I've already told you, is open source, so you can use it whenever you want to. But basically, we'll be using the global COVID-19 data. This data contains information about countries, it contains information about regions, it contains information about the population, and it gives you a column named target. Target basically tells us that the data we have is of either the confirmed cases or the number of fatalities. So as you can see in the screenshot that I have right below me, we have cases for Afghanistan, and we have certain columns that are having the values of NAN. NAN stands for not in number or not available. So the problem is that when you have a data set, there are many times when you don't get to use the when you don't get to get the data that's completely accurate. There are going to be some missing values. There are going to be some values that are out of order and not in the correct format, and there could be a lot of other things. So that would be the problem. So if you want to get this data set, you can get it from Kaggle, and that will explain to you how there are competitions going on COVID-19. This data is available on Kaggle right now. You can take a look at the COVID-19 competition, and you'll get the data, you'll get the problem statements and everything, but just the data is enough for you to get started. So what is random forest? Random forest is the algorithm that we'll be using in this session. We'll take a look at why we are using random forest in a bit, but first let's understand what is random forest. So random forest is a supervised learning algorithm. So for those of you who are unaware, supervised learning is a type of machine learning algorithm in which we have a lot of data, and we have the thing that we want to predict as well as the things that we want to use to make the prediction. So to give you an example, if you want to make a prediction about a person's estimated salary, the salary would be the thing that you want to predict, and the other things such as the person's age, qualification, the college that they graduated from, the CGPA or GPA that they had when they graduated, all of these things when taken into consideration are the things that we will be feeding our model to get the estimated salary of a person. So these are the kind of things that supervised learning helps us do. It helps us firstly train our model on a labeled set of data, and then give it some data, and it will predict the data that we want it to predict, like the person's age, salary, or whatever we want to predict. So that's why we do it. Now, random forest, as the name suggests, is an algorithm that's also called an ensemble method. Basically, instead of using some other very vague algorithm, it uses decision trees, but it uses them in a very smart way, so that we can train multiple decision trees, and then we can use those multiple decision trees that have been trained on the data that we have, and then we use those trained decision trees to make the decision that we want to. How does it make the decision? Let's take a look at that. So let's firstly understand why we use random forest. So random forest is used to solve a wide variety of challenges. Random forest is used to solve a large set of problems, and it's mainly because it provides many benefits, such as no overfitting. So our model will not be able to memorize the entire data. So overfitting basically means when you try to train a model and it essentially just memorizes all the mappings. So when it gets the training set and some of the values matches, then it will basically, what it will do is that it will compare the values and then it just get the output which sounds the most similar to it. Instead of making a calculated intelligent decision, it will basically be remembering stuff, mugging up stuff, and then giving you the answer, which is not the way that it's supposed to do. And when we overfit our model, then we get really good accuracy, like 100% of accuracy many times. But then the problem is, in real world it doesn't perform really well, because in real world there is no it's not able to identify the pattern that can map the data that we have to the output that we want. So random forest allows us to overcome that problem because it uses multiple decision trees and it gives us high accuracy. Now that depends on the data that you have. If you have a really large set of data, then high accuracy is something that you can be sure of getting when you're using random forest, or you can be quite certain that you'll be getting a really good level of accuracy. So there are many things that you need to take into account when that happens, especially the quality and the quantity of data. But if everything is in the right format and is in the right shape, then you can expect a higher accuracy from random forest. And then it comes to one of the most important aspects, which is it deals with missing data quite easily. So as I've already told you, that if you have columns that have a lot of missing values, then it's probably better not to use it. But if you have columns that have some missing values, let's say that there are 10 rows of data that you have, and one of the columns doesn't have data for 2 of the rows. So essentially you have 10 values, you are supposed to have 10 values, but you only have 8. Decision tree could fill up these decision trees, and random forest could fill up these data points by just figuring out what exactly is the data that we have, figuring out a trend in the data, and then fill those missing values using that. Now, again, it's important to understand that we don't have to go overboard with this. Sometimes what happens is we are missing around 50% of the data. That time, it's not really a good idea to use a random forest or decision tree to predict the values that those columns should be containing, because you don't have that much of data available to train your model to begin with. So it's better to drop the data or to insert the data manually, like filling it all with 0 or filling it all with the mean value, or doing some complicated things by separating the data points into groups and then filling the means of those groups in those columns. There are many ways of doing this, but if you have some missing data, random forest is quite easy to use random forest to get the data inside those columns. Now, how does random forest work? Again, we'll not be going into the mathematical intricacies of the entire working of random forest, but it should give you a good understanding of how it works. So basically, in random forest, we train multiple decision trees. And what are decision trees? We'll take a look at that in a moment. But think of decision trees as flowcharts that are derived from the data that we have. So we make multiple decisions, multiple true or false decisions. And if we make enough decisions and we come to the end of the tree, then what we realize is that that is the answer. So we use that. After training those multiple decision trees, what we do is we make predictions, and we use all the decision trees to make the prediction. So let's say that I have trained a decision tree, I have trained a random forest to predict the stock price of a particular company in the coming few days. Now, what I will do is, let's say that there are 3 decision trees that are trained inside a random forest, and then I will ask all the 3 decision trees to make the prediction for the next couple of days, let's say the next 7 days. Then when all 3 of those decision trees have made the decision and they have given us an output, the majority decision is what is considered to be the final decision of a random forest. For instance, if I have a decision tree that's trying to predict the house, that's trying to predict the prices of stocks, then what I have to do is I have to take into account how many decision trees have predicted a particular value. And if majority of them have predicted a particular value, then that value is the one that I use. So to give you an example, let's take a look at this. So suppose that I want to create a model that predicts whether a person has a particular disease or not. So it's, as you can see in the image down below, we have a random forest. It contains 3 decision trees. And what it does is that 2 of those decision trees give you the output of true. That means the person does have the said disease, and 1 decision tree gives you the value of false. That means that since the majority of the trees are pointing towards true,
the decision tree, the decision taken by the random forest is going to be true. So the person does have the problem that we're talking about. So let's take a look at what decision trees do. So in each decision tree, what we do is we try to split the data on the basis of a particular feature. So let's say that I have a data set in which I have the person's name, I have the person's age, and I have the person's qualifications. So as you can see, the data will be quite varied depending on the person's name, age, and qualification. Then what we will do is we will try and find out which of the particular columns, namely name, age, and qualification, allow us to best separate the data into separate parts. So that way we can figure out what we're trying to do. So in that case, what will be, and that again takes a lot of mathematical computations, but you don't have to worry about that. Once we figure out the feature that we want to use and we figure out what is the value on which to separate, then we do this again because we have 3 features and we have multiple ways of splitting the data. So we keep doing that until we reach some sort of a conclusion. And when we do reach a conclusion, then we make the predictions based on the rules or the rules that we've come up to how to separate the data. Let's take a look at an example. A very popular example when it comes to machine learning and any sort of machine learning or data science algorithm is the iris dataset. It basically contains some information about flowers, such as the sepal length, sepal width, and the petal width. And we come up with we try to figure out whether a particular image contains iris setosa or virginica or versicolor type of flowers. These are particular groupings of flowers or particular types of flowers. So let's say the decision tree comes up with this kind of formula. So right at the beginning, it will take a look at the petal length, and it sees whether or not the petal length is less than 2.45. If it is, then it's the setosa. So as you can see, all of the petal length in the data that we have are less than 2.45, so they are all iris setosa. But let's say that it's not less than 2.45, but it is less than 4.95. So if the petal length is less than 4.95 centimeters, then it's versicolor. And if that's not true as well, then it's finally virginica. So essentially, any data point that has petal length less than 2.45, it's setosa. Any data point that has the petal length between 2.46 and 4.95, it's versicolor. And any data point that has the value of about 4.95 of petal length, it's virginica. So this is how decision trees come into play, and we use multiple decision trees. We train them again and again. So that's why we don't run into the problem of overfitting, because we've trained them again and again using different parameters, and we've gotten decision trees that work differently on different data. So the majority decision wins in that regard. So with that in mind, we come up to the hands-on for the global prediction. So let's take a look at the hands-on. For that, we have a Jupyter notebook, and this notebook is taken from Kaggle. So we'll be explaining to you how these things work and how the person who has come up with the code and the understanding, how are they doing it. So what we're doing here right at the beginning is we're importing everything that we need to. Now, it's not necessarily the case that you need to import everything right at the top, but it's really a good idea to import everything right at the beginning, because then the person who's taking a look at your entire notebook can understand what are the libraries that you have used, whether they have those libraries or not. If not, that they can install them and then run your notebook. So these are the libraries that they have used. And to be quite honest, they are not really in esoteric libraries. Many data scientists use these libraries quite frequently. Matplotlib, Pandas, NumPy, Seaborn. So these are for data manipulation, data extraction, and visualization. Plotly is an advanced visualization library, and they have used the datetime library to convert the dates into multiple formats, which we'll be taking a look at in a moment. Now, I've already run all the cells because the data is quite huge, and this would take a lot of time for me to run the entire data set through the entire process, and I don't want to waste your time. So this is how it's happening. Then we have imported multiple things from the sklearn library. We have imported the random forest regressor. The reason why we're importing the random forest regressor is because it's a regression problem. We're trying to predict a continuous value. So the number of people who have been found as the confirmed number of cases, they could be 40, there could be 45, there could be 60, there could be 61. So they are not something that you can either predict into true or false or one group or the other. What's happening here is this: we're trying to predict a continuous value, continuous numerical value, and that's why we're using random forest regression. Then we have the standard scaler and label encoder to resize or reshape our data into a particular standard size and to convert categorical data into numerical. Finally, we have pipelines and train test script to understand what that means, and we're telling matplotlib that whatever visualizations it produces, it needs to be displayed, it needs to be optimized to be displayed inside a Jupyter notebook. But with that in mind, we have data set such as train.csv and test.csv. Again, this has been taken from Kaggle, so they have provided the data set. It has train.csv and test.csv, which is the training data and the testing data. So with that, we firstly take a look at the training data. So as you can see, we have the ID, which is not really useful in our scenario, but it could be that it has been taken from a database that contains the entire IDs and it has been converted into a CSV file. As you can see, most of the top values per country are not available, and for province state is not available. This gives you an insight in what a data scientist would have to do on a day-to-day basis, which is essentially just take a look at the data, and if you're not getting, or if the data that you have contains a lot of missing values, then what you do with it. And we'll take a look at how to deal with this. We have country, region, we have the population, weight, date, confirmed cases, and the target value. So we're taking a look at the target, which specifies the target value is either the confirmed cases or fatalities. So on 23rd of January, the confirmed cases and fatalities in Afghanistan were 0. So there were no corona cases found in them. And similarly, we have the test cases. And in the test data, what we have is we have the entire data set. And in that data set, we are missing the target value, which is something that we have to predict. That's what we're supposed to do here. Now we take a look at the shape. A shape basically means the rows and the columns. So we have, as you can see, this is the number of the rows that we have, which if you see is quite large. So we have 9,07,306 rows, which is a really large data set. This is why I didn't want to import the data again and run the entire Jupyter notebook again for you. And for the testing, we have 3,11,670. And there are 9 columns in the training data and 8 columns because we have to predict the 9th column. Now we take a look at the number of missing values in the training data and the testing data. And as you can see, 83,840, which is quite a lot if you take a look at the data that we have. So we will be taking a look at that. And we have province state, which is 48,994. So we have quite a lot of missing data in country and province state in both testing and training. So with that in mind, and by the way, this is all being done by NumPy for pandas for you. So pandas is the library that we use to read the CSV file. Then we take a look at the head of the file and it gives you this nicely formatted list of all of this. It is displayed well in Jupyter Notebook. And then what we do is we take a look at how many null values are there and the sum of the number of null value columns inside it. So this is what we have. Now what we do is we take the ID and the forecast ID from the ID will be taken from the training data set, and the forecast ID will be taken from the testing data set. And now this is just to show you how to get the data out of a particular data frame. And now finally what we do is we drop the values or drop the columns that either have null values or are of no use to us. So what we do is we remove the country because it has a lot of null values. We remove the province state, it has a lot of null values. And we remove ID because it's not going to help us in any way, shape, or form. Another reason is that another reason would be that someone has asked that they want me to recommend some free courses to you. I will be recommending free courses. So if you want to learn more about that, then stick with me till the end of the presentation, and I'll be showing you some resources that you can learn free and paid as well. So with that in mind, let's continue. So we will drop the country, province, state, and forecast ID because these are the incorrect value or null values, and a forecast ID is something that we don't really need. And if we put data that is of no use to us in our training set, then it could negatively impact the performance of our model. So we drop them. So we are telling the columns that we wanted to drop, and then the return data frame is the one with the dropped column. So we assign it again to our data frames, and we get the dropped columns. Now we try to visualize the data. So as you can see that the target values are there, we have the weights, we have the population. As you can see, it's quite widespread. So certain things such as the population of a country or something could be leading up to something like this. So 1.5 billion or something like this. So the most populated countries have this much population. Similarly, you can take a look at all of the other things that we have, and when we cross these things, we get this. So what we're doing basically here is that we're taking a look at the population and the target value. We're taking a look at the weight and the target value, and then the target value with the target value basically shows you that we have 0 or whatever. Now we take a look at the pair plot or the bar plot, which basically takes a look at how many confirmed cases and how many fatalities we have in a training data set. So as you can see here, this is the number of that. So we have a lot more confirmed cases than we have in the fatalities. So not a lot of people have it has caused a lot of fatal deaths for number of confirmed cases. As you can see, the number of confirmed cases is quite high. And with that, now we take a look at the target and the population. So confirmed cases and fatalities, they have quite a good amount of confirmed cases and fatalities according to the population that of a country is there. And we are using the training data again. So now we take a look at and this is where matplotlib comes into play. What it does is that it creates a pie chart or a donut chart necessarily for you, and it shows you the target value, what the confirmed cases and all of that. So as you can see, in US, the majority of cases are in the US, which is 53.7% of our entire data set. It could be that our data set is not completely correct. So it could be that there are some values that are missing, maybe US is just 46%. But the majority of the data that we have belongs to the citizens in the US. As you can see, it's right there. And again, you don't need to know any math to do this. You just need to understand how to write code for this. We create a figure, we create a pie chart, we update the traces, and once you understand matplotlib, you understand how you use these things. Basically, we just tell it we want the text inside our pie chart, inside the pies that we have created out of the entire chart. And with that, we give the uniform mid size, and if the text is too large to fit, then we hide it, so on and so forth. And then what we do is we group the data by the country region, and then what happens is we take a look at the target value. So after grouping it, we sum it, and then we take a look at the target values. As you can see, in Afghanistan, there are 16,015 cases, and you can take a look at any number of cases here as you want to do. So as you can see, in US, there are a lot more people than there are in Afghanistan. And with that, we come, as you know, we have 9 lakh cases in our data set, and out of those, 5.7 lakhs are from the US. So with that, we get the largest 5 values of target values. So top 5 most affected countries are the ones that we have here. And we have the US, Brazil, we have Russia, United Kingdom, and Spain. So these are the top 5 countries that have been mostly affected with COVID-19. And this is what our data indicates. And so as someone has asked, what if I have to find the data of a particular country? So if you want to find the data of a particular country, then as you can see, we have it here. We're printing the target value of all the countries. If you want to find of a particular country, then you have to type it like this. Here, you will have to type, let's say that I want to find of India. Just make sure that you have written the word India correctly here, if the I is capitalized. From the given data that we have, it seems that the first letter of the entire country is capitalized, so we get that. So again, this is something that you will learn once you learn about matplotlib and pandas and all of the libraries. I won't be running this again, because for this to run, I would have to re-execute the entire Python or Jupyter notebook, and that would take a lot of time. So I'll just show you how to do it, and you can do it on your own. With that in mind, we have this, and now if you want to visualize this, again, just 3 lines of code is required here. So again, no mathematics was required as of now. what we've done is we have created a cat plot in which we have these 5 values. We have the target value as the x-axis and the population is the y-axis, and this is what we have. Now with that we get the top 5 most populated countries in the world, and we have China, India, US, Indonesia, and Brazil. And these are the top 5. So we have the n largest function that's doing this for us. And now what we do is we come up to some interesting visualizations. So this visualization is called tree map. It allows us to basically create a tree or a jigsaw-like structure in which the larger the value of a particular country or a particular data, the more size it gains in the entire plot. So as you can see, if I hover over US, I get this interesting hover menu, in which we get all the values that we want, the target value, the country, population, and many other things. You go to Brazil, you go to Russia, you go to India, you will get a lot more. So as you can see, India is quite densely populated, so it's getting all of this. Then there's this, United Kingdoms, Iran, Turkey, and as you go down, you can take a look at other countries as well. But those countries don't have that much of population, so the squares are quite small. Now that is done, but as you can see, the date and time was not in the correct format. So if I were to show you the date and time that we had earlier, if you take a look at the data that we had data like this, which is 2020-04-27. Now a problem with this is that it cannot be converted into a numerical format because there are dashes in it. If there are slash, if there are dash, if there's any character in it that's not number, then that's a problem. So to convert it into completely numerical, what we do is we use the datetime library that we already have installed, but we need to use it correctly. So here's what we do, right beneath the tree map, we get the date and we convert it into the datetime format, and then we convert it into years, months, and days. So as you can see, 2020-04-24, which is 24th April 2020. So this is how they convert it. And the reason why we convert it into this way so that it could be numerical is mainly because if you don't do it this way, then you get values that are string based or character based, and machine learning models don't work on data like that. Similarly, as you can see, we have confirmed cases, we have the name of the countries, and these are the things that we need to convert into convert it from categorical to numerical. Categorical is thing that's not numerical. For instance, US, Brazil, the computers and the algorithms will have no understanding of what these things are. These could be anything as far as they're concerned. Similarly, confirmed cases and fatalities, they have no idea what that is. So with that, we create some interesting plots. These are called heat maps. Heat maps will show you the date and the number of cases that they got on those dates. So as you can, and we have gotten just a few dates so that we can take a look at that. And as you can see, majority of these are quite empty, but China got these cases quite early on. So that's why we're getting this here. And then either they didn't have the data or they had no cases. So that's why we're getting these values. And we can explore more about this data later on. We can explore more into the dates and what are the missing things and all that. Similarly, we have it here, and this allows us to understand just how many people were coming each day. So the brighter red the column, the more people came that day. So if it's light like green or yellow, then it's not that many people, as you can see on the legend right on the left hand side here, on the right hand side here. Then we take a look at the nth largest values here as well, and we get the same thing. We get target values, we get fatalities, and as you can see, China is right here, and we get the values. And then we create again the heat map, but this time we create for a larger date range, and this is what we get. So as you can see, these are the countries, and again, as you can see, Bangladesh had data till this date, and then later on it didn't. Similarly, for others, we don't have the exact same thing. So let's take a look at, now comes the time to understand what are the columns that don't have the numerical values. Basically, what we do is we say in the training data set, get the column names that are of type object. Object is anything that is not numerical. So we have country, region, and target. And similarly, in the test one, we have the same thing. So now it's time for us to convert our categorical data to numerical data. So we get label encoder, and what it does is that it assigns a unique value to each of the data that we have. So for instance, if we had a column in which we had male and female as the only values that it contained, let's say that it's an employee one, so it will assign the value of 0 to male and 1 to female, and then whenever it sees 0 in the data frame, it converts it into it sees male in the data frame, it converts it into 0, and if it sees female, it converts it into 1. Similarly, we keep going on and on. So we do that here, and then we get the data that we want. We get the first column, which is the country region, and then we convert it into from string, then we convert it into the numerical data that we want. We do the same thing with the training data, and we do the same thing again, but for the other columns, which is the target column. And now, as you can see, this is what our data looks like. Countries, Afghanistan, I think, is given the value 0 here, and confirmed cases are 0, and fatalities is given 1. So now everything, as you can see, is numerical. So that's good. Now what we do is we separate our data into X and Y data. So X and Y basically is something that we take a look at when we're trying to understand what is the data that we have. X are the values that we want to use to make the prediction. Y is the thing that we want to predict. So with that in mind, we take the data and then we split it into training and testing. So we already have some testing data, but what we're doing here, we're trying to create a little more testing data to check on a small piece of data first. So that's what we're doing. We're converting into training and testing data with 20% of the data set to testing and 80% of the data set for training. As we have 9 lakh rows, then it's quite easy for us to do 10 or 20%. If we had smaller data like 1 lakh or 50,000, then we would do something like 30% and 70%, or 75 and 25%. Now comes the interesting part. We create a machine learning pipeline or a data science pipeline in which we describe the process. So what we do, we use the standard scaler. What it does is that it removes the outliers for us, and it converts the data into a normal form so that it's easier for us to crunch through the entire data set, and it's easier for us to calculate the things that we want to calculate. And we'll be using the random forest regressor here. So convert the data into a standardized format, and then use the regressor to create a random forest regression tree. So in the pipeline, we fit the training and testing data. So we get the training data, the values that we want to make the prediction, and the values that are going to be predicted. And then we make the prediction on the testing data that we had already set aside. Now we make the prediction, and we take a look at the accuracy, and we have 95% accuracy, which is quite good. To be quite honest, any data, any large data sets that you get output for, and you get around 80% or above 80% is quite a good thing, because for a machine to be able to learn all of these patterns and then be able to predict things at an accuracy of about 80% is quite good. Ours is 95.4%, which is quite good. And now we use the test data that we had already gotten from Kagan. We make the predictions. We convert it into a data frame using the pd.dataframe format. And here we have it. We add the forecast ID, and we get the target values. So here we have it. And this is what the data frame looks like. So as you can see, for the first value here, we'll be getting the value of 106.6. So, and the second value will be getting 5.2. So it means that for the first day, we'll be getting 106 confirmed cases and 5 fatalities. Now, these values are in floating point numbers or in decimal format, and that's because we're trying to predict continuous values. So you could get decimals, but we could just round them. So 107 and 5, 107 and 1, and 155. So these are the values that we have gotten. And using these values, what we can do is now we have calculated what the training data has given us to do. So we created a model, and now later on, if we get some data, then we will use that data to make the prediction. We just have to pass it to our model here. Instead of test, we just have to pass in one value. And what it will do is that it will make the prediction, and it will give us the prediction. When we get the first value as the thing that is the confirmed cases, and the second value would be the fatalities. So we'll be making the progress like that. Now, again, as you've seen, we didn't have to use a lot of mathematics in this case. It's mainly because that
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.
for solving normal problems, you don't need a lot of mathematics. So with that, we've come to the end of the hands-on.
So, a fraud by definition is an act of deception that is used illegally to deprive a person or an organization or entity of money, property, or legal rights. So, if we talk about financial frauds, which are the most common type of frauds, so a typical organization loses around 5% of their yearly revenues to fraudulent cases. And according to an RTI report, there were around 2,480 cases of frauds in 18 public sector banks, which involved around 32,000 crores. And according to an RBI report, in 2017 and 18, a total of 911 credit card fraud cases were there, which amounts to around 65 crore rupees, which were illegally transferred from different bank accounts. So now let's discuss some of the types of frauds that we can encounter in our daily lives. So the most common types of frauds nowadays are online frauds, where a person's account may be hacked and all his money can be transferred to different accounts illegally. And the most common types of frauds nowadays are the credit card frauds, where stolen credit cards and credit card numbers are used to make illegal transactions. And then we have threats and theft of inventory when someone breaks into a bank or an ATM. And then we have other types of frauds where someone can steal your idea or your professional work. So now that we know what are frauds and what are the different types of frauds and how they can affect different organizations and how important it is to detect the frauds and save ourselves from heavy losses. So now we'll discuss some of the rule-based approaches or traditional approaches that are used for detecting frauds. So in the rule-based approaches, the algorithms are actually written by fraud analysts, and these are based on strict rules. So if there are any changes that have to be made for detecting a new type of fraud, so they are all done manually. So either by making those changes in the already existing algorithms or by creating new algorithms. So in this approach, whenever there's an increase in the number of customers and the data, the human effort also increases. So in conclusion, we can say that the rule-based approaches are time consuming and they are costly. So now let's discuss some of the drawbacks of the rule-based approaches. So one drawback of the rule-based approach is that it is more likely to have false positives. So this is a type of error condition where the output of a transaction, it depends upon the rules and the guidelines that we have made for the training algorithm. So if you have a fixed rule and a fixed threshold, and if a transaction is rejected where it should not be rejected, so it will generate a condition of high rates of false positives. So these false positive conditions actually result in losing a lot of genuine customers. So our rule-based approaches cannot recognize hidden patterns since all of the rules are mentioned by the fraud analyst, and it cannot also predict new types of frauds because it always abides the rules that are mentioned by the fraud analysts, and that leads us to a situation where it cannot respond to new situations which is not trained on or it is not explicitly programmed on. So now that brings us to our next topic, that is how we can use data science to solve these problems and use data science for fraud detection. So the modern alternative is to leverage the vast amounts of big data that is collected from different online transactions and model it in such a way that allows us to flag or predict fraud in the future transactions. So for these different data science techniques such as machine learning and deep neural networks are the obvious solutions. So here I'm going to show you an example of how machine learning techniques can be used to identify fraud in financial transactions. So machine learning is a broad field. It has a large collection of algorithms and techniques that are used in classification, regression, clustering, or anomaly detection. So two main classes are supervised and unsupervised learning. So in supervised learning, it is used to predict either the values of a response variable, which is also called regression, or the labels of a set of predefined categories, which is also called classification tasks. So in supervised learning, the algorithms learn how to predict unknown samples based on the data of samples with known response variables and labels. So in fraud detection, we are technically dealing with the classification task. So for each sample, that is a transaction, the predefined labels tells us whether it is a fraud transaction or not. So however, there are two main problems while using supervised learning for fraud detection. So the first problem is data labeling. So in many cases, fraud is actually difficult to identify and some cases will be obvious. Some cases will be easy to recognize with rule-based techniques, and they usually won't require complex models. So where it becomes interesting are the subtle cases. So they're hard to recognize as we don't usually know what to look for. So here we use the power of machine learning, but because fraud is something that is hard to detect, so our training data sets that is collected from the past transactions are probably not classified correctly in many of these cases. So this means that the predefined labels will be wrong and some of the transactions will be wrongly labeled. So in this case, our supervised machine learning algorithms won't be able to learn how to find these type of transactions or these type of frauds in the future transactions. And the next problem that we face is the unbalanced data. So an important characteristics of fraud data is that it is highly unbalanced. So this means that one class is much frequent than the other. So in a fraud detection example, less than 1% of the transaction will be fraudulent. So in most of the cases, you will find that less than 1% of all the transactions are fraud transactions, and most of the supervised machine learning algorithms, they are actually very sensitive to unbalanced data. So we have to use different techniques to balance the data before we actually use the supervised machine learning algorithms to predict the fraud cases in the future. So the next class of problems that we can solve using the unsupervised learning. So it does not require or predefined labels or response variables. So it is used to identify clusters or outliers or anomalies in the datasets. So in our fraud dataset, we don't trust the predicted labels to be 100% correct. So since there will be a lot of incorrect labels as well, but we can assume that the fraudulent transactions will be sufficiently different from the vast majority of regular transactions, so that our supervised learning algorithms will flag them as anomalies or outliers. So in supervised learning, we can use the dimensionality reduction, which is also called a type of dimensionality reduction is called principal component analysis. So in preparation for our machine learning analysis, dimensionality reduction techniques are very powerful tools, and they are used to identify hidden patterns in the data. And whenever we have high dimensions in the data, so it is better to use PCA so that we can reduce the number of features for machine learning while preserving the most important patterns of the data. And similar approaches can be used, such as clustering algorithms, and like K-means clustering can also be used to find the patterns in the data using number of clusters. So in this video, we are going to use the supervised machine learning model on our data set so that we can predict future fraud transactions. So now let's discuss some of the challenges that we'll face while building a machine learning model on our credit card dataset. So various challenges arise when building models for fraud detection. So the first challenge is the unbalanced data. So there are plenty of legitimate cases, but only a very few fraudulent cases. So for example, in a credit card transaction, typically less than 0.5% of the transactions are fraudulent. So it might cause an analytical technique to experience difficulties in creating an accurate model. And depending on the exact application, operational efficiency may be a key requirement. So the fraud detection system might only have a limited amount of time available to reach a decision. So in a credit card fraud detection setting, the decision time to let a transaction pass or not is typically less than 8 seconds. And also incorrect flagging. So when flagging a particular transaction, if the transaction is flagged as fraudulent for a good customer, so you risk losing this customer due to the harassment caused by flagging the transaction as fraudulent. So now let's discuss some of the techniques that we can use to solve the first type of challenge, that is unbalanced data. So here you will find that most of the cases in a data set, most of the transactions will be legitimate transactions and very less transactions will be fraudulent transactions. So if you train your classifier model on this, so your classifier will tend to favor the majority class, that is your legitimate transactions. So which results in large classification error over the fraud cases, since it has not learned much because of the less data available to it. So the classifiers actually learn better when it is trained on a balanced distribution rather than an unbalanced data. So now we'll discuss sampling methods to solve this unbalanced data problem. So we always perform the sampling methods on the training set, not on the test set. So we'll always divide our data set into two sets, that is our training and test sets. So we'll build our model on the training set, and before building the model, we'll balance the training set so that our model learns on the training set, and then we'll use the original test set, which is the unbalanced test set, to predict whether a transaction is fraudulent or legitimate. So the first technique is called the random oversampling technique. So in this technique, we oversample the minority class, which is our fraud cases. So we copy the cases that are already present in our fraudulent cases. So we'll just copy the same cases multiple times till we reach a particular threshold or the value of the cases that we want in our dataset. And the other technique that we can use is the random undersampling. So in this technique, we undersample the majority class, which is our legitimate cases. So we remove some of the cases that are present in our dataset, which are from the legitimate transactions. So we'll remove some of those cases, and then we'll downgrade some of those cases till we have a dataset that has an equal distribution or an almost equal distribution of both the fraudulent and the legitimate cases. Or we can do both, so either we can up sample or we can down sample. So now let's discuss some of the techniques that we can use to solve the first type of challenge, that is our unbalanced data. So you'll find that most of the data sets have most of the transactions as legitimate and very few transactions as fraudulent. So if you train your classifier model on this particular dataset, so our classifier will tend to favor the majority class, that is the legitimate cases. So which results in the large classification error over the fraud cases, since it has not learned much from the fraudulent data, because the data that was available to it was very few. So now let's discuss some of the techniques that we can use to solve the first type of challenge, that is our unbalanced data. So you'll find that in most of the data sets or legitimate cases, they're outnumbered. So now let's discuss some of the techniques that we can use to solve the first type of challenge, that is our unbalanced data. So you'll find that in most of the data sets, most of the transactions are legitimate transactions, and there are very few transactions which are fraud transactions. So if you perform a classification model on top of this dataset, your classifier will tend to favor the majority class, that is all legitimate cases. So which means that it will show a huge classification error over the fraud cases. So classifiers actually learn better from a balanced distribution. So if you train or model on a balanced distribution, it is more likely that we have a less classification error for our fraud cases, and it will be easily available to us. So now let's discuss some of the techniques that we can use to solve the first type of challenge, that is our unbalanced data. So you'll find that in most of the data sets, most of the transactions are actually legitimate transactions and very less transactions are fraud transactions. So if you create your machine learning model on this type of data set, your classifier will tend to favor the majority class, which is your legitimate transactions, and which will result in large classification error over the fraud cases. So our classifiers or our machine learning models, they learn better from a balanced distribution where the balance of the two classes, that is legitimate and fraud, can be equal. So now let's discuss some of the methods that we can use to solve the first type of challenge, that is our unbalanced dataset. So you'll find that most of the datasets, they have large number of legitimate cases and very few fraudulent cases, since in credit card transactions, less than 0.5% of the transactions are fraudulent. So our classifier or our machine learning model will tend to favor the majority class, that is our legitimate cases. So which means that it will show a large classification error over the fraud cases, will not be able to identify which case is fraud or not. So our classifiers actually learn better from a balanced distribution instead of an unbalanced data. So now let us discuss different sampling methods used to balance an unbalanced dataset. So the first technique is called the random oversampling. So in random oversampling, we increase the number of fraud transactions in the dataset by creating duplicates of the already present fraud cases. And the next technique is called the random undersampling. So in random undersampling, we decrease the number of legitimate cases to get a balanced distribution. And also we can perform both random oversampling and random undersampling by increasing the number of fraud cases and decreasing the number of legitimate cases. So now this is how our dataset will look like after performing both the oversampling and the undersampling. But the problem with oversampling is that it is done by creating duplicates of the fraud cases that are already present in our dataset. So that means that we will be training our model using a lot of duplicate values, which won't explain the variance in the data. And the problem with undersampling is that we end up throwing away a lot of useful data and information which is not preferred in general. So that brings us to our next sampling technique, which is called the synthetic minority oversampling technique, aka SMOT. So in this technique, we oversample the fraud cases by creating synthetic fraud cases. So if you look at the scatter plot at the right hand side, the green dots here represent the legitimate cases and the red dots here represent the fraud cases. So in SMOT, we find the k nearest neighbor of a fraud case, let's say x here, and let's take the value of k as 3, so we'll find the 3 nearest neighbors of x. And after choosing the nearest neighbors, we'll randomly choose one of the x's nearest neighbors, let's say y here, and then we add a synthetic sample using the following method. So we'll take the x and the y coordinate of both the points and find the x and the y coordinate of a synthetic point, which is given as follows. So the synthetic point will lie on the line that joins both x and y, and here the number 0.3 it is a random number between 0 and 1. So we can use different numbers between 0 and 1 so that we get different synthetic samples that are present on the line that joins x and y. And we can also repeat this step multiple times for each neighbor of x, which is a fraudulent case, to get a desired value of the fraud cases in our dataset, and hence we'll get a balanced dataset after all. So now let's go to RStudio to implement credit card fraud detection model using SMOT. So now let's build a fraud detection model in R. So first of all, we'll import the dataset that we are going to work on. So I've stored my dataset in this particular folder. So once I load this dataset using the read.csv function, and I'll store the dataset in credit underscore card data frame. So if I run this line, your dataset will be imported, and after importing the dataset, we'll look at how our dataset looks like. So after your dataset is imported, you can click on the dataset name in the variable explorer, and once you click on the name, you will find that our dataset contains 284807 entries, that is rows, and around 31 columns. So this dataset is about different transactions made by different credit card users, and the first column here you can see is the time. So this is the time stamp, and then we have columns from V1 to V28. So these columns are actually the reduced versions using the dimensionality reduction. So the actual dataset contains the actual columns which the dataset does not contain. So these are actually the reduced versions using the PCA, so that the confidentiality of the users is maintained. So these are different features that are extracted from the actual features using the dimensionality reduction. So after the 28th column or the 29th column, we have the amount column that represents the amount of transaction that was done using this particular credit card. And then the last column here you can see is the class column, which contains two values, that is 0 or 1. So 0 here represents that the transaction was a legitimate transaction, and 1 represents that the transaction was a fraud transaction. So after that, let's look at the structure of the dataset and see what are the different types of variables that we have in our dataset. So if you use the structure function and write the name of your dataset, that is credit card, so you'll see we have around 31 variables, that is columns, and most of the variables are numerical columns. And the last column here you can see is class, which is also an integer column, but in actual it is not an integer column, it is a categorical column. It has two categories, that is 0 and 1, and 0 here represents the legitimate transactions and 1 represents the fraud transactions. So first of all, we will convert our class column to a factor column, two levels, that is 0 and 1, so that we can work with our dataset later on. So we'll convert this to a factor column using the factor function, and I'll pass the name of the variable, that is credit card $class, and then we have two levels, that is 0 and 1, 0 for legitimate cases and 1 for fraud cases. So we'll again store it in the same variable, that is credit card $class. So once you run this function, if you now look at the structure of the dataset, so you will see now our class column is a factor column with two factors, that is 0 and 1. 0 here represents the legitimate transactions and 1 represents the fraud transactions. So now let's look at the summary of the dataset to display the summary statistics of different columns. So here you can see the last column is a class column. So here around 284315 entries are legitimate cases, that is 0, and only 492 entries are your fraud cases, that is 1. And then we have most of the columns are integer columns with mean of 0, and the first column is our timestamp. So now before moving ahead, now let's check whether there are any missing values in our dataset or not. So we'll use the is.na function to check whether there are any missing values in our dataset or not, and then the sum function will count the number of missing values if there are any. So once we run this function, we'll see that we don't have any missing values in the dataset, so it is okay for us to continue and work with our dataset. So now we have to use the class column. So first of all, let's see how many fraudulent and legitimate transactions are actually there in our dataset. So we'll get the distribution of fraud and legitimate cases or legitimate transaction in the dataset. We'll use the table function, and inside the table function we'll write the variable that we want the distribution for. So our variables or the transactions are stored in class variable in our credit card dataset. So we'll use the table function to get the distribution of different transactions. So here, after running this command, here you can clearly see that 0 represents the legitimate transactions, and most of the transactions in this dataset are legitimate transactions. So there are around 284315 legitimate transactions and only 492 fraud transactions. And if you want to get the percentage of the transactions, you can use the prop table function, and then inside the prop table function you can write the table function, which will get you the distributions, and the prop table function will get you the percentages of the distribution. So here you can see that 99% of the more than 99.82% of the transactions in this dataset are legitimate transactions, and only 0.001% transactions are fraud transactions. So clearly we can see this is an imbalanced dataset. So now let's also plot a pie chart to get the distributions of our legitimate and fraud cases in our dataset. So we'll firstly set the labels of our pie chart. So the labels are legit and fraud. So we'll create a vector that contains two strings, that is legit and fraud, and we'll store that in labels. And after that we'll paste or we'll concatenate the percentages of your fraudulent cases and legitimate cases with the respective labels. So if you pass two vectors in the paste function, so first we'll use the paste function to concatenate two strings. So we'll first vector that we have passed is the labels, which contains two values, legit and fraud, and then we'll pass the round function. So this function will actually calculate the percentages of the distributions. So we'll calculate the percentages of the prop table that we have just seen above, which will display this particular result, and we'll multiply it by 100 to get the percentage, and then we'll round this percentage to 2 digits. So we'll only get 2 digits after the point. So we'll use the round function, which will contain our percentages up to 2 digits of decimal, and then we'll have the labels which contains your two strings, that is legit and fraud, and we'll paste it together and we'll store the result in labels. So if you run this command and I look at the labels right now, so now your labels actually look like this. We have a 99.83%. so here we have rounded the values up to 2 decimals using the round function here, and the fraud cases are 0.1% and legit cases are 99.83%. So clearly we can see there is an imbalance in our data set. So let's plot a pie chart first of all to get the distribution or display the distributions of our legitimate and fraud cases. So we use the default pie function from the default R package, and we want a pie chart for the different distributions of the different categories of the class variable in our credit card data set, and we'll use the table function to get the different distributions of the categories, and our labels will be equal to these labels, and then the color of the labels will be according to the orange and the red. So the orange will represent the number of legitimate cases and the red represents the number of fraud cases. And then this is the title of our pie plot. So our title will be pie chart of credit card transactions. So let's run this command to get a pie plot. So this is our pie chart for our credit card transactions, and here you can see most of the color is orange. It means we have around 99.83% of the legitimate transactions and only 0.17% are fraud transactions. So now if you make a model on this particular data, so you will get most of the accuracy. So we'll first of all make a model that is no model. So even if you don't have any particular machine learning model, and if you predict that every single transaction in this data set is a legitimate transaction, so you can see what kind of accuracy we'll get. So first of all, we'll predict that all the transactions in this data set are legitimate transactions. So we'll store our predictions in predictions variable, and we'll repeat integer 0 equal to the number of rows that are present in our credit card dataset. So in our credit card dataset we have around 284807 rows. So we'll create a vector that will contain zeros 284807 times. So after creating a vector, we'll convert this vector to a factor variable with two levels, that is 0 and 1. Here 0 represents the legitimate transactions and 1 represents the fraud transactions. So we are predicting without using any model that all the transactions are legitimate transactions. So once you run this command, we'll factor out or we'll convert this particular vector to a factor with two levels, that is our legitimate transactions and fraud transactions 0 and 1. So after that, we'll use the confusion matrix to get the accuracy for this particular predictions or that we have done without using any particular model. So we'll use the caret package. So if you have not installed this package, you can use the install.packages command and write the name of your package to install it. And then after installing the package, you can load the package using the library function. And once you run this command, your package will be loaded, and then you can use the confusion matrix function from the caret package to get the confusion matrix and the accuracy. And if you want to know more about this particular function, you can press F1 here, so it will take you to the documentation on the right hand side, and then you can know more about this particular function. So in this function, we'll firstly pass our predictions that we have stored in predictions variable as data, and then we have our reference variable, which will contains the actual classes that we have predicted. So we have predicted the classes of the credit card dataset. We will pass our reference variable or the actual classes that we have predicted. So once we run this command, we'll get the confusion matrix for this particular model that we have built without using any machine learning model. So here you can clearly see that we have correctly classified all the samples that were all the transactions that were legitimate transactions, but we have not classified any of the transactions that was a fraudulent transaction. So still we get an accuracy of 99.83% because we have flagged every transaction as a legitimate transaction and we have not flagged all the fraud transactions as fraud transactions. So this will be your true positives and this will be your true negatives, which are the correctly classified values. So our true positives are total and our true negatives are 0. It means we have wrongly classified all the samples that were fraudulent transactions. Here your 0 represents legitimate transactions and 1 represents your fraud transactions. So out of all the fraud transactions, we have flagged all the transactions as legitimate transactions, which are false positives. So here you can clearly see that if you only check the accuracy of the model that we built, so we'll be wrong most of the times because here accuracy does not represent anything. Here our goal is to maximize the number of cases or maximize the true negative so that we can classify most of the fraud transactions as fraud transactions. So now let's move ahead and build a model. So before moving ahead, we will take a small subset of our dataset so that it is computationally more faster. And later on, once you have built a model on the smaller subset that you can make, then you can make the model on the whole dataset, which will take some time. So we'll take a smaller version of the dataset so that we can compute it faster. So we'll use the dplyr package to get a small fraction of our whole dataset, that is credit card. So I'll load the dplyr package first of all. So after loading the dplyr package, I'll use the sample fraction function, sample frac function, to get the fraction of our dataset, which will be random fraction. So it will contain both zeros and ones, and I'll pass my credit card dataset using the forward pipe operator, which will pass my credit card dataset to the sample frac function, which will extract 0.1%, that is 10% of the samples or 10% of the rows that are present in our dataset. So right now our dataset contains 284807. So after extracting 10% of the rows, it will be 28,480 rows. And we'll store the result in our credit card data frame again. And we have used the set seed function. So if we run this particular code again, so we'll get the same sample again. If you don't use the set seed function and you run this code again and again, so your sample will be different every time. So we'll run these two lines together and we'll get a sample that will be 10% of all the rows that are present in our actual data set. So now let's look at the data set. That is a fraction, that is a subset of our original data set. So we have around 28,481 rows and all the columns. So this is a 10% of data set, and then we'll make a model on this particular data, and after building a model later on, we can build the model on whole data set. So now let's see what is the distribution of classes that we have in this particular data. So right now we have around 28,437 transactions as legitimate transactions and only 44 transactions as illegitimate or fraud transactions. And now let's plot a scatter plot between the two columns, that is V1 and V2. So we'll plot a scatter plot between the columns V1 and V2, and we'll see what is the distribution of classes between these two variables. So we'll use the ggplot2 function to plot a scatter plot. So firstly I'll load the ggplot2 library, and after loading the ggplot2 library, I'll use the ggplot function to plot a scatter plot. So ggplot function is based on grammar of graphics, so it has different layers that we stack upon each other to build a final plot. So our first layer is our data layer, where we pass our data frame. So our data frame is our credit card data frame that we have just extracted from the whole data frame. And then we have our second layer as the statics layer. So in the statics layer, we have our variables that we want to plot on our scatter plot. So on the x-axis we have our variable v1, and on the y-axis we have our variable v2. And we want the color of the points of the scatter plot according to the different categories of the classes. So we'll have two categories in the classes, that is 0 and 1. So we'll have two different colors for each particular category. And then to plot a scatter plot, we'll add the third layer using the plus sign here. So our third layer is our geom layer. So in the geometry layer, we'll pass our function that we want to plot scatter plot for. So here if we want to plot a scatter plot, we'll pass geom underscore point. So it will plot a scatter plot for us. And then if you want to change the background of your plot, so we can use the theme function. So theme BW, that is black and white. So it will make the background of your plot as black and white. And then you can also change the color of the points. So to here, this will get you the basic plot that we want. So if you zoom in on this plot, you can see that this particular color represents our legitimate cases, and our blue color here represents our fraud cases. So if you want to change the background of this particular plot, so you can use the theme function, which will change the background to black and white. And if you want to change the color of these points to different colors, so we can use the scale color manual function, and inside of that function we can declare our values. So our values of the colors are dodger, blue 2 and red. So now this color represents the 0, that is legitimate cases, and red represents the fraud cases. So now let's run the whole command and we'll get the final plot, black and white background and these colors as the color of the points. So if you zoom in on this particular plot, you will find that now this particular color Dodger blue 2 represents all legitimate cases, and our red color represents all fraud cases. So here also clearly you can see that we have a comparatively huge number of legitimate cases and only a few fraud cases. So if you train your model on this particular data, our model will not be able to learn a lot because the number of fraud cases are very less. So we have to use different techniques to balance the dataset before we actually make or build a model on this particular data. So before balancing the dataset, we'll first of all create training and test sets. So we only use balancing on the training set to train the model, and we don't use balancing on the test set because that will be the original test set that will predict values for. So first of all, we'll create training and test sets, and then we'll balance the training set and train our model, and then evaluate the performance of the model using the test set. So now let's build our training and test sets for the fraud detection model. So we'll be using the CA2's library. So if you have not installed this library, you can use the install.packages and the name of the library to install it. And after installing this library, you can use the library function to load the library, and after loading the library, we can use the sample.split function to split our dataset into two sets, that is training and test sets. So in the sample.split function, if you want to know more about this function, you can press F1 here. So it will take you to the documentation on the right hand side. So now if you want to split your dataset into training and test sets, so here we'll pass our column that we want to split according to. So since we are going to predict whether a transaction is a fake transaction or a legitimate transaction, so that column is a class column that represents zeros and ones. So we'll use the class column to split our dataset into training and test sets. So I'll pass the column, my class column, from the credit card dataset, and now I'll mention the split ratio, which will represent how many rows I want in the training set and how many rows I want in the test set. So if you write split a ratio equals 0.8, so 80% of the rows that are present in your dataset will be in the train set, and 20% of the rows that are present in your dataset will be in the test set. So if you run this particular line, and we'll store the result in data sample. So once you run this line, and if you look at the data sample now, so it will contain true and false values. So here the true values will be 0.8. So 80% of the values here will be true and 20% of the values here will be false. And these number of values will be equal to the number of rows that we have in our dataset. So now we'll use this particular object to split our dataset into two sets using the subset function. So we'll use the subset function on our credit card dataset, and we'll check wherever the sample value is true. We'll store all those rows in train data. So after running this line, our 80% of the rows from the credit card dataset will be in the train data, and wherever the data sample value is false, we'll store all those rows in the test data. So 20% of the rows in the credit card dataset will be in the test data. So now let's run all these lines together. So now we have successfully created our train data and test data. So now let's click on the train data in the variable explorer to see how many rows are there. So we have around 22,785 rows in our training data. That is 80% of the rows of the whole dataset. And then if you look at the test data, so we have around 5,696 rows in the test data and all the columns. So we'll train our model on the train data after balancing this data, and then we'll test the performance of the model using confusion matrix on the test data. So now if you want to check the dimensions of your training and test data, you can use the dim function. So it will display the dimensions. So our training data contains 22,785 rows, and our test data contains 5,696 rows, and all the columns, that is 31 columns. So now before making a model, we have to balance our data set first. So we'll use different techniques. So the first technique that we're going to use is called the random oversampling, which means that we will increase the number of fraud cases in our data set. So we'll oversample the minority class. So right now, if you look at the distribution of the class variable, you can see around 22,750 transactions are legitimate transactions and only 35 transactions are fraud transactions. So now if you want to increase the number of fraud transactions, so we'll use this particular method. So first of all, we'll write how many, we'll store our number of rows in our dataset or number of legitimate transactions in our dataset in nlegit variable, and then we'll store the number of fraction or the amount of fraction that we want for our fraud cases. So if we want our fraud cases to be 50% of the whole dataset using the random oversampling, so we'll write 0.50 and we'll store the result in new fraction legit. So now this fraction will be 50%. So our in our final data set, after performing the random oversampling, the 50% of the rows will be your legitimate transactions and 50% of the rows will be fraud transactions. Now if you want to calculate how many rows should be there in our data set to accumulate both of the legitimate and fraud transactions as 50%, so we'll divide the number of legitimate cases by the fraction, and it will tell us how many rows we want in our data set to balance our legitimate and fraud transactions as 50-50%. So after dividing the number of legitimate cases by the fraction, we'll get the number of rows that we want in our data set. So if you run this function, we have stored the number of rows in new and total. So if you click on new and total, so you'll find that we need around 45,500 rows in our data set, and out of these rows, 50% of the rows or 50% of the cases will be fraud cases and 50% of the cases will be legitimate cases. So now to perform random oversampling, we'll use a package called rows. So if you have not installed this package, you can install the package using install.packages function and then write the name of the package that you want to install. And after you have installed the package, you can use the library function to load the package so that you can use the functions that are included in this package. So in this package, you're going to use the oven.sample function, which will help us to perform random oversampling. So if you want to know more about this function, you can press F1 here. So it will take you to the documentation of this function. So in this documentation, you can see the first argument that we want is our formula argument. In the formula argument, we have to mention our variables that we want to oversample. So here our class variable is the variable that we want to oversample, and then we have used the dot, which means the rest of the variables are independent variables, and this tilde sign is used to separate our independent and dependent variables. So our class is our variable that we want to oversample or that we will predict later on, and we'll use all of the variables in our dataset except the class variable, which we can mention using the dot symbol here. And after the second argument is our data argument, so it will require the data that we want to oversample. So our data comes from trained data that we have just created above our training set. And the third argument here you can see is our method argument. So if you go to the documentation, you can see that we have three methods, that is over, under and both. So firstly we'll perform the oversampling of the minority samples. So we'll use method equals over, and then we have our n argument, which will be the number of rows in the new dataset after the oversampling is performed. So that is equal to the number of new and total, which is 45,500 rows. And then we will also use the seed function so that if we run this code again, so we will be getting the same sample again or the same number of oversampled rows again and again. So let's run this function now to get our oversampling result. So after running this function, if you just click at the variable that has been created, so here you can see we have different attributes of this variable, that is oversampling result. So our data is actually stored in the data attribute. So if you want to reach the data attribute, you can use the oversampling data and then the data attribute, and we'll store the data set in oversample credit. So if you store the result in oversample credit, and now if you look at the distribution of the classes that we have after random oversampling, so you will find that we have 22,750 legitimate cases and 22,750 fraud cases. So now the distribution of our fraudulent and legitimate cases are equal using the random oversampling. So before moving ahead, let's plot this distribution using the same V1 and V2 columns of our oversampling result. So now if you click at the oversampling credit, so this is our oversampling credit, we have 45,500 rows. So let's plot a scatter plot between V1 and V2 and see what is the distribution of classes between these two variables. So we'll use the ggplot function to plot a scatter plot again. So here now our data comes from oversample credit here, and then we have the variables v1 on the x-axis and v2 on the y-axis, and the color of the points will be according to the categories of the class column, that is 0 and 1. And then we'll use the geom function. So if you want to plot a geom, so if you want to plot a scatter plot, we'll use the geom point function, and then the theme of our plot will be black and white using the theme function, and the color of the points will be dodger blue and red. So if you want to change the color, you can use this scale color manual function. So once you run this command, you will get a scatter plot between v1 and v2 that represents your oversampled data set that we have just created using the rows package. So now if you zoom in here, you will find that we have the blue color or the dodger blue color as class 0, which is the legitimate cases, and the red will be our fraud cases. So here you can see still our points do not represent a lot of points compared to the blue points. So the reason is that in our random oversampling we create duplicate points, so most of these points are overlapping on each other, because we in random oversampling will just create duplicate points that are already present in our dataset. So if you want to know whether there are points overlapping on each other or not, so we'll add some jitter to these points. So once we add some jitter to these points, so you'll see that there will be a lot of points in these on top of each other because we have just created duplicate points using the random oversampling. So to add jitter to the points, we'll use the position argument of the geom point function. So if you set your position argument to position jitter, and inside the position jitter function we can mention our width of the jitter that we want. So if you write 0.1 here, so now if you run this function, you'll find that there will be a lot of points that are overplotted or stacked upon each other because we have just created duplicate points using the random oversampling. So now here you can see the points. When you add some jitter, you will find there are a lot of points that are stacked up on top of each other because we have just performed the duplicate values. We have just increased the number of duplicate values using the random oversampling. So now let's perform our random undersampling. So in random oversampling, we just train our model on duplicate values, which is not a good condition. So we'll see what is random undersampling. So in random undersampling, we'll reduce the number of legitimate cases. We'll keep the legitimate cases equal to the number of fraud cases. So let's first of all see the distribution of our credit card dataset. So we have this distribution. We have around 22,750 legitimate cases and only 35 fraud cases in our training set. So now if you want to set the number of legitimate cases equal to the number of fraud cases, so we'll use this method. So first of all, we'll store the number of fraud cases in n fraud, and then we'll calculate we'll store the fraction that we want for our fraud cases or our legitimate cases. So we want the number of fraud cases equal to 50% of the whole data. So we'll store that in n frac fraud, and then we want to calculate the number of rows that will be in our data set so that our fraud cases and legitimate cases are equal in number. So we'll divide the number of fraud cases by the fraction that we want our fraud cases to be in, that is 0.5. So once we divide it, we'll get the total number of rows that we need in our data set to satisfy this fraction. And once you run this particular command, so if you look at your new total, so now our data set will contain 70 rows, and out of the 70 rows, 35 rows will be number of legitimate cases and 35 rows will be number of fraud cases. So now let's use the o1.sample to create that particular data. So we'll use the same o1.sample, and now instead of mentioning the method as over, we'll write method as under, and then all of the arguments are same. So you just have to change the method, and once you run this particular function or particular command, so now your undersampling result will be calculated. And now if you want to get to the data set that is stored in undersampling result, so we'll get the dataset attribute or the data attribute of the undersampling result, and we'll store that in undersampled credit. So once you run this line, you will have your dataset that is undersampled credit. And if you look at your dataset right now, so we have around 70 rows, and out of these 70 rows, 35 rows will have legitimate cases and 35 rows are fraud cases. So now let's plot scatter plot between same v1 and v2 to see how our distribution of the points look like and the distribution of the classes look like between these two variables v1 and v2. So if you plot it now, so you'll see that now we have equal number of legitimate cases and fraud cases. So in random oversampling, we decrease the number of legitimate cases to a certain ratio so that we have more, or we have an equal distribution of legitimate and fraud cases. But the problem here is that we end up losing a lot of data which is not preferred in a general case. So now we'll perform both the random oversampling and undersampling to see how our data actually looks like. So now we'll perform both random oversampling and undersampling. So now the number of rows that we want in our dataset will be equal to the number of rows that are present in our training set. So our new dataset will also contain the same number of rows, that is 22785. And now we want our fractions of the legitimate and fraud cases equally in our dataset. So out of the 22,785 rows, 50% of the rows will be fraud cases and 50% of the rows will be legitimate cases. So we're not going to increase or decrease anything. We're just going to resample our dataset in such a way that 50% of the rows will be fraud cases and 50% of the rows will be legitimate cases, using both random oversampling for increasing the number of fraud cases and random undersampling to decreasing the number of legitimate cases. So after storing our fraction in the fraction of fraud new variable, we'll use the same o1.sample. So now we have used the method as both. So here if you want to perform both random oversampling and undersampling, you can use the method as both. And then the n argument here is the number of rows that we want in our new dataset, and then the p is your probability of fraction. So if the method is both here, so the probability will be default by 0.5. So 50% of the rows will be your legitimate cases, and 50% of the rows will be fraud cases. And then we have used the seed function so that we get the same sample again and again if you run this code again. So now if you run this code and if you get to the data set using the data attribute of the sampling result, you will store that data set in sample credit. Now let's look at the data set. So we have around 2785 rows, and out of the 22,785 rows, you can see around 11,430 rows are legitimate cases and 11,355 rows are fraud cases. So if you want to get the percentages of these rows, so you'll get around 50% of the data are legitimate cases or legitimate transactions, and 49.8% are fraud transactions. So now let's plot a scatter plot between V1 and V2 to see how our class distribution looks like. So I've already added some jitter so that we can see the overlapping of the points, because we have performed random oversampling and undersampling both. So we have reduced some number of legitimate cases and we have increased some number of fraud cases. So now they are in equal ratio, but the number of fraud cases are overlapping on each other because they are duplicates of each other, and the number of legitimate cases are scattered on whole of the plot. So now let's move ahead and use the third method that we use, which is called the SMOT, which is the synthetic minority oversampling technique, which will add the synthetic samples in our dataset without actually creating duplicates of the fraud cases. So to implement SMOT, we use this library called SMOT family. So if you have not installed this library, you can use the install.packages and the name of the library to install it first. And then after installing, you can use the library function to load the library to use the functions that are contained in this library. So after loading the library, if you look at the class distribution, we have the same class distribution, that is 22,750 are legitimate cases in our trained data and 35 are the fraud cases in our trained data. So now we want to increase the number of legitimate cases, or we want to add synthetic samples of the fraud cases so that we have a balanced data set that we can use to train our model. So we'll start by first of all setting the number of fraud and legitimate cases and the desired percentage of the legitimate cases that we want in our dataset. So our legitimate cases are represented by N0 here. So we have around 22,750 legitimate cases, and N1 are the fraud cases. So we have around 35 fraud transactions, and then R0 represents the ratio that we want in our dataset after the SMOT. So we want 60% of our rows should be legitimate cases and 40% of the rows will be fraud cases. So we'll add synthetic samples in such a way that after adding the synthetic samples, our data set has 60% of the legitimate cases and 40% of the fraud cases. So now to get the number of times that we have to perform SMOT to get the desired number of ratio of the legitimate and fraud cases, so we'll use this SMOT function first of all from the SMOT family. And if you want to know more about this function, you can press F1 here. And you can see we have different arguments, that is x, which is our data that we want to apply SMOT on. Then we have our target value, so the vector of the target class attribute corresponding to our dataset x. So our x will be our independent variables, and our target will be our dependent variable that we are going to predict later on. And k is the number of nearest neighbors we want during the sampling. And then we have our dupe size, so it will be the number of times we run our SMOT, or number of times we want to run our SMOT to add different synthetic samples. So if you want to get the number of the dupe size, which will actually tell us how many times we have to run SMOT in order to get the desired percentage of all legitimate and fraud cases, so we'll use this formula. So this formula will help us to get the number of times we have to run SMOT in order to get a percentage of synthetic cases such that our final data frame contains 60% of the legitimate cases and 40% of the fraud cases. So using this formula, which contains both R0, N0 and N1, once you run this here, and before running this we have to run these three together, and after that if you run this, so if you now look at the number of times, so we'll get we have to run 432 times. So after running 432 times on the SMOT, we'll get to a value of your variables in such a way, or value of the points in such a way that 60% of the points will be flagged as legitimate transaction and 40% will be fraud transaction. So we'll use the SMOT function first of all, and our x will be our training data. So if you look at your trained data right now, so our trained data, first column is our time column. So we are not going to use this particular column because we are only going to use these features V1 and V2 up to V28. So we'll be removing this particular feature from our data, and then we'll also remove the last column, which is our target column, which is our class column, which is 31st column. So we'll remove these two columns, and our training data will be from amount till V1. So after declaring our training data, that is our x, now we'll declare the target. So our target is our class variable that we are going to predict either 0 or 1, and the number of neighbors that we want is 5, and then the dupe size is equal to the number of times saved. So once we run this particular code, so we'll get our output as mode output. And if you right now if you look at this mode output, so it will have different attributes, and our data is stored in our data attribute here. So we'll get the data set, which is data frame from this particular attribute. So we'll use this attribute data and we'll store the data set which we have created using this mode method. So once we run this particular line, and if you now click at the credits mode, so we'll get the data set that has around 37,905 entries and around 30 columns. So we have removed the first column, and our last column is our class column. So in the class column, around 60% of the class values will be 0, that is legitimate cases, and 40% of the class values will be 1, which is fraud cases. So now let's change the name of this variable to class with an uppercase C, so that we are according to all of the data types that we have in our, or all of the data frames that we have used till now. So we'll change the first of all the name of our last column, that is our 30th column, to class with an uppercase C using the call names function. So after changing the name of the class, so if you want to now get the percentage of the number of legitimate and fraud cases in our dataset, so we can use the prop table function, and then we'll pass a table function which will get the distribution of the categories present in the class variable. So now you can clearly see that we have around 60% of the legitimate cases and 40% of the fraud cases represented by 1. So now let's plot a scatter plot between V1 and V2 and compare the original dataset with the dataset that we have created using this mode. So this will be our original dataset where our data comes from the training data, that is without smot, and the rest of the code is same as above. So this will be our original scatter plot between V1 and V2 for the training data. So now let's plot a scatter plot for the V1 and V2 in the credits mode data after we have used the credit, or after we have used this mode method on our training data. So you have just have to change your credits mode, the data that you are passing to ggplot function. So once you run this function, you will see that we have added a lot of synthetic points, around 40% of the synthetic points using this mode method. So now if you look at this particular data, you can see the blue points represent class 0, which is the number of fraud legitimate cases, and the red points represent number of fraud cases. And you can see we have not only added points, but we have added synthetic points and not the duplicate points. So these are all the synthetic points that our mode algorithm has added using this mode method. And now after creating this particular data, we'll train our model on this data, and then we'll evaluate the performance of the model on the original test data. So now after making the data set 60 and 40 ratio, so the 60% of the cases now are legitimate cases and 40% of the cases are fraud cases. So now let's build a decision tree on top of this data so that we can predict whether a transaction is fraudulent or legitimate. So we'll be using the rpart package to build classification and regression trees. And we'll use the rpart.plot package to plot the regression trees or the classification trees. So if you have not installed these two packages, you can install using the install.packages command and install the packages for rpart.plot. So once you have installed these packages, you can load it using the library function. And once you load these packages, now we'll use the rpart function to make our classification and regression tree. So if you press F1 here, you will get to the description of this particular, or the documentation of this particular function. So the first argument here is a formula argument where we have to mention the independent and dependent variables. So now we are predicting the class variable. So our class is our independent or the dependent variable which we are going to predict, and we'll use all of the variables except the class variable as independent variables. So these, if you want to write all the variables, you can use a dot instead of writing every single name, and then we use tilde sign to separate our independent and dependent variables. And then we'll pass our data that we want to train our model on. So now our data that we will train our model on is a credits mode data, which is our balance data. So once we run this, we'll create a tree which will predict the class of any particular sample based on all of the variables. So we'll store the tree in cart model variable. So after building a decision tree on this particular data, so now let's plot the decision tree using the rpart.plot function. So we just have to pass our model that we have built, that is our card model, and then we have used extra equals 0. So once we plot this model, we'll get a decision tree. So if you don't want any extra information on the leaves, we write extra equals 0, and type equals 5 will change the display of this plots, the shapes that we have used in this plot, and tweak equals 1.2, it enlarges the text to 120%, so the text will be enlarged by 120%. So this is our decision tree that our model has built. So it will use only one column in our data set, that is V14, and it will use this column to classify different samples. So the particular column's V14th value is greater than minus 2.6, so that sample will be classified, or that transaction will be classified as a legitimate transaction, and if it is less than minus 2.6, so that transaction will be classified as a fraud transaction. So now after building the decision tree, let's now predict values on top of the test set to see how many samples are correctly and incorrectly classified. So we'll use the predict function to predict the values on top of the test set. So we'll use the first method, that the first argument that our predict function takes is our model that we have built, that is our card model. And if you want to know more about this function, you can press F1 here, so it will take you to this particular documentation. So we'll use the card model, that is our machine learning ML model that we have declared above, and then the data that it wants to predict on is our test data, and then we want to predict classes, so it will predict whether a class is 0, that is legitimate case, or class 1, that is fraud transaction. So it will predict on top of the test data, and then we'll compare the predictions with the actual values of the test data that we already have with us, so that we can see what is the distribution of the correctly and incorrectly classified values. So we'll store all the predictions in predicted val variable. So once we have predicted val variable, if you look at how our predicted value variable looks like, so here you can see the first value is 4. If you go to your test data, so here you can also see the first row of the test data is the fourth row of our whole data set. And if you want to see what our model has predicted, so for this particular row, the class value is 0, and our model has also predicted 0. And for this the second row, the class value is 0, and our model has also predicted 0. So if you want to know how many predictions are correct and incorrect according to our model and the actual values, so we'll build a confusion matrix to see how many predictions are correct and incorrect. So let's build a confusion matrix using the caret package. So I'll load the caret package, and then I'll use the confusion matrix function where I'll pass the predicted values first, and then our actual values that are present in our class variable in our test data. So once you run this, you will get the confusion matrix for this particular model. So you can see here our true positives are 5625 and our true negatives are 7. So out of 9 samples that we have in our test data, 7 samples, or the 7 fraudulent cases, were correctly classified by our model that we have built using the credits mode data. That is, after using this mode method, the data that we have built, if we build our model on top of that, so we'll get out of 9 cases that are present in our test data, out of 9 cases, 7 cases which are fraud cases are actually classified. So we'll be able to detect 7 cases out of 9 cases that are present in our test data. And here accuracy is insignificant, but still if you want to see the accuracy, our accuracy is around 98.98%. So now if you use the model, if you build the same model without using more data or on the original trained data, and let's see what is the classification rate or how many samples are incorrectly and correctly classified. So this is our decision tree without using the more data. So now our data is actually the trained data, and I've excluded the first column of my data, that is our time column. So we were only using the variables v1 to v28 and then the amount column, not the time column, and the rest of the code is same. So this is our formula which contain dependent variable, that is class, and independent variables, the rest of the variables that are present in our data set. So we'll use this particular function rpart to create a classification and regression tree, and we'll store the modeling card model, and after that we'll plot the card model. So this is our model, looks like this is a decision tree that our model will use to classify different samples based on the legitimate cases and the fraud cases. So now let's predict on top of the test set and see what is the classification or the misclassification rate. So we'll use the same predict method, and then we'll call the card. In the predict function, we'll mention the first argument as our model, that is our card model, and then we are predicting on the test data. So here also I have excluded the first column. So if you want to exclude the first column of the test data, you can write this. So here it will include all the rows and it will not include the first column, that is our time column of the test data. So test data, how it looks like. So if you want to exclude this particular column because we are not going to predict using this column, so you can write -1 here. And after that we have to write type equals class, so it will predict classes for each sample. So either it will be 0 or 1. So now we have predicted the classes of the test data using our model that was built on the original trained data without using smooth. Now let's look at the confusion matrix. So now if you now look at the confusion matrix, you can see that our true negatives is 6. So out of the 9 samples, we are only able to classify 6 samples if we use the data set that we have, that is our trained data, without using the smooth. So now let's compare these two models using the whole data. So now instead of predicting on the test data, we'll predict on whole of the data set, and that will show us how many samples will be correctly classified by a model that was built on smooth and by a model that was built on the original data, that is unbalanced data. So first let's build our model that was built on the credits mode. So this will be our model that we built on the credits mode. Now let's predict on the whole credit card dataset that will contain all the values. So we'll exclude the first column and then we'll predict the classes, and we'll store the predictions in predict val. And after storing the predictions, let's see the confusion matrix. So in this confusion matrix, out of the 44 samples that we had in our dataset, 40 fraud cases were correctly classified by using the smooth data, or the model that was built on this smooth data, because our true negatives is 1. So these are the samples that was the transactions that were actually fake transactions, 1, and our model is also predicted that these transactions are fake. So out of 44, 40 transactions were actually correctly classified. And now let's build the same model using the model that was built on the trained data or the original data without the balancing factor or this mode. And after creating this data that is built on the original dataset that is unbalanced, and now let's predict on the top of the whole dataset. And now if you build the confusion matrix, so you will see that we have only 35 right now. So we have using this mode, we can easily detect 5 more samples than we can detect using the unbalanced dataset. So that is why using smooth is preferable, because it balances the dataset first and then it predicts. So you can easily see we are able to classify more fraud cases using the smooth, which is 40, instead of using the original dataset that we have, which is unbalanced.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.